Hi, and welcome to Cryo.do's ultimate guide to microservices using Java, Spring, and Docker. Our expert mentor will walk you through a detailed, hands-on course designed to help you master the art of building and deploying microservices, one of the most in-demand skills in today's tech industry. Microservices architecture allows for the creation of scalable and independently deployable services, making it a preferred choice for the modern enterprise application. By combining Java, Spring, and Docker, you'll be able to learn how to efficiently build, deploy, and manage microservices that are robust, scalable, and ready for the cloud. By the end of this coursework, you'll have the knowledge and skills to create your own microservices architecture and take on more advanced challenges with confidence. This is a free certified course which you can download to showcase your newly acquired skills. You can find the link to access your certificate in the description below. Before we begin, make sure to visit our website at www.cryo.do to learn more about our programs and resources. You can find the link in the description below. So get ready to dive into the world of microservices with Java, Spring, and Docker. Let's get started and happy learning!
Hello everyone and welcome to this fourth session of this week. So in this session we will understand a few concepts in configuration, like how can we refresh a configuration once it's updated in the remote source like GitHub, and also we will see how we can encrypt and decrypt a certain configuration information, and before finally we will also see how we can update our Docker configuration to include the configuration server as well. So just like as we discussed earlier, so if there are scenarios where the configuration needs to be updated at runtime, so maybe like once the application is up and a few configuration got updated, so there will be cases where we want our application to pick it up without having to manually restart the entire application server instances. So say for example, there was this recent lockdown by which almost every area got affected, and your food delivery app, right? It could be any of your favorite food delivery app, and they decided that based on the recent lockdown restrictions, we might enable the delivery to that particular location or not. So in order to do that dynamically, it is almost impossible, or I would say not feasible, to kind of have it hard-coded in your application or have it inside your application. And every time you need to update it, you have to restart your server instance. That's not really a good approach. So rather what we can do is we can have all this configuration in the remote repository like how we did now, maybe in GitHub or any of those repository. And whenever there's a change in any of those values, we can update those values and just refresh the configuration inside our application. And in order to do that, Spring gives us an annotation called as refresh scope. So whenever there is a change in the application properties, it will be automatically picked up in our application without having to restart it. So the key consideration over here is that the application can pick up the latest configuration from the config server without having to restart. So that's what we discussed all the while. So that is the key use of it, that we can pick up the values but not require the application to restart. So let's now quickly see the demo of it. So before we do any changes, I first want to quickly stop all the servers that are running. So just go to your console and terminate all the sessions that is running for cards, accounts, and config servers, because we are doing some changes. So it's better that the server is not running in the background. So first is we'll come to the accounts main class, and over here just above, like how we have added the rest of the annotation, we will add one more annotation over here called as refresh scope, and just import this. So similarly, we will also add it as part of the cards main service. So just come to your cards, and just above your cards application, add refresh scope as well. And here it would have automatically imported it for you. So that is step number 1. Now step number 2 is, in order for us know and activate, or rather refresh our data, we would be using something like the actuators, or we would be physically hitting a refresh API to let the application know that it has to fetch the latest configuration. And in order to do that, in your application.properties, which in both your accounts and cards, we need to add a new property. So that is management endpoints.web exposure include all. So what it does is it will be exposing all the API. By default, all of this will be hidden by the actuator. But when you give exposure include all, so what it will do is most of the key APIs which is being used to kind of manage your application will now be able to access through the APIs. Okay. So what is this? We will see it in action in a while. And once we have done that, so just save it, and the same line you also add it to your cards microservice. So just go to the application properties of cards and add it over here. That's it. So we have now added refresh scope to the main class and updated the application properties to include this. So that's it. So now what I would suggest is let's start the config server first. Always remember that going forward, whenever you're starting your microservice, your config server should be started first because that contains all the key config data. So it is always recommended that this is started first. And once this is up, then you can start the cards and accounts microservices. And even when we are going to do the Docker compose, we'll be seeing how we can do that. So once the config server is up, the configure server is up, we can start the accounts. And as I showed in the previous demo, we can also start from here in the top. So I will now start the cards application once my accounts is up. The reason why I'm starting cards after accounts is because I don't want to really overload my RAM and CPU when 2-3 services are starting together. So that's why it's almost like, at least in your personal computer, it's recommended that you start the service one by one, especially when you have like low config or not a great configuration, right? So when you have limited RAM, so it's always better that you start the application one after the other. Yes, so all our services are up, and to test it, we just go back to the postman and we'll just invoke both this config props in cards and accounts. So you see the cards, it is working fine, and even for accounts, when I hit it, it is working fine. So what I will do is, in order to test if it is working fine, we also need to see like what is that what did this property do for us. So in order to look that, what we will do is I'll just come back, I'll just create a new request. So what I will do is inside my accounts microservice server, I will call the actuator. So if you remember, I said actuator is a dependency which we added in Spring Boot while creating the project. So I said it is used mostly for the management and operations of your application. So let me just make a request to this link. You'll see that now it has a lot of options, like it will help you to check what is the health path. So these are various other APIs which is available inside it. So the API which we are interested is this API, localhost 8080 actuator refresh. So what it will do is, so if I'm going to hit this refresh actuator, so it will go and now manually fetch the our latest configuration information for me. But remember that it is a post call, that's why you see the method is not allowed. So ensure that you change the get to post, and now when you hit on send, it will kind of go and make the config server fetch the latest information. It won't return you any data, but internally it would have got the data refreshed from the config server. So we can also test it in action. So what I will do is I will just go to my GitHub page, right? And I will just go to this accounts.properties, and here I will just directly make a change. So what I will do is, you can directly even make a change as we are doing it. So just go, ensure that you're logged into your GitHub, and you just go to the repository where you have your accounts.property. Just click on this edit. And now what I will do is, instead of build version 1, I'll just give it as build version 12. And instead of bank.in, I'll just make it like bank.in.in. And here, instead of Delhi, I'll just make it as Delhi city, just some random changes, right? And now I will just change it. So I'll just give the commit message as test. I will commit it. And once I commit it, so what I will do now is, I know that my configuration is changed now. So what I will do is, I have to first call this refresh now. So I just need to invoke this API once, telling my configuration server that, the data is updated. And you see that, it has picked up all the changes that has been updated. So we had updated the build version. We had whatever is the changes that were there, it has picked up all that. And now if I go and just redo the same request, so if I just do config props, so you see that, whatever changes I did, it's now available. So remember, I have not restarted my microservice. I have not done anything. All I have done is made the changes, came here, I just call the refresh, and we are good to go. So you can label this as refresh. So in future, if you want to call it, you can call it. And similarly, the same thing we can do for cards as well, right? You just go to your cards.property, make any changes, commit it, come back. Instead of 90, 80, 80, you will now change it with 9000. Why? Because it is the actuator for cards is running in a different port. So you run it. So currently we have no change. So it will not show you any data. Like we have not made any change. So that's why even if you call the same API again, there's going to be no change. So same API will come. But once you make any change, so say for example, if I just go here and instead of build version 1, I just make it 100 just for demo purpose. And I just commit it. Now when I come back, I have to first refresh it. So I'll first hit the API, refresh API. And once the refresh API is hit and I come back, and now when I just call this API again, you see that, the build version is updated to 100. So this is the beauty of the refresh scope. So normally or ideally, one question you might have is, what if I have thousands of API, thousands of microservices for which the configurations are updated. So manually, it doesn't make sense that I have to manually hit this API every time, right? So in those kind of scenarios, what we usually do in the industry is we kind of write a shell script, or we can also automate it in Docker Compose. So wherein we can write a script which can be invoked whenever there's a changes in the configuration. So what you can do is, instead of manually calling each of these API every time, you can rather just write a shell script which will kind of call this API automatically through the command prompt, and it will automatically update all the configurations for you. So that was pretty much about the refresh scope. And the final thing which I want you all to see is also the securing the configuration. So as we saw even in our own example, right, for the accounts and cards, we had the scenario where we had to define the username and password for the H2 database console. We gave the username and password in the application.property files. But in real world scenarios, there are also other complex user ID, password, API keys, etc., which sensitive information which kind of needs to be given for the application. But also we have to ensure that they are not being visible to all the users. So in this kind of scenarios, it is important that we kind of encrypt it, and this is where the configuration server comes into play, where it will first encrypt and save the text. It will first encrypt where we can use the config server API to encrypt the text and put it in the config file. And whenever the data is being read, the config server will automatically decrypt it and take the data back to the plain text form. So the advantage is, you as a end user or any application which is accessing the configuration property, they don't really have to bother doing the encryption and decryption themselves. The configuration server and client will take care of the encryption and decryption part behind the scene. So how it works is something I will show you in the demo right now. But for now, just understand that whenever you have any sensitive information in the property files, it is always advisable that you encrypt it and let the configuration server decrypt for you whenever you read it back. So now let's see it quickly. So in order for us to do this encryption decryption, all we need to do is just go to your application.properties of the config server. And we just need to add a single property called as encrypt.key, and we can give a key over here. So this is nothing but just understand that whenever you need to, just like you need a key to lock your unlock your lock, the same way we need to have a key which can be any complex password kind of alphanumeric letters which you can give, and using that and some encryption algorithm, this Spring config server will encrypt the text for you, and using the same key it will decrypt the encrypted text as well. Okay, so it's always recommended that we keep this password or keep this key as strong as possible so no external people can easily detect it. So once we have done that, this is the only thing which we need to add, which is encrypt.key. So once you add it to the config server application properties, save it. And now we just need to start the config server again. So just start the config server. Okay, the server started. Now we'll just go back to the Postman, and over here, now let's try to encrypt something. So what happens is, since the config server is now running, it will be exposing a new API called as encrypt. Okay, so this encrypt is what will help us to encrypt any text that we want, and this will be a post call. So ensure that the type is post, and in the body you can just send the raw text in the text format. Okay, it's not a JSON, it's just a text format. So say for example I want to encrypt hello. Okay, hello and exclamation. When I just send hello in the body, I get a encrypted text like this, right? So what I can do is I can just copy this text. Okay, I'll come back to my GitHub location, and what I will do is I will just go back to this cards.properties, and I will just put it over here, right? And before I put it over here, I just need to tell the configuration server that this is an encrypted text. And how to do that is, you just add this keyword cipher in curly braces and paste the whatever text you have after it. Okay, so I'm just kind of saving this data for cards.properties. So now we are good to go. So how can I test it, right? So testing is the same thing. So if I just come to my same config server and now hit it, continue. So now when I just come to Postman and using the config server, I just hit on cards default. This will give me all the data for cards. And when I hit it, you see that, now the message is coming as hello. We have not decrypted it. I have not done anything over here. So automatically what the config server does is, it will take in the encrypted text. It will use the key which we have defined over here, convert it back to the plain text and send it back to the application consuming it. So this is the beauty of encryption and decryption. So wherein you can secure certain keys from the outer world without having to expose it. So with that said, we have come to end of this section, and before we wrap up, let's now quickly see how we can create the Docker image for config server. So the concept is pretty much the same. So the first thing that we did earlier, which we added this Docker configuration, image configuration. Okay, so this is the step one. And once that is done, all we need to do is just come to your config server, give run as, then you give run configuration, and here you define just like how you did for your cards and thing. So just you need to call run the Spring Boot build image. So what I will do is, I'll just go to config server, run as, run configuration, and inside Maven build, I'll just give a new over here, make it as Spring Boot, and this name I'll give it as config Spring build. So we can also do it from command prompt, but I kind of prefer it having it from here. So it's easy for us to quickly execute it. Apply, and now you can just ensure that you run it for this. So I just give it as selected. So if this location is not selected, just make it as config server, apply, run. And while it is running, I would recommend that you just kill your config server, which is running already, so it doesn't kind of conflicts with anything else. Okay, so I mistakenly killed the console as well, so we just need to again give the Maven build. Okay, just a minute. Repeat. So I accidentally killed the build process, so we'll just re-trigger it again, come back, come to config spring build, run it, and now it will start. So you now see that the Docker has started to create the image for our config server, and once this is created, you will see the image in your local system as well. So while this is getting done, I will also explain you some other thing. So if you remember in the previous section, we had created this Docker compose. So if you remember that we had discussed about this concept of Docker compose, where we can have the same file, or we can have the same script starting various services for us. So now since we have created config server, and config server internally is now kind of dependent on multiple services, accounts and cards is now dependent on config server. We just need to kind of update this old configuration that we had, and we will now do that. So how to do that is, so we'll first quickly do the changes, and then I will explain to you what is happening. So below, meanwhile, you can see that the image is created, and we can also quickly test it. So if you just come to your Docker desktop, come to images, and just refresh it once. So now you see that this config server got created successfully. And how to push it is, we just click on this. So just the way I told, either you can do docker push backend123/config server, or from the command prompt, or you can directly push it from here as well. So I'm just doing it from here to save time. So the first thing that we did is we have added this configuration for config server. So just like how we had for accounts and cards, we now have added config server. So this will be starting first. So we say what is the name of the image. The name of the image is the same thing that you see over here, banking123/config server. So that's what we have given here. The version is latest. And we can also define some additional parameters. Now that we have multiple services running in our local system, we can also kind of define what is the memory limit for each of the container. So in my case, I've just defined it to 800 MB. You are free to choose even a lower number as well, but ensure that it is at least above 500, 600, because below that, your services might stutter a bit. The next is the port number. Since we are giving 8071, I have kept the same thing on both the side, internal as well as external. And this is important since we already defined a bank network. I'm giving the network as bank network. So what are the changes on the accounts? Here also, the changes are, I've added mem limit, right? And after that, I've added this new thing called as depends on config server, just to let my the Docker know that before, this accounts will be depending on this config server. And if config server is not available, it will be failing and trying to restart. So that restart policy also we can define. So wherein we can say that whenever my service is failing due to either the unavailability of a dependency or something else. So what I can do is after a delay of 5 seconds, I can try to start it for 3 times max. Okay. And every time it will be waiting for a window of 120 seconds. Okay. So this is a restart policy. And after that, for my config server, I also have to give two variables. So first thing is I'm defining over here. So I'm defining over here what is the active profile. So in our case, we are just using it as default. So this is, it will fetch all the default configuration properties. And the second thing is I'm defining what is the config server which has to be imported for this particular application. So remember the same thing that we did in the application.properties, right? So if I just go to the application.properties of accounts, so this is what we defined over here as well, right? Spring.profile active and spring.config import optional config server. So the same thing we can also kind of define it in the Docker Compose as well. So what is the advantages at the runtime? Based on the environment, you can change each instance of the accounts to have different property files. So that's what. And also remember one more thing, there everything was lowercase and using dots. Here everything is uppercase and separated by a underscore. So that's the only difference. And same for the cards. So cards also we just added the memory limit, and we have defined the depends on config server, and we have given the deploy restart policy. So in case if it fails, we will try it for 3 attempts. And finally, the environment configuration we have given, take the default environment and import your config server from this port. That's it. And finally, the network is as it is. So that's the only change on the Docker Compose. So now what we will do is we will now start all the 3 microservices using Docker Compose and validate if it is working fine. So to do that, I will just come back to my command prompt, and before you do it, just ensure that you are in the folder where the Docker Compose is present. So you know the command by now. So it is Docker Compose up. So now what happens is, sorry, I just have to verify whether this image is pushed to my remote. And also before starting, just ensure that you delete or clear all the previous container that got created. Okay. And yeah. And also similarly, since we also updated our accounts and cards microservices, we have to also create their images as well. So for the cards, it is quite simple. You just go to the cards application, just go to the cards folder. So always ensure that whatever images you are updating, you have to also create the Docker image for that. So first let's do for cards. So I'll just do a Maven build. And similarly for accounts, you know the drill. What you have to do is, since it is using the Docker file, so first I have to manually create the jar file. So for that, what I will do is I'll just go to run configuration. I'll go to accounts. First I will do a clean install. So that will create the latest jar file for me. So now I have 2 processes running. So one for cards, wherein it is going to create the image directly for me, and for accounts, first I have to create the jar and then I will execute the command to build the image. Okay, so for cards, the image is created successfully, and for the accounts also, the jar is created. So let's go to the Docker image, and if I come to the images now, I just wanted to show you one thing. So when we create multiple images of the same application, you see that the latest got created, but the old one before this, now it's having the tag of none. So as I said earlier, it is important that you delete this because we anyway no longer need it, and it will also consume space. And in case if any containers are running which is using that image, first kill the container and then you can delete the image which is having the tag of none. So always ensure that you have the latest tag only, and all the none tags can be deleted safely. Okay, so that is one thing which I wanted to say. And for the accounts, now once the jar is created, we can go and create the Docker build manually, like just like the way we did last time. Yep. So I'll just go to command prompt. So we'll just give the command to build our images for accounts. So the same like what we did in the previous week. Yep. So it is created as well. So if you come to the Docker desktop, now you'll see that accounts also now we have a none, which is the older one. You can just simply delete it and that's it. So now you have all the latest Docker images created. So once all of this is completed, so the reason, as I said, why you see only for this created a minute ago and all this 42 hours is these two are using build packs, and build packs uses a different time scale. It uses some crazy time scale, but since you do it from Docker file, that's why you see the proper time over here. So now that we have all the images created, we can also push it to the remote repo. So just do a push to hub, even this push to hub, and you can come to the Docker hub and refresh it. Now you'll see that even the config server is added because the last time we pushed it from the desktop. So that's how you see it. And once these cards and accounts are updated, even now you'll see the last pushed as maybe a minute ago or something like that. So it's getting pushed currently. Okay, so while the repositories are getting pushed, we can come to our local and we can start the Docker compose so that our microservices are up using the Docker image. So the command for that is docker compose up. So now you see that first the network got created, then the config server created, then the accounts and cards got created. So all the three containers have now been created. And now you'll see that first it will start the config server and then it will start each of the server, and in between you'll see some errors like connection refused. That is because till your config server is totally up, your application, your accounts and cards will keep on trying to hit it, and that is the reason you see the errors. And since you have defined the restart policy, your Docker compose will keep on trying to restart it again and again till the config server is up. So now we see that the cards is now starting up. Accounts is also starting up. Yeah. So the cards is up now. Accounts is also up. And config server should also be up because without that, these two won't start. So it's time for us to test. How we can test is the same thing. So first we'll test if the config server is up by hitting the same edge, since we are using the same port even for Docker image. So we'll just hit 8071 and we'll see if the cards is returning the data. We see that it is working fine. And similarly, we can also do it for accounts. So this is the first check where we are checking if our configuration server is working fine. It is returning all the data. We can see that it is working fine. And also the one more thing which I wanted to show in the cards is, remember that we had encrypted this value in our GitHub hello. So if you just, okay, so meanwhile the Docker desktop also is showing that the images are updated. So if you just refresh, you'll see that all the images are now up and running. Okay, all the images are now pushed to hub. Yeah, so what I wanted to show is, remember that in the cards.properties we had encrypted this value, and that is still being read properly even from the Docker image as well. Okay, so that shows that the config server is working fine. We can also test if the accounts and cards are working fine by just hitting each of the services. So accounts, I'm able to still get the data. carts, I need to just change the port. Yeah, so carts is also returning the data. And remember, we also had created a new APIs, which is config props, which is just to kind of fetch the data from the config server. Even that is working fine. And same for carts. If I just hit it, it is working fine. So this shows that all my APIs are working fine even after I have integrated it with the Docker Compose. So with that, we have come to end of the session. So as a summary, we can say that we have learned about the basics of configuration management. We have seen how Spring Cloud helps to manage the microservice configuration. We saw how we can set up the config server for our banking microservices, how we can update the Docker configuration after the config server is done. So we saw how we have updated the accounts and cards microservices to read the data. We saw how we can refresh the configuration using refresh scope. And finally, we saw how we can secure the configuration with encryption. So with that, we have completed this session and thank you. Hello everyone and welcome to the 6th week of microservices using Java, Spring and Docker course. In this week, we will be focusing about how we can discover and register a service. So let's quickly recap what we have learned in the previous session. So we saw what are the basics of configuration management in microservice, how we should separate the configuration details from the main application code. We saw how Spring Cloud helps us to manage this microservices configuration. Then we saw what is a Spring Cloud config server and we had it set up. We created a new config server project and set up our config server and read the config details from a GitHub repository as well. Then we saw how can we update the Docker configuration for this config server, like we created our own build image, a Docker image out of this config server. Then finally, we created a config client for accounts and cards microservices, which was consuming this config details from the config server. And finally, we saw what is the refresh scope, how we can update any configuration on the go without having to restart our consuming applications. And finally, we saw how we can encrypt and decrypt the configuration properties as well. And last but not the least, we updated our Docker Compose configuration as well, and we brought up all the 3 services together in order to test it. So in this week, we will be focusing on the following major topics. So the first thing is we will understand what is service discovery and registration. Then we will understand what is the difference between service discovery and load balancer. Then we will get into the actual job of setting up the service discovery, wherein we will create our own service discovery application and wire up our accounts and cards microservices to it. And finally, we'll understand what is a fiend client. So the learning objectives by the end of this week is you'll be able to understand the basics of service discovery and registration, the differences between service discovery and load balancer. We will understand how to configure server-side and client-side service discovery agents, like using certain tools like Eureka Server, Spring Cloud, Load Balancer and Fiend Clients. We'll understand how to update the Docker configuration to reflect the service discovery registration changes. And finally, we'll just look into what is Eureka self-preservation mode, which helps us to avoid false heartbeat alarms. So the first topic of the day, which is service discovery and registration. So microservice, by their definition, just to brush up, they are a bunch of independently running services, and each service will be exposing an API which runs in a dedicated port of a server. So if you just understand or recall from what we had done so far, so whenever we want to access any API from Postman, so generally what we do is we just give localhost :8080/accounts. So that means that your account's microservice is running on the port 8080 of your local server. So there is another set of challenges which we have to consider when we are dealing with so many independent microservices. So the last week, the challenge that we saw was how can we manage the configuration of all the microservices, for which we saw we have this concept of config server. So this week we will understand a different challenge of the microservices. So the following are the practical major questions which comes from the conceptual setup of microservice. How do we locate or discover a microservice? So understand this. Every microservice will be running in a port and will be having an IP. So though for the purpose of our demo, we are running all the microservices within our machine, and we sort of know what is their port number and IP. But if you take a large enterprise where multiple microservices are deployed even across multiple cloud vendors and running in different containers, it becomes kind of tough to really understand which microservice is running where. And the second thing is, how do we share data between these two microservices? So in the Docker Compose, we understood that we can create a logical network wherein we can kind of just share the data between the microservices. But when we look at a larger picture, So also this question arises that if I want to share data between my two different microservices, how can I do it in a better way? The next is, before I deal into this, I also want you to visualize this. Though in our local demo, we are just starting one instances of account and card microservices, but actually in the real world, like any real world applications that you use, there is never a single instance of the application or the server running. So say for example, you're using an application like Facebook. So the service which is dealing with timeline, that's not just one service which is running, right? There'll be like hundreds and thousands of services which are running in the cloud based on the traffic load at that point of time. So the next question comes is, how do I load balance between different microservice instances? So the next question is, how does a new instance of microservices get added to the existing list of microservice instance? So what does it mean? So remember in our earlier discussion, we said Docker also provides us with this option of dynamically scaling up and down based on the demand, right? So we saw that's also one of the important features of microservice. So wherein if the traffic is less, we can have less number of instances. If the traffic is more, we can have more number of instances. So now the question comes, if dynamically say my traffic has gone up suddenly and I have now spun like say 10 instances of accounts microservice. So how will my rest of the microservices know that there are these 10 instances of accounts which is brought up and this is their server address and IP? So this becomes very important, because especially when you want the new instances to also start serving the request which is hitting the microservices. And finally, how do you manage the interaction between microservices? So say I will give you a simple example. I will also kind of implement it to you so that you get a better idea. So assume that from my accounts microservice, I want to also query cards microservice. Okay, so just the same example, right? So assume that I want to have a API which gives me a summary of all the accounts and cards which is held by a customer of a ID. So what I want to do is, from my accounts microservice, I want to call the cards microservice, get all the details of the cards for that particular customer ID. And finally, I want to combine both this data and send it back to the user in a new API, right? So in those kind of scenarios, it becomes important that how do I manage the interaction between my two microservices? So how will my accounts know that where is the cards microservice running, and how will my cards microservice interact with accounts microservice to get send it the data? So these are some of the key challenges of when you're working with multiple microservices. So in short, if I have to summarize it, I'll just say there are three key issues or three areas. So first is, how do new services instances enter into a network and start to serve clients? So because as we say, we can dynamically bring up and down all the instances. So how do we know that we can understand that we can bring up the instance, but how do we ensure that it starts serving the request? So that is one thing. The second thing is, how do services locate each other in a network? So how do they come to know that what is the new instance that is up, what is the instance that is down, what are the ports or dynamic endpoint URLs which we have to invoke for each microservice in a network? The third is how do I load balance between the services when there is more than one microservices running, and also how do I share info between the microservices instance? So these are some of the key practical challenges which we may face while implementing a microservice. And to deal with these potential challenges, we have this concept of service discovery and registration, so which Spring provides us. So it kind of helps us to locate and manage various instances of microservices. So the service discovery and registration function works as follows. There will be a central repository of all network addresses of each registered microservice which will be maintained, and every new microservice or client that needs to be associated with this central repository should register its address with the server, and the server will periodically poll all its clients for their status. So before we dive any further, I'll just quickly want to get over to the whiteboard and just make sure that you understand these challenges properly. So every week, as I said earlier, we will be taking up a few challenges of implementing microservice and see how Spring and other tools helps us to overcome it. So for this week, as I said, as we discussed so far, the challenges as follow. So assume that for my bank application, I have tens and thousands of microservices. So say for accounts, I have container 1, container 2, container 3 running, each in its own port. So maybe 81, 82 and 83. I'm just making up the numbers. Similarly for cards, I will have maybe 2 instances which will maybe running on 84 and 85. And similarly for loans, I may have one instance which is maybe running on 86. So the question now comes is, so just assume that this is my bank, okay, and there is external request coming to this network now. So say for example, I as an end user log into my banking application. So naturally what happens is, from the front end, a request will be triggered to each of these microservices, which will then invoke each of these container to process, and finally it will give me the output. So the first question that comes is, how do all my microservices know how many instances are present of each microservice and where to reach them? So say for example, if my accounts wants to reach cards, how will it know that, what is the port number and IP of the cards microservices that is running? Because if you have seen so far, unless we manually hard code it, there is no way that microservice can communicate with each other so far, right? Even in docker.compose, in the docker compose file that we wrote, we just give the port numbers statically, right? So it is just given that for accounts, if there are 2 instances, these are the port numbers. For cards, if the 2 instances, these are the port. Loans, if 2 instances, these are the port. So I'll quickly show you the docker compose file, so for your better understanding. Yeah, so this is what we created so far, right? So this is the accounts, and here we mentioned what is the port in which it has to run and what is the network, right? And if I want to create a second instance of the same accounts, all I need to do is I just need to copy this, paste it again one more time, change the name of this accounts to maybe accounts 2, because no 2 instances can have the same name. So I'll just change this to accounts 2, and also the port number, I cannot have the same port number, so I have to give some other unique port number here. This is fine still because internally it will use 8080, but for the external world I have to expose it to a different port. So if you see over here, even if I have 10 instances, I kind of have to hard code all the port number over here. But if there is a case wherein one of my instances goes down, or if there is a new instance that comes up dynamically, right? As I said, it's also possible we can orchestrate all this later, like in the cloud using things like Kubernetes. So in those kind of scenarios, my cards or other microservices won't know what is the different instances or which instance up and down. Also, even for the client which is hitting from outside, he or she might not know which server I have to reach over here. So that is one of the key concerns which we have. The second thing is, even between the interaction between the 2 microservices, how can I do it efficiently? How can I pass the data between the 2 microservices? And also, how can I ensure that each microservice can communicate with each other without actually having to remember the IP address and port? And the third thing is, how can I quickly find out if one of my instances is down and I can remove it from my network, just to ensure that there are no further requests going to that particular instance, which might slow down my entire microservices. So these are some of the few questions or key challenges which we have, for which the service discovery and registration help us to deal with the problem. So what the service discovery and registration does is, so basically what it is nothing but, just assume this is your series of microservices instance that is running, right? So between this and your client is nothing but any person who is requesting data from this microservice, right? It could be a postman, it could be your application, anything. So between these two, there is this guy now sitting called as the service discovery and registration function. So what this guy will do is, whenever a client is hitting my server for a request, okay, so say for example it says localhost 8080/accounts, just for example. So my service discovery will then query all the agents which are registered with it and see which is that container which is having this particular parameters, and then route the request over there. Okay. Similarly, whenever a new instance is being formed or whenever a container is starting up, the first thing that container will do is it will register itself with the service discovery and registration, stating that, hey, service discovery server, I'm this particular instance and I'm starting up, and this is my detail. And once I'm up, I'm ready to serve the request. So what happens is, now this registry of this particular service discovery will also have IP of this particular instance. And whenever a new request comes for this particular service, say for accounts, so it will also route this to this particular instance. Also, what my service discovery does is, in case if one of the instances is down due to some reason, maybe a high CPU load or there's a network issue or whatever it is, so it will ensure that there is no further request going to this particular node until it is back again. So to monitor that, what it does is, periodically all the nodes which is connected to this service discovery agent has to send a periodic heartbeat. So heartbeat is nothing just like a ping, right? It just for every threshold period, maybe 30 seconds or 1 minute, it will just send a high kind of a message. Ping is just like a simple message which says that hey, I'm live and I'm working fine. So if a particular node is not sending heartbeat message for more than 3 consecutive times, then your service discovery will mark it as inactive and remove it out of the network till it again starts sending the heartbeat back. So that is another advantage wherein you can avoid certain failures. So in case if there's a high traffic load and lot of requests is going to this container, you can even avoid that. So now you see that this service discovery agent is acting more like a load balancer, where it can also balance the load. It is registering all the clients, and it is doing all the stuff. So this is the beauty of the service discovery and registration agent. So this is the central server that I talked about, so which sits in between your actual microservices and your client, and it kind of acts as a broker between your server and the requester. So coming back to the slide. So the next topic of the day is what is load balancer versus service discovery comparison. I'm sure most of you would have heard this term load balancers, right? So wherein we say if we have more than one instance of a server running and we have a request coming in, we let the load balancer do the kind of load balancing work for us. So what generally happens is, I'll give you a simple example. So say you have this IRCTC website. So when you hit irctc.co.in, what happens is it is not just one server of IRCTC which is running, right? This application will be running in multiple instances, but this address that we give irctc.co.in basically goes and hits your load balancer. So what the load balancer does is it will check the incoming request and it will see which of the server is having load right now. So whichever server is running low on the request, it will route that particular request to that particular server. Also, we can have some other strategy like session stickiness. So if repeated user is coming again and again, instead of routing to a new server, we can still route him or her to the same old server which they requested earlier. So there are a lot of strategies by which you can load balance. We will not get into that. But the concept is load balancer also does a similar job like service discovery. But there are a few limitations, and especially when it comes to microservice architecture, the approach of load balancing does not really work well in that case. In your traditional application, yes, load balancers work wonderful. That's how most of the applications are designed. But when it comes to the microservice architecture, that's where the load balancers really start not showing that much of promise. So let's quickly understand through this table what is the various differences or key comparisons between the load balancer and service discovery. So the first thing is load balancers are complex in nature and not container friendly, because we have to load balancer can be of both the types. It can be hardware as well as software, and also there are a lot of configurations involved in it, and it is not container friendly. Load balancers were designed to work with servers predominantly, so they are not kind of comfortable with this concept of having isolated containers running and going up and down, all those kind of things is not for what the load balancers were made. But however, in case of service discovery, the peer-to-peer communication between service discovery agents happens, so it is quite easy. So even if you have you can also have multiple service discovery agents server running in parallel where they can share the data seamlessly, so it is not that complex in nature. And in the load balancer, there's a challenge that whenever there is a new server or a new instance coming up, you have to manually go and update the IP of that particular server into the load balancer registry. However, in case of service discovery, we don't require to do that because dynamically all the IPs are maintained, and whenever a server goes up or comes down, it gets automatically refreshed. Similarly, for load balancer, there's a centralized bottleneck or risk of failure because your load balancer is sitting in between just as one instance or just a few instances between the request and the server. So even in case of the one of the load balancer fails, that will cause a great traffic bottleneck. But since our service discovery agent is just one of the microservice server again, so we can have n number of instances of discovery agents running between you and the microservices. So that will ensure there is no single point of failure. So because we can have as many microservice instance of the service discovery, and does not cost any money as well, because it is just like any other server instance that runs. And that is the next point. Load balancers also have a lot of licensing cost because load balancers are not free. They are all proprietary software, so you have to pay a ton of licensing cost for them. And for service discovery, the advantage is most of the tools that we use are open source, so it is free. And also another advantage is usually we only do server side load balancing, but in case of service discovery, we can also do client side load balancing, which means that even your clients can cache some of the server information and directly hit the particular server without having to go through the service discovery. So that is also another advantage. And finally, the last challenge is in case of the conventional load balancer, there is a limited horizontal scaling option, meaning you cannot have multiple load balancers added as backup of each other. The reason being the licensing cost, and also it is quite complex to maintain. But service discovery, there's no such limit because these are just singleton microservice instances that are running, so you can have as many service discovery agents as you want. So that was pretty much about this first session. So before we actually start with the service discovery setup for our banking microservices, let's take a break right now and end this session. We will catch up with setting up this configuration in the next session. Thank you. Hello everyone, and welcome to the second session of service discovery and registration. So now let's try to understand how we can set up this service discovery and what are the various tools which you'll be using in this week. So in Spring Cloud, the service discovery and registration can be implemented by many open source tools. So some of them are the Eureka service, which is from the Netflix. We also have something like Apache, Zookeeper, Console, and many other open source tools. But the most famous or the favorite of them is the Eureka service, because this is something which the Netflix had implemented for their own streaming architecture. And once it was successful, they kind of gave it to the Spring Cloud team, which kind of made it open source. And now let's get into the actual setup and understand how we can set up our own config server. So before we go further and get into the actual config, I just want to quickly revise what we have learned so far, because it is important that you understand what we are doing before we actually get into the config side. So what I said is service discovery and registration has two parts, right? So one is you have this server side discovery, like, or the server side discovery and load balancing that happens, and also you have this client side load balancing that happens. Okay, so for the server side, what basically happens is you expose your IP address or the port number of your service discovery port to the outside world. So what happens is, say if my service discovery agent is, say, running on 8070, I'm just making up some port number, right? So you will expose this IP to the outer world, and they would then call inside this maybe accounts. Okay. So what my server side discovery and load balancing agent will do is, once any request hits it, it will check what is the the name of the application that is running, and internally it will check its records, what are the instances that is running this particular application. So say it finds there is a server which is running on some IP and it is running on the port 8080, this accounts instance. So directly it will then check which of the instances free now to handle the request, and it will send this particular request back, right, to the instance and service it. The next part is the service discovery discovery and registration agent will also periodically ping each of the instances which is registered, right? So each of the accounts, cards, whatever microservices are running, so every few seconds or minutes it will check for the heartbeats, and if the heartbeats or the ping messages are not coming from the instances on time, it will then remove that particular instance from the network till the heartbeat is again started to come from them. And finally, the service discovery agent can also be kind of clustered together. It's not necessary that only there will be one server discovery and registration agent. You can have n number of service discovery and registration agent running in parallel. So what happens is, any request that hits this, so even if one service discovery is down, any of the other instance would be able to take it and proceed with it. So that was all about the server side discovery and registration work, which we will do right now. There's also another concept called as client side load balancing, for which we have something called as the Fiend client. So this is the tool which we use. So here the tool that we use is going to be Eureka. So that is something which we use on the server side to implement this, and on the client side we have this Spring Cloud which will be helping us to do it. And for the client side load balancing, we have a tool called as Fiend client. So what the Fiend client basically does is, so wherein whenever the client microservice is requesting for the data from other microservice, it will maintain a local cache. Okay, it will maintain a local cache of all the service instance IPs. So whenever it makes the call for the first time and it will receive a response from the header, it will find out what is the IP and the port of the request of the server which is from which it got the response. And the next time when it makes the call to the same server, it will first check from the cache if that instance detail is available. If so, it will directly make the call to that instance without going to the service discovery first. So say for example, as I said, to the outer world we will be exposing the service discovery IP input. So say maybe for example it is localhost :8070/ whatever, right, accounts cards. But if my client has made the first request to this and it found out that there is a instance which is running on 8080, and that is the one which is serving me accounts, so it will cache that IP over here. So it will say maybe localhost :8080/ accounts. So the next time when again it has to make a call to accounts, it will check in the cache if there is any instance which is already serving 8080 accounts, and if it finds it, it will directly kind of make a call to this without having to first go to service discovery registration. And also the other beauty of this is, since it is not overloading service discovery, the service discovery will run faster. And also the other thing is, this cache will be periodically synced with the service discovery and registration details as well, just to ensure that both are in sync. So that is another beauty of this client side load balancing. And if there is a scenario where it wants to make a call to a microservice, the details of which are not given in the cache, so in this kind of scenario, it goes to the usual route. So it will first hit your service discovery, make the request, get the IP, come back, update it in the cache, and proceed with the processing. Okay, so that was pretty much the summary of what service discovery and registration does. And also it's important that we are aware of the tools that we use to kind of implement this. So the first thing, as I said, we have the Spring Cloud, Netflix, Eureka. So this will be our server which will be used to kind of implement the service discovery. We also have other open source tool like Apache Zookeeper, but that is kind of in a maintenance mode right now. And anyways, from a features perspective, the Eureka server from Netflix is really good, and it's also open source and free as well. The second thing is we also have something called as the Spring Cloud Load Balancer. This will be used on the client side for the load balancing. Okay, so earlier, before the Spring Cloud load balancers was heavily used, we also had something called as Netflix Ribbon. But nowadays, Netflix Ribbon is not maintained well, like it has entered maintenance mode and no new features are added. So that is why now companies are preferring Spring Cloud load balancer. So you might, in case in future, if you might read some articles or documents, you might see that they are using Netflix Ribbon for client side load balancing. So you might have this doubt that why we are not using it. The reason is Ribbon has now entered into maintenance mode, so no new features will be released, and Spring Cloud load balancer is now actively maintained. So that's why in this demo we will be using Spring Cloud load balancer for client side load balancing. And also we will be using one more service from Netflix. So you might wonder why we are using many Netflix products, because Netflix kind of did some unique innovations in this area, and then they kind of open sourced their products to the Spring group. That's why many of these service discovery stuff are associated with Netflix. So the next thing that we will use is the Netflix Fiend client. So what is this Fiend client is? It will be doing all your lookup operations. So I said, right, if we want to cache the data in the client side of the server, so to do all that, we'll be using this Fiend client. So I hope it is now clear. So first we will be using Netflix Eureka to set up a server, the service discovery server. Next we'll use Spring Cloud load balancer agent, which will be kind of doing the load balancer from the client side. And also we will be using Fiend client to do the lookup operation from the client using the local cache. So with that said, now we will first go to the start.spring.io or the Spring Initializer website. So what we have to do here is similar to how we created the config server, we also have to now create a server for the service discovery. Okay, so the name of the server is going to be Eureka server because it is using Eureka. So rest of the configuration remains same as before. Select Java 11 packaging jar, version of Spring Boot 2.7.4 or whatever is the 7 series version that you see now. And the project is Maven and Java. So here instead of config server, I will just give it Eureka server, and here I'll change the name to Eureka server. I still had the window open from the last week, so that's why I'm directly doing the changes over here, or else you can also type it from the scratch, right? And over here, just ensure that you remove all the previous dependencies. You can have the Spring Boot Actuator, that is important because we will be doing a lot of stuff with that. But apart from the Actuator, the first thing that we will add is the Eureka server. So since we are going to use Eureka server, and the second thing that we are going to use is config client. So this is the config client which will be used in order for us to fetch the application configuration. So this config client is nothing but, if you remember from the last week, just how you have the config server, we also need to include the config client. So remember that if you just recollect what we did in the last week for the accounts and cards, we didn't since we already had the application up and running, we added this client manually, right? So here, if you remember, we added this client over here manually. So just a minute. Yeah, so this is how we added it manually. But here, since we are going to create it from the scratch, we can directly add the dependency over here, which is your config client. Okay, why we require config client is from the Eureka server, we will be reading our config servers to fetch some data dynamically. Okay, so this is just to ensure that we are following the same best practices, wherein we store all our configuration details in the GitHub file, and from there we will read a few of the properties. So with that, we are good. So if you just click on the explore and come to pom.xml, you will see that all the dependencies that we added. So here also now we have added the config client, we have the Eureka server, and it adds the test by default. This is for testing, and we are good to go. So now we can just download it, and once the Eureka server is downloaded, you know the drill by now. So just extract the zip, and once you extract the zip, just put it in the same folder where the rest of your project is present. So I'm just pasting it in the same folder where my accounts, cards and config servers are present. So once this is done, so just ensure that inside the Eureka you don't again have another folder. So I'm just moving all the contents to the home folder, right? So you should have this Eureka folder, and once you click it, all this should appear. So the next thing which I want to do is we have to now import this project into our Eclipse. So we'll go to import, we'll have existing Maven, click on this, go there, go to the path where you have put your Eureka server and just select the folder. Automatically the pom.xml will be added. Just click add projects to the existing workset, and that's it. Your Eureka server will now be added. So the first thing that we will do now after adding our project into Eclipse is, remember that I said for the client side load balancing we will be using Spring Cloud and not the ribbon, the Netflix ribbon, right? So we have to add that exclusion over here. So what happens is by default Eureka will use Netflix ribbon in order to do the client side load balancing. But since we are going to use the Spring Cloud, and for which we have also added the dependency over here, now we have to ensure that our Eureka server is not using the Netflix ribbon for doing any client side load balancing. And in order to do that, what I will do is I will just first quickly search where my Eureka server is. So I'll just come to the POM XML of my Eureka server, check where my Eureka server is. I found it over here. So under this, what I need to do is I need to add a exclusion properties which will ensure that this ribbon is kind of excluded from my client side load balancing. So to do that, there is just a bunch of code which I need to add. So let me first quickly add it and then we'll see what it is. So now you can see that I've added this exclusion list to my Netflix Eureka server. So what I've basically done is I've included this exclusion which says that whenever there is this starter ribbon, please exclude it from my project, and in that I'm just providing the group ID and artifact ID. So this is just done to ensure that the Netflix Eureka is not using the Netflix ribbon internally. That is step 1. Step 2 is already something that from the previous week as well. Whenever we create a new kind of like a microservice and we want to also add the build pack configuration in order to create the Docker images. So what you do is under this build property, come below the artifact ID and add this configuration image thing, and here you just specify your username followed by the project artifact ID. So this is something which also you have to do. So this is clear from what we have done so far, and that's it. So this is the only change which you need to do from a pom.xml perspective. So similarly, how you need to add the annotation for config server, similarly even here you need to add the annotation of enabling the Eureka server. So for that, just come to the main class where your Eureka server is present, and over here at the top you just give enable. So what this does is whenever your application starts up, your Spring will read that this particular application wants to act as a Eureka server. So whatever is the dependencies and whatever is the functionalities that is required, it will load it at the runtime. So that's the reason we give this annotation. So similarly, even for config server, if you see in the last week, we saw that we added this enable config server. So what we are doing is we are annotating or telling our Spring Boot that these particular microservice instance will be acting as a Eureka server. So the next thing which you have to do is add a few of the application properties. So the application properties are quite simple. Let me first quickly add it and then we'll go through it. Okay, so we have quickly added a few properties. The first property is the application name, which is Eureka server. So as I said, this is important because whenever you are reading any configuration from config server, this is the name from which it will fetch. The second thing is your config import. So we are just specifying the address of our config server. As I said, a few of the properties will be reading from config file. So that's the reason we have specified it over here. The third is we are saying like, do we want to enable the ribbon? Again, we have given false over here. So this is just to ensure that, the Netflix Eureka is not picking up ribbon under any circumstances. So these are just a few properties which we have updated over here. There are also a few more, but those we'll be updating in our config. So it is easy for our application to read and start from there. And also remember one more thing, just in case like our accounts and for accounts and cards, we created multiple configuration files for each of the environment. So if you just come to our GitHub So you will see that for accounts and cards we created multiple files, like one for dev, prod and on so on. But in case of a Eureka server, we don't really need to create multiple files because we can have the same configuration running for multiple instances. So that is also possible. So just to save some time, I'm just creating one single proper file, which is eureka server.property, which means that this is the default profile. And over here I have defined a few properties for my Eureka server. So one thing I'm telling is my server port will be running in 8070. The instance host name is localhost. The client register with Eureka false, and client fetch registry is false, and client service URL default zone is this hostname :port/Eureka. So what this means is client register with Eureka means, since this is my Eureka server, I don't want this to act as a client and register itself again with Eureka, right? This is not going to host any business application. It's just there to kind of route the request between the client and the server. So that's why this is given as false. And similarly, fetch registry is also false because this is a server and I don't want to fetch registry as a client. So that's the reason this is also false. And what is the default zone or the default URL which I'm expecting my clients to follow is, it will have the hostname :port number /Eureka. So if anyone is setting this, they will be getting all the details from my Eureka server. Okay, so these are the few properties which I need to add. And once I add this to my Eureka server properties, so this I have now uploaded directly in my GitHub repository. So what you can do is, if you want to directly create this file, just go here, add file, create new file. And here you can give the name as Eureka server dot properties. And here you can give all the properties which we saw. Below, just give any commit message like Eureka server committed and just commit it. So once you commit it, you will be able to see the file like this. So this is all the properties which we have given so far. It is not mandatory for this to only be put over here, but since we have already configured the config server, I thought it is better that we have some of the properties over here and some of the properties in the local. So we also kind of have some exercise to recollect what we have learned so far. So coming back, so once we have completed all this, it's time for us to start our Eureka server. So before we start our Eureka server, it is important that we first start the config server, because the Eureka is now depending on config server. So first what I will do is I will start my config server locally. So always remember this drill, right? So whenever we make any changes, we'll first test it using Eclipse in the local. And once everything works fine, we finally kind of create the Docker image out of it and then retest it again at the end of the course using Docker. So now my config server is starting, and once it is up, the next what I will do is I will also start my Eureka server. So config server is up. Now next I'm starting my Eureka server. So since we just have one Eureka server file, that's why we have not given the profile here as dev, default or prod or something like that. Because by default, if there is only like no environment mentioned, your config server will only return your default configuration. So now the Eureka server is up. And as you can see that what we have mentioned in our config server is that we have asked it to start in the 8070 port. So the first thing that we will do is we will go to our Postman. We will create a new request. You can just give the name of the request as Eureka. So now the first check that we will do is we'll go and hit 8070 Eureka, because that is the URL which we have given, right? So if you remember in the GitHub, we have given this property file. So what is the default zone or URL is instance name :port :Eureka /Eureka. So if I hit Eureka and at 8070 port, so I'm expected that I should be getting something. So here it is telling it is not found. So let me just quickly check what is happening. Or let's do one thing. We will go and hit it from our Chrome browser. So this will show us the dashboard. It seems that Eureka didn't start properly. So let me just quickly troubleshoot it. Sorry, there's a small typo in the URL. So you don't need to give Eureka, just give localhost 8070 and hit enter in the Chrome. So this will open a nice Eureka dashboard for you. So remember that we haven't coded any of this. This dashboard is given by Eureka once you kind of install it. So here we can see that there is a section which says instances currently registered with Eureka. No, because we have not yet started our accounts and cards and made it kind of talk with this. So that's why you see as no instances. And also you see other infos like what is the memory available, how many CPUs are there, what is the memory usage and all that stuff. So this is the beauty of Eureka, where you kind of also get a nice dashboard where you can monitor everything easily from a single place without having to code all this, right? So the next part of our exercise is going to be how we can update our accounts and cards microservices in order to register with services discovery with the Eureka server and also do the load balancing stuff, right? And finally, we'll also add the Netflix Fiend client at end of this course, wherein we will ensure that we are able to perform the lookup directly from the client as well. So to do that, what I will do is I'll just come to my accounts applications.properties. So remember that it's not required that you have to always add it in application.property. You can also go and add it to your accounts.properties in the GitHub file as well. But since we have to every time do a check-in, like commit the file and do all that, so that's the reason I'm directly updating it in the application properties. If you're interested, you can also go and kind of update it in the GitHub as well. So that is also works because anyways it will kind of read any of the configuration. So whatever changes we are doing, you are free to kind of also update it over here as well. So once what I need to do now is in my application property of accounts, I need to add a few properties. So let's quickly add it and then I will explain what they are doing. So I've added a few properties over here. So you see that I've added a bunch of Eureka and other stuff. So let's see what they are. So the first that I've added is Eureka client service URL.default zone. So which I say that, this is my client and I want this to connect to this particular Eureka server. So that's why I've given the port number of Eureka and given /Eureka. So internally, it will now go and hit this Eureka server whenever this is up. The second thing which I have given is the instance prefer IP address true, which means that, it will try to communicate with the other instances using their IP address instead of some name or something, because IP addresses tend to get generated dynamically whenever a server is up or down. The second thing is I say client register with Eureka true. As I said earlier, in case of the server, this is client, so it has to be registered with Eureka. That's why it is true. And the last is client fetch registry is also true. Why it is true? Because since it is a client, it is also needs to know the details of all other clients which are registered with it. So that's why we have this fetch registry as true. And after this, we have given a few metadata information like info app name. So this is used like whenever you have in the Actuator, you have this URL for info. So when we hit that, you will get all these details. So you can give any description over here. So since it is accounts microservice, I've given account microservice. Description I've given as bank account and version 1. Okay. So this is just like a metadata. You are free to give whatever information over here. The next property that I've added is management info environment enabled true. So why this is required is, remember in the previous week, we added this property where we say management endpoints web exposure include all. Though this exposes all the URLs of the actuator, there are still some sensitive URLs like environment which is not exposed even after adding this. So that's why we give this property to specifically enable this API as well. What is the use of it? We'll see in the due course of time. And finally, we also added two more properties. One is like endpoint shutdown enable true and management endpoint shutdown enable true. So what this means is, remember I said even when any instances is down or getting shut down, it will inform the Eureka server. So whenever we are shutting down any instance, our instance will tell the Eureka discovery server that I'm good. Hey, I'm shutting down. So please remove me from the list. So that to enable that, we have added these two properties. So now let's start the accounts microservice and see what happens. So remember that as of now, this Eureka dashboard is empty. It is telling no instances available. So let's now start the accounts microservices and see what happens. Okay, so the server is up. So now what we need to do is just come back to your Eureka and just refresh it. So you might see this error that emergency that maybe incorrectly claiming instances when they are not and all that stuff. So this is fine. You can just ignore it for now. There is a concept call of Eureka self-preservation mode during which we will see what is happening. But just give me a minute. It seems the account services started. Okay. Seems the Eureka has not picked it up. So what I'll do is I'll just quickly restart the Eureka server once. So to restart the Eureka server, just go to Eureka server and stop it over here. And once it has stopped, we just restart it once. And just to ensure my accounts is working fine, I'll just go to my accounts and hit the API. So the data is coming. So which means that maybe my Eureka server is not updated properly. So I'll just restart my Eureka server once. So I'll just go run as Java application. So the Eureka server has started. So I can just go back to my Chrome and refresh it. Still it seems it has not picked up the accounts microservice. So just give me a minute. I'll quickly troubleshoot it. So I found the issue that we forgot to somehow add the Eureka. Remember that I said whenever you want to kind of connect to a Eureka client, you also need to add the dependency in the application which is going to connect. So here in the account service, we have not yet added the Eureka client dependency. So that is the issue. So to do that, so after this, you just open your pom.xml of your accounts, and once just locate this dependency of cloud, Spring Framework Cloud, and after this give a new line and paste these properties. So basically what we need to do is we are going to add the Netflix Eureka client as a dependency, and also we are going to add the Fiend client. So both of this is required in order for us to register as a Eureka client. So this is important. So once you do that, the server will automatically build in the bottom. You click on that, you will see that it automatically downloads all the dependencies. So this is the reason why the accounts was not registered with Eureka. So once this is done, all you need to do is just kill your application, accounts application, and just kind of start it again. So to do that, just go to your main application, run as Java, or you could also start it from the top. Anything is fine. So now hopefully our Eureka server should be able to show the accounts application once it is up. So as you keep on adding new functionalities, you will also see in the logs when it starts, all those things will start showing. So now you see that the Eureka data is coming here, and it has now finally started. So now if you just go to the Eureka server, so just go to the Eureka server and refresh, you see that the application accounts is now showing. It is having one instance, and you show this status. So if you click on this, you remember that whatever we gave details over here, right, in the application dot properties of the accounts. So if you just open that, so just come to your resources, application properties. So remember that I said these are just metadata which gives information about your application. The same detail is now what exposed over here. So if you just come to, so what is this host.docker internal? This is nothing but your local host. So what happens is when you install your Docker desktop, internally it creates an alias wherein it says that host.docker.internal is also localhost. So even if you replace this with localhost, it is still fine. It works fine, right? So whatever you gave there comes here, which means that your application or server is up and running. And here you just see the status from there, right? So now we can see that accounts is added to Eureka. So similarly, now let's get the cards also added. So the process is fairly simple. Since we already have the application, we'll just directly update the pom.xml. So what we need to do is just come to the pom.xml. After this cloud, just give enter, paste the configuration, save it. After that, you just go to the application properties. So what I will do is I'll just copy the application properties from my accounts. So it is easy. We don't have to type everything again. So I'll just come over here. I'll copy all this stuff. There will be no change. Just in the info, we have to make the changes. So which we'll do right now. Come over here, paste it. And here we'll just make the changes. So here we'll say cards microservice. That's it. And rest of the details remain same. So once we have done both of these changes, just come to your main class, or you can just even do from here. Right? Just start your cards application. So we have started the cards application, and if you come to your Eureka and just refresh it once, now you see the cards is also automatically added in your table. So that's how we can register any number of clients to our discovery agent. So whenever it gets up, automatically it registers with the Eureka server. And also one more thing to notice, like after every few threshold time, it will be sending a heartbeat to the discovery client agent. Okay. So before starting, you see that it says discovery agent star registering service. So after every few time, it will be kind of sending this heartbeat signal. And in case if your Eureka server gets down, then automatically you will start seeing the console error over here. So that's also a few thing which I wanted you to know. And finally, before we just end this session, I quickly also wanted to show you how this works, right? So whenever there's a graceful shutdown means where you initiate the shutdown, right? So how do we know, if a server has been gracefully shut down? So what you can do is, remember that I said we have included this actuator dependency in our applications, right? So if you go to the actuator of accounts and you search for shutdown, so you see that there is a API which is enabled for shutdown and it is a post call. So what you can do is come to your Postman, just create a new request, okay? And then on the top, you just give it as shutdown, right? And over here, just give localhost colon 8080 slash actuator slash shutdown. Okay, so this is a post call, but you don't really need to give any parameters to it. So once you execute it, you'll get a response that shutting down by. And once that is done, you come to your Eureka, just refresh the server, and you see that the accounts is now gone from the list. So this is how even on graceful shutdown, you can see that the services get automatically deregistered from the list. So this is the beauty of adding these two lines. So with that, we have come into this session. So in the next session, we will understand how we can add the Fiend client, and we'll also add a few functionality into our application, wherein from the accounts microservice, we will be calling the cards microservice in order to return a combined data of both accounts and cards for a given customer ID. Okay, so thanks for attending this session and looking forward to see you in the next session. Bye. Hello everyone and welcome to this third session. In this session, let's try to understand what is the Fiend client all about. So the Netflix Fiend client can be used to communicate between microservices without worrying about the details of REST API. So as I said earlier, it is basically used to perform the lookup of the various microservices between the clients. And in order to showcase the benefits of Fiend client, what we'll do is we'll update our accounts and cards microservices for the following scenario. So for our banking application, this application needs to have a functionality where all the list of cards and the accounts and cards held by a single customer is returned as part of a single API call. So currently what happens is we have accounts API call and cards API call separately, each returning its own data. But instead of that, consider that I want to develop a dashboard which shows all the data together. So I want to have an API which will return all this data together for me. So in this kind of scenario, the Fiend client is best suited. So wherein my accounts does not really have to remember or know where the cards is located. It simply can do a lookup from its local cache and find it. So how it happens and how it does it, we will just look in the demo that we do. And finally, the Fiend client can also combine the accounts and cards microservices to return a single response. So that is the whole purpose of doing this. So now let's get into the details and do it. So the first step of adding the Netflix Fiend client is something which you have already done while adding the Eureka client, which is adding the dependency of this open Fiend right over here. So this is what is the first step where we define the dependency for this client. So also remember one more thing, this we only added for the accounts and it is not really required for your cards. The reason being the cards is not currently going to talk with your accounts, but still we have added it. So in future, if there is a scenario where we make the cards talk with loans or any other microservice, so for that scenario we have added it. But purely from this demo perspective, you just need to add the Netflix Fiend client dependency only on the account service, okay? Because the accounts is going to look up for client and not for the cards microservice and not vice versa. So the next step that we do, if you see, that's almost a pattern, right? Whenever we add any config or Eureka or whatever, so there's more or less a pattern. So first we do add the dependency in the pom.xml, then we get into the main class. So where we say that this is a Fiend client. So in order to enable the Fiend client, we just add enable Fiend clients, and now we need to import it. So just click on this error. It will show you the drop down to import this. So similar to this JPA repository which we created earlier, right, where we had an interface which was kind of talking and doing finding the customer by ID. So similarly, now we have to create an interface for this Netflix Fiend client. So what we will do is we'll first create a package. So what I'll do is I'll just right click on this src mail java new package. So the name of this is going to be n.bank.accounts. This is common. And after that, I'll give service client. Okay. So this is just to ensure that there's no other confusion. So that's why I give it as service client. After that, give finish, and later I just give again new. This time I'll give it as interface, not class, because this is going to be an interface. And the name of this interface is going to be cards theme client. Ensure that you camel case it all properly. The first letter has to be camel case. So totally it's a Pascal case statement. Give finish. Then you will see that this interface gets created. So we will quickly add all the required things over here. So the first thing that we'll add is theme client cards. So this says that this particular service which I'm going to use or interface which I'm going to use is depending on this application, or the client is going to depend on this client application called as cards microservice. Okay, so that's why I've annotated with the theme client. After that, now what I do is I'm going to create a request mapping. So here is where we actually make the API call to this particular cards. So I will say method is request method dot post, value is cards. This is the endpoint URL, and it consumes the request of the type application/JSON. Okay. So what I've done basically is I've just created an API call, or rather added an API call. So for that I've used the request mapping annotation. So there's a typo. Instead of dot, it should be a comma. Yep. So now what I've done basically is I have created this request mapping. I've added this request mapping annotation. I've said make a post call to this API called cards, which consumes, which is of the type application/JSON. So this is the standard JSON call that we make. So once this is done, after that, I have to now say what is the kind of data which I have to get. So for that, since I know that I'm going to get a list of cards, which is nothing but a list of all the credit cards which a customer ID holds. So I would say get card details, and the request body will be of the type customers with the customer. So this is similar to what we have done for our cards as well. So if you check the cards repository, this is similar to what we did. So now let's quickly import all the pending stuff. So request method, then we need to add the request mapping, then we have to add the list, add the request body, and we also need to kind of add this model for cards, right? So we have not yet added the models for cards in our accounts model, so that's why this is now failing. So for that, what you need to do is, it's very simple. Just go to your models of your cards. So just open your cards project, go to your models package. Here you will see that we have already defined a model for our cards, right? So the same thing we can just copy and put it in our. So don't copy everything, just copy from this import, like this import statement. So just because the package will be different, name will be different, that's why we are not copying it. So just copy this entire thing, come into your model, and here just model of your accounts, just come inside the model of the accounts. Since we are going to handle the cards data, we need to now define a class for the cards. So what I'll do is I'll just say new class, the name of this is cards, finish. And inside this, I'm just going to now paste, just remove this and paste this. That's it. So this now ensures that, all my details are present, but also ensure that currently in the second week, we just added the card ID, customer ID, card type, and expiry date. Okay, optionally, we can also add the card number. So to do that, what you need to do is column name. So name of the column. So if you just come to your cards data.sql, you will see that the card number is having the column name of card number, right? Card underscore number. So the same thing you can give over here. So you just say card name, the column name as card name, and private. It is an integer, so you can just give int card number. So your Lombok will take care of all the other mapping. And similarly, you can add the same thing to your cards model as well. So this will ensure that, when your data is returned, even the card number is returned. Okay, so in the second week, just for demo purpose, we didn't include that. We just added a few columns, but you can also include this to ensure that, all the data is returned properly. So once you do that, just come back to your accounts, and here just come to the fiend client, and over here just add, like, import this cards now. So this will work properly now. So just import the cards, and that's it, you're done. So that was the first step that we needed to do. So the next thing that we need to do is the data that we are going to return, or the model we are going to return, is going to be a combination of both the accounts as well as cards, right? So for this, what we need to do is we have to now create a different model altogether. The name of the model, we can just keep it as maybe customer details. So it's up to you. You can give it customer details, or you want to keep it as customer profiles. Anything is fine. So just give that, and inside this, all you need to do is and on the top just add the annotations. So your Lombok will take care of actually fetching the data from accounts and cards and making this response for you. That's it. So once we are done with this, we have completed the part of mapping the the details from cards and getting it into our model. So the final part of this is we have to now wire it into our controller. So the first step which we do as usual is first we have to auto wire. So what auto wire does is it automatically marks this as field getter setter and allows it to use Lombok stuff and JPA. Basically in our case it is Lombok. So just use auto wired. After that we have to add a fiend client. So here it is cards fiend client, and here you can give a name cards. Okay, so once you add it, just import it. So just click on the error and import it. So this error will be gone. And after that, we have to now add a new API call, which will now make this call to cards and fetch the combined information. So it will be a post call. Let's give the name of this API as profile. So whenever I hit profile, I'll be getting the data of both accounts and cards together, right? So public. So I'll give customer details. Or maybe I can just give get customer details at this body. So what I basically done so far is I have created a new API of the name profile. Okay, and whenever I'm calling this API, so I'm expecting that the customer will pass in a request body of the customer ID. And once that is done, now I'll make the call to both my accounts and cards, get the details together and send it back as a response. So let's do it. For first call the accounts microservice. So I'll say accounts find by customer ID, customer dot get customer ID. The next is I also want the list of cards held by the customer. So I would say cards. So automatically you see that this is now populating that. So get card details. So when I send the customer, it will fetch that for me. And once I get all this, so the next thing that happens is I want customer details. So it seems we have to import the list. So just do that. So we imported a wrong list. It should be the Java util. So just remove that. Go back here. Click on this. Just be careful of what you import. So it should be the Java util list. So once you do that, so don't worry about this error. It is coming because we have not yet returned anything. So once we complete the coding, this will be gone. So after that, so what we have done over here is till now we have called the accounts API, got the details. We have called the cards API, got the details. Then we call the customer details model to fit both the accounts and cards detail into that. And once that is done, we will now call this set accounts, where we will set the accounts model into it. And similarly, we'll also set the cards details into it. That's it. So just understand what we have done so far. So I'll just quickly recap what we have done. Okay. Yeah. So now you see the error is gone as well. So it was seems that there was some temporary Eclipse issue. So the issues are resolved now. So we see that there's no errors. And before we proceed, so whenever, even in your real case projects, whenever you see some unknown errors or you see that everything is fine, either the best way is you just click on this accounts, right click on it, take to Maven and update the projects. Just click on these three and just give OK, it will update. Or the other way is you just kind of just delete that line and try to write it again. Or also you can try to just stop, close your Eclipse and open it again. So unless you know that there is some specific syntax issue or some logical issue, this should resolve by itself. So now let's try to quickly understand now what is the benefit of using Fiend so far. So we have not yet started our API, but before even we start, I want you to appreciate the beauty of it, right? So what we have done now is, from our accounts microservice, when we invoke the profile, we first call the accounts microservice, right? So this uses a regular account repository over here, and it will be finding the customer ID based on the query that we find, right? It will get all the accounts detail. And secondly, what it will do is it will also make a call to the cards API through this cards Fiend client and send the customer ID. So what the cards Fiend client does is, so if you just come to the cards Fiend client, so this is nothing but just an interface wherein whatever data it gets, it will just kind of make a post API call to this cards, right, which is having the Fiend client ID of cards, and it will just get the card details with the request body of the customer ID that is being sent. That's it. So here, if you see, nowhere have we mentioned what is the IP, what is the port, of nothing of the cards. We have just said for the application of the named card, make this post API call to this URL/cards, and to it pass this request body of customer ID. So whatever customer ID you send, it will be passed to this card details, and then it will fetch that detail and send it back. And once you are done with that, we basically have this accounts and cards models, so where it will just map each of the column names, and once that is done, it will be taken to the customer detail, where it will just merge both the accounts and card details together. And finally, in our accounts application and the accounts controller, we just define this URL for profile and make the calls to accounts and cards independently. And once you get both the details, we just add it to the customer details, which is nothing but just merging both accounts and cards, and finally return the customer details. So this is the beauty of Netflix Fiend client. So wherein we are not specifying any server or IP of any of the clients. Directly we are just telling, just hit this cards application and do this, right? So internally the Fiend client will determine where it is setting, and if even it's not able to determine, it will go via service discovery and find where is this service sitting now. So now we are good to go and start our application. So just ensure that if there is any running accounts application or running cards application, just kind of kill it, just for a safer side. And also ensure that your Eureka and config are running still. So once, what I'll do is I'll just start my cards and applications and the accounts application now. So first start the cards, and after that you start your accounts as well. So once the card is up, you can start the accounts. Why I'm starting the cards first is because the accounts will be depending on the cards microservice. So that's the reason I'm starting the cards microservice first. So once I do that, my card service is now starting up. Now it's time for me to also start the accounts microservice. Yes, so the cards is up. So what I'll do now is I will just go to my accounts and start it as well. So my accounts application is also starting now. So you see that even my accounts is up now. To validate if everything is up, we can just go back to our Eureka server, which we already have. Just run it. You see that both the accounts and cards are up now. So once this is done, what we need to do is just come to your Postman. So remember that in the previous for second week, we created these two APIs, right? Accounts and cards. So let's test for a scenario where both the customer ID is same, right? So we already, if you remember, we added a few data as well. So if you just come to the Eclipse and you come to the data.sql, you'll see that we added a few customer details. So wherein the same customer or the same customer ID was holding account and also some credit card details. So here in this case, the customer ID is auto generated. So this is 1, this is 2, this is 3, and this is their accounts detail. And similarly, if you come to the cards data.sql, so in this case, we are telling that the customer ID 1 is holding this card, the customer ID 1 is holding this debit card, customer ID 2 is holding this credit card, customer ID 2 is holding this debit card, right? So what we can do now is first come to Postman and query for maybe customer ID 2. So you will see that it is returning two data. So the first data is 806,000, second data is 16,000. Similarly for the cards, I can query my data. You'll see that this person is having the account number 1234. Now let's check if our profile API is working fine. So to do that, all you need to do is just add a new request. In 8080 port, it will be profile. Here you can just say profile field client as header. So in future you can quickly check it. And body, just it should be a post call. So in the body, just add the raw JSON. So the JSON you can just copy from the cards or accounts because it's using the same request body. And now let's run this. So you see that we got data. Let's also verify it whether it's right or not. So the customer 2 has the ID of 1234, and here we see that here also we got 1234, which is having a New Delhi savings account. So that is fine. And for the cards, we got two cards. So one is credit, one is debit. One is 806,000, second is 16,000. So if I come to cards and run for the same customer ID, I see the same thing. Credit card 806,000, debit card 16,000. So which means that our profile is working absolutely perfect. So this is the beauty of your Fiend client. So what we did is, just to repeat, from the accounts microservice, we called the cards microservice, but nowhere in the configuration or in the address have we mentioned that this is the place where you have to make the call. So all we say to the code is that there is a Fiend client with the name of card. That's why we annotated with this. And in that card application, just make a call to this /cards endpoint and get the data. It will be of the type application JSON. So this is the normal REST API. So that's why we do that. And you pass it the customer ID which you receive from your accounts microservice. That's it. So I hope this makes it clear that how all this things works together. So we saw how service discovery works and how how the Fiend client helps us to kind of make the discovery between the service quite seamless. So with that, we have almost reached the end of the course. And before we wind up, it's also important that we kind of just update the Docker images which we have created so far. So before we do that, I'll quickly just shut down all the servers and also recommend that you also do the same, just to save some RAM space, and it makes our Docker builds easier. So I just create all my servers. So the first thing, before we create the Docker images, we have to know what are the applications we have updated and what we have not updated. So if you remember, we have created Eureka. So this will be a new Docker image. Cards and accounts, we just did some minor updates. So it will be this also needs to be recreated. But in this week, we have not touched the config server. So we don't really need to recreate the image of config server. Okay. And also one more thing. And while we do the Docker image, it's also important that you recollect that we also need to update the Docker compose file. Why? Because we have added this new Eureka server, and that will kind of change all the dependencies over here. So last week we added the dependency for config server and also added this depends on config. So this week now we have to add the config for Eureka server and update this depends on config server and also add the Eureka server over here. So what I will do is I will quickly just add the configurations and we will go through what changes we have done in the Docker compose. So as you can see that I have now added the Eureka server configuration. So it is just similar to what we have done so far. So first we say Eureka server, that is the name of the application over here. The next we say which image it has to take. So Bankin123 is our user ID. So whatever is yours. And once we upload this, the name of that would be Eureka server. So don't worry, we have not yet created our image. But while we do that, I thought it's better we just have the config ready. Next we say expose it on the port 8070 and internally also run it on 8070. The network is bank network, and this internally depends on config server. So remember that when we did the Eureka server configuration, we added a few configuration in the GitHub. So that's why it depends on config server. And in the deploy restart policy, we say that whenever there is a failure, just delay for 5 seconds and attempt for 3 times and within the window of 120 seconds. And after that, a few properties which we have updated is we say this is just for the config server. So we say the active profile is default because we just added one file for it. And even if you don't add it, that's fine. And the second is Spring config import. So this is the config server address for starting this Eureka server. And after that, the other change which we did is for accounts and cards under depends on, we have also now added Eureka server after config server, because these both will now depend on Eureka server to register themselves. And under environment, we have added now a new property, Eureka server UR default zone. So remember, in application property we added. So same thing we can also configure from here. So if you remember, right, we in the application dot properties of say accounts, right? So if you just go to accounts application properties, so over here we defined what is the default zone which this client has to connect. So the same thing we can also do it from Docker Compose as well. So when the Docker starts this, it will read from this and set the property directly. So either way is all right. So that's why we have done this. And yeah, the same thing for cards. So we just added the Eureka server and depends on. We have defined the environment for it, like which is the URL which has to connect. That's it. So these are the only changes which we did for Docker Compose. So I think we are good to go. The first step is we have to now create the jar for accounts. So since it is using Docker file, it will be using the old approach. So first I'll right click on this, go to run as, go to run configuration. Over here I will search for my accounts where I have given this clean install, run it. So now you'll see that it will first generate the jar file for accounts. And meanwhile, as it is creating the jar file, probably I could create or update the image for my cards. So for cards, it's quite simple. Just go right click, run as, go to run configuration, and here just search for the configuration where you have given the goals as Spring Boot build image for the cards. So run this. So this also now runs in parallel. I won't really recommend you having multiple images processing running in parallel because it might really slow down your processor. So this computer has 16 GB RAM, so I can afford to have at least like 2 to 3 processes running in parallel. So the next thing which I want to do is I want to now create a new image for Eureka server. So I'll just click on Eureka server, this one. And before you create a Docker image for a new project, always ensure that in pom.xml you have given this image name, because without this it will fail. So I'll just go to Eureka, I'll go to run as, I'll go to run configuration. And over here I see that is no configuration provided. So I'll just go to here again, I'll go to run as, I'll click on Maven build. It will open a window with all this default stuff. So here I will say Spring. And over here I will give the command. So if you remember, the command is, so if you have to create the Docker image for build packs, the command is Spring Boot build image, and we can just give apply. So the next time we can get it from the list, and now you can run it. So we see that for a few of the things it is already completed. So if I just come to my Docker desktop and give refresh, I see that for cards it is ready. So I can just now delete the older version which is having none. So just go here, click on remove, and that's it. And I don't need to do anything for config server because, as I said, we haven't done anything. And now we have to create the image for accounts. So for accounts, it's quite simple. So first go to the folder where your accounts is present and then run the Docker build command. So this will start creating the Docker image from the jar that was created. And you also, if you can verify if that jar was just recently created. So just go to the accounts folder. Inside that, just go to your target and you'll see that this jar was created and it was just recently created. So which means that this is working fine. So now it seems that the Eureka, the accounts image also got created. So if I just come back to my Docker image and refresh it, you see that I see a latest and also none. So this none tag, I can just remove it, and now we are good to go. So as usual, what you can do is in your project or in your day-to-day life, it is like kind of recommended that you just push all of these to the hub. So so just to ensure that it's all updated. So just ensure you push your cards, accounts, and your this thing. And yeah, so since now we have the images ready, we are good to go and start our Docker Compose. So what I will do is I'll come to my accounts. So just ensure that you are in the same folder where the Docker Compose is present. So now to start all the services together, all I need to do is Docker compose up. And remember that this time now we have 4 services running. So we have 2 accounts, we have 1 config, and we have 1 Eureka server. So just ensure that you kind of stop or kill other unwanted applications just to save some space and CPU. So we are good to go. I will just give docker compose up. So you see that now it is now starting config server, Eureka server, cards, accounts. So everything is now getting started. And you see that the container name is accounts because we have added this docker file in the accounts folder. That's why everything is having the prefix of accounts. And also since we said it is each service is depending on either Eureka or config. So that's why you'll see in between there is this connection refused, which means that all your servers are trying to start parallelly, but till your config server and Eureka server is up, it won't be able to start. That's why you see all this interim errors in between. So don't worry about it. Since we have defined the restart policies, after some time it will be up and running in no time. No worries. So we'll just wait for a few minutes. We see that the config server is up now, and now the other servers are also starting. So the cards application is also starting now. Accounts is also starting, and Eureka is also starting. So I think we should be good now. Okay, so all the servers are kind of up now. So we see that there's not much errors in the console, and it's all just doing the heartbeat registration and all that stuff. So I think we can just go to the Postman right now and just check a few services. So first I will just go to accounts just to check if the accounts is up. I see it is up. Next I will do for cards. So remember that I have stopped all the server in my Eclipse. Even for that matter I can close the Eclipse as well. So these are not being served from my Eclipse. This is getting served from my Docker image now. So similarly for config, I can just click on this, like make a call for config server just to see whether it is reading all the details. It is reading fine. Similarly for the accounts, we added this config props. I can click on this. It seems it's working fine. So now we'll come to Eureka, and we'll just kind of do a check on this profile API, which we just recently added. So even this is working fine now. So which means that all our Docker images are up and the compose configuration is working fine. So once all this is done, I would recommend that you just give Control-C and gracefully shut all the containers one. And once everything is stopped, you just come back into your Docker desktop. So you'll see that all is stopped. So once it is stopped, just come to the containers, select all of them and delete it. So this is just to save some space and ensure that you don't really run out of storage in future. And yeah, that's it. So once you are done with all this, we are good to go for this session. So let's quickly summarize what we have learned so far. So far we have learned about the basics of service discovery and registration. We learned about the differences between the service discovery and load balancers. We saw how we can configure the server side and client side service discovery agents using Eureka server, server cloud, Spring Cloud, load balancer and Fiend clients. And we saw how to update the Docker configuration to reflect service discovery and registration changes. And finally, let's also just quickly discuss about this Eureka self-preservation mode and how it allows us to avoid the false heartbeat. So before we wrap up, there's just a small topic which we should discuss, which is the Eureka self-preservation mode. So what this is? So remember when the first time we started our Eureka server, so let me just quickly open the dashboard for you. So now since we have stopped it, that's why I won't be able to refresh it or else it will go. But remember that we saw this, there was error saying that maybe incorrectly claiming instances are not being expired safe and all that stuff. So why these errors are coming is due to the self-preservation mode of Eureka. So what is that? So let's take a simple example. So assume that I have like some clusters of Eureka servers running, which is doing the service discovery work. Okay, so this is my Eureka server 1, this is my Eureka server 10, and in between I have like 9 other services. And now just imagine that I have my accounts microservices which is registered with Eureka, and now I have say like maybe 6 instances of account services which is kind of connecting with this discovery client. So maybe 3 of this in this client and maybe 3 of this in this client, just for hypothetical purpose. So this is my first instance, second instance, third, fourth, 5 and 6. Okay, so what happens is regularly each of these instances will be sending heartbeats to their respective discovery client agent, and if that server determines that one particular agent's instance is not sending heartbeat for last 3 consecutive time, it will then remove that particular instance from the network till it starts to again send back the heartbeat. So that's how the Eureka works normally. So what happens is there may be scenarios where there could be temporary network glitches, right? So maybe the network between the accounts and your Eureka server is down for some reason, or it is slow for some reason. So what happens is, though these instances are up, it may not be able to communicate with your Eureka server, and it may miss that threshold, and your Eureka might mark it as unavailable. But say if the same thing happens for most of the instances, okay? So say for example, 6 went down, then 5 went down, then 4 went down, then suddenly 3 went down, 2 went down, and 1 went down. So in this case, what happens is your Eureka server will mark your entire accounts as unavailable, and even though technically the instances are up, right, but it will stop sending the request just because it's not able to receive any heartbeat from the client because there's some network slowness or whatever it is, right? So in order to prevent this, that is in order to ensure that your Eureka is not totally shutting down the instances, it's not totally shutting down the multiple instances just because there's some network glitch or temporary errors. It will just stop removing the pending servers once a particular threshold is reached. So say for example, I have kept the threshold for maybe 60 or 6 servers as maybe say 85%. So what happens is, once the 4 servers of my particular cluster has went down, it will stop marking these 2 servers as inactive till one of these is back again. So the reason for that is, it will ensure that at least 2 instances in my cluster are able to service the request till the other clusters are back, instead of marking the entire cluster as unavailable. So that whole concept is called as self-preservation mode. So the reason for this is, as I said, there could be some cases where you could have just a temporary network glitch. So say just assume that there was some some calamity in your area, and the servers just went down for a minute. So just for a minute all your servers went down, but what your Eureka server in normal mode will do is, it will just mark the entire instance as unavailable, and just till the heartbeats are starting to come back, it will not route any request to any of these instances. But rather what we can do is, when we set the threshold period, we say that if 85% of the servers are down, then don't mark the other servers as unavailable till one of the servers are back again. So in this case, what happens, even though if these 2 servers are not sending heartbeats anymore, the Eureka server will still send the request to each of them till one of these servers are back again. So in that case, it will start sending to them as well. So this whole concept is called as self-preservation. So don't worry, we don't really have to do anything for this. This is kind of enabled by default. But in case for some reason you want to disable it, then we have a property for it, which is called as server.enable self-preservation, and you can set this to false. So by default it is true, so that's why we don't need to do anything. But if you require, you can also set it to false. Okay, and Eureka will have certain parameters where you can kind of determine how to handle this. So what are the parameters are? One parameter is the lease renewal interval in seconds. So what happens is, it indicates the frequency the client sends heartbeat to the server. You also have the lease expiration duration, where the duration the server waits till it kind of receives the last heartbeat before it can stop an instance. So if I say lease expiration duration is 90 seconds, so it will wait for 90 seconds till the last heartbeat has been received. So after which it will kind of remove that particular instance. And also you can set renewal threshold. So if which means that whatever value I set over here. So if I set to say 0.85, it means that once 85% of my server is down, after that I won't allow the other servers to go down in my cluster, so on and so forth. So we have a few properties in Eureka which kind of helps to configure the self-preservation. So you can go to the documentation of Eureka and to understand it better. And with that, we have now come to end of this session. Thank you for your time, and looking forward to see you in the next week. Bye. Hello everyone, and welcome to this week 7 of Microservices using Java, Spring and Docker course. In this week, we will be focusing on how to build resiliency in our microservices. So let's quickly recap what we have learned in the previous session. So we learned about the basics of service discovery and registration, and we compared them with load balancers. We saw what are the differences between the traditional load balancers and the service discovery and registration functionality. We saw how to configure the server side and client side service discovery agents using Eureka server from Netflix, Spring Cloud load balancer and Netflix Fleeing clients. We saw how can we set up our discovery agent server, how can we do load balancing from the client, and also we saw how can we use Fiend clients to do lookup between the microservices without using IP address or port. Then we saw how to update the Docker configuration to reflect the service discovery and registration changes. We made the changes to our Docker compose file, created a new Docker image for the Eureka server, and we pushed them all to the Docker Hub as well. Finally, we saw a bit about what is Eureka self-preservation mode, which helps us to avoid the false heartbeat alarms. So we saw, like in case of any temporary network outages, how Eureka helps us to not shut down the entire microservices, but keep a few instances running, even if the heartbeats are not coming from them. So in this week, the following are the main points or the table of contents which we'll be discussing. The first is resiliency and its importance. We'll understand what is resiliency and why it is very important in microservices. The second thing is we will also kind of understand what are the different patterns in the resiliency. So to implement resiliency, there are a few tried and tested patterns. So we will be looking into them. And as an exercise, what we will do is we will be implementing these three patterns in our microservices. So first is the circuit breaker pattern, second is the retry pattern, and the third is the rate limiter pattern. There are also other patterns which are there, but from a demo perspective, we'll be implementing these three main patterns. Learning objectives for this week. So by end of this week, you'll be able to understand the basics of resiliency and why it is important for application. We will understand about the patterns of resilience, that is circuit breaker pattern, retry pattern, rate limiter pattern. And we will understand how we can implement resiliency in our banking microservices. So let's get started. The first topic, what is resiliency and its importance? So resiliency basically means that it enables an application to strive to prevent a cascading series of failures and preserve the overall functionality of application. In the real world scenario, the following are some of the factors that can lead to unexpected failures of the server. The first is your network latency, the second is hardware issues, the third is memory or CPU overload. So what we are trying to say over here is resiliency is nothing but just ensuring that if there is any failure in one of your application or some of the depending microservices are failing, it should not bring your entire application to a standstill. Let me give you a simple example. So assume that for our banking application, we are calling the cards microservices from the accounts microservices and then returning the data of combined data back to the user whenever they are calling the /profile API. But assume that the cards microservices is down. So in that case, as of now, if it is down, what you will see is an error, because since the card is down, even the accounts will fail and the /profile API will not work. But when you are building any high performance and very critical applications where you should not be having or showing frequent errors to the user, where it is not desirable to show frequent errors to the user, in those kind of scenarios, it is better that you kind of have some fallback mechanisms wherein even if the card service or any of the depending services are down, instead of directly just returning an error, you just return either the partial data which is available or you show some default data till the actual data is available to you. Okay, so that is the whole concept of resiliency. So as we said last week as well, so every week the pattern that we are going to follow is we will take up a few challenges while implementing microservices and we will see how we can work around them. So far we have seen how can we separate the configuration from the microservice application and keep it in an external repository like GitHub and ensure that whenever we are changing the configuration, it is not affecting our application. Then we understood how can we perform the service discovery and registration for our microservices so that even if the microservices are not aware of each other's location or IP address, they still can communicate with each other efficiently. And also your service discovery can do efficient load balancing based on the capacity of each of the microservice instance. And for this week, topic that we are considering is, so we are kind of building upon the functionalities one after the other. So last week we saw how can we add the discovery and registration pattern between the microservices. So this week we are going to see what if since now our accounts is depending on the cards microservices, what if tomorrow the cards microservices go down due to some reason? It could be network latency or it could be memory or CPU overload in the cards instance. There can be any issues. So we'll try to understand how can we build that resiliency now in our microservices. The same also applies to even your enterprise microservices, wherein if you have a microservice which depends on 10 other microservices, or you have a bunch of microservices running which all together go down due to some temporary network issues. So we will try to understand how we can avoid those kind of scenarios or how we can build some resiliency in our system in those kind of scenarios. So in simple definition or simple word, resiliency just means that even in case of any failures or any adverse events, your application simply does not give up and still returns you some data or gives you a fallback mechanism to show that error in a graceful manner. So what is the importance of resiliency? So it is important to ensure that your microservices are fault tolerant and resilient, because in live production application, so whenever we say live or production, it just means that your application is being used by the end user. So say for example, if I say my application is live, it means that you have hosted your application on the main server which your end users are using. So say for example, if I'm having a site like irctc.co.in. So when I say it is live or it is in production, it means that the site is now hosted on irctc.co.in, and people like you and me would be using that application to book our tickets. So whenever in live production application, if the architecture is not built to withstand or handle failures gracefully, the non-resilient microservices may introduce additional failures and unintentional consequences on overall application. So I'll give you a simple example. So assume that, say for example, you have some 10 microservices running for your application, and a few of them have gone down for some reason. And the remaining 4 microservices are depending on these microservices to kind of get some data or fetch some data and serve your customers. So assume that, one of the microservices which is gone down, it's actually up, but it's kind of serving the request slow because it's taking a lot of time to process because it is having some memory or CPU overutilization. So what happens is when your microservice 4 is down or serving slowly, even microservice 1 has to wait till that request is coming back, and that in turn will reduce the overall speed of your application because your user has to wait till all this process is done and they're getting the data. So imagine if such a scenario happens in a very critical application like say share trading or stock trading application where every second is important. So that is the reason why we have to have resiliency in our application. So ensure that even if some parts of the applications are down, it is not bringing down the entire microservices. So let's quickly check on this resiliency and its importance even on the whiteboard, so this concept really becomes clear to you. So let's quickly recap what we have discussed so far, right? So what we are telling us, so assume that you have your microservices which you have set up for your company, or even for that matter, you can take the example of our own banking microservices, right? So what we have done in the previous week is we created this /profile API, right, in your accounts services. So what the /profile does is it calls 2 microservices, right? So one is it will call your accounts microservices to fetch all the accounts for a particular user ID or a customer ID. And also it calls your cards microservices to fetch all the card numbers for the particular customer ID. And once all this data is ready, it will then serve or return the response to whoever is the client requesting this particular request, right? So let's take this example and let's try to expand our knowledge and understand how we can understand what is resiliency all about. So now we are clear that this /profile API depends on /accounts /cards, and once the data is ready, it will combine both of this data and return it back to the client. Let's take the typical scenario. What if my cards API goes down, right? So I didn't start my microservice, or for some reason this cards has gone down due to some overutilization of memory or whatever it is. So if that is the case, now in this traditional scenario, what happens is whenever somebody calls this /profile, it will make a call to both accounts and cards, and since cards is now down, it will not return any data to this client. You'll just get a 500 error, or you'll just get a server error stating we are unable to proceed the request. However, your end client will not understand why you are not able to send the request, because to him or her, your application should be returning the data at all times, right? So this is scenario 1. Let's take scenario 2. So assume that this cards one is working now, but it is working very, very slowly. So say for example, my cards one has reached maybe 99% of the memory utilization and 99% of CPU utilization, maybe due to some process which is running for a long time in this container. So what happens is whenever anyone hits my /profile, so what happens is so first it will make a call to both your accounts as well as your cards. My accounts will complete the request and return back in maybe a few seconds. But since my cards is taking a long time to process the request, this /profile has to wait for a long time for this to complete this operation and return the request. So what happens is whenever say if say 100 clients are requesting the request for 100 clients are making a call to this /profile. So assume that if for one request this is taking say 2 minutes. So if 100 requests are hitting this /profile at the same time, For every request, it has to wait whatever time this account takes plus 2 minutes, and then combine the data and send it back to the client. So what this will do is this will also put an additional load on my accounts microservices that is running a /profile, because the /profile API has to now deal with this latency of the cards, and which will slow down the overall application. So assume that whoever is launching my application, they will first see the profile API. So now what happens is, whenever my client loads the application, just to load the entire data in the application, it is going to take something like 2.5 minutes or something, which is which is not a very optimal approach of handling this stuff. So that is the reason what we have this concept of resiliency. So wherein what we say is, whenever there is a failure that happens, or there is a slowness in your system that happens, we don't want our application to fail. Okay, so the application shouldn't fail. So that is the kind of the core message of resiliency. And how do we achieve that? So the concept is, assume I'll just give you a few scenarios. So assume, let's take the scenario 1 of our banking application itself. So we say that whenever we call the /profile, it will call 2 services, right? One, it will call accounts. The second, it will call the cards. So the first scenario is, we say due to some network issue or due to some hardware issue or whatever, this cards has totally gone down. Okay. So what we do is, whenever someone makes a call to this profile, if accounts is working fine, we'll just take the data from the accounts, just compile the data for accounts and send it back to the end user. And we will just put the card data as null and send. So for example, in the previous example we saw, right, the last week. So last week, if you remember, we created the /profile API, and whenever we queried it with some customer ID, we got this result. So we got data for accounts. We also got the data for cards. So what we will do is, since card is down, we won't send any data over here. Instead, we'll just send null. Okay. So what we'll do is, for accounts, we will send whatever data that is available. And for cards, in the API response, we'll just send it as null. So this is approach number 1. So this is something which we can do. Approach number 2 is, if say this is not some some very basic information that is retrieved. So maybe just assume that we want to find what is the theme colors that the user has customized for their application. Okay. So just assume that this profile makes a call to accounts, it makes a call to cards, and also it makes a call to the theme API. So this theme API is nothing but it's just similar to the theming that we do in our applications, right? Where we select what is the background color we want, what is the image we want in the background, just those kind of customization options. So assume that now this theme API has gone down. So in that case, we can also have an alternative approach, wherein instead of just returning null, we can tell our API to return some default data by querying some external database. So say for example, by default my application loads in a dark mode. Okay. So what I can do is, instead of just sending null, if my theme API is down, so I can just send the default settings for the dark mode or the light mode, whatever is my default preference, I can send it along with this data. So this is the second approach. So wherein instead of just sending a null data, I can also send some default data with this API. Okay. Let's see the third approach. So what the other approach is that is possible is, so assume that this is my /profile, which is now depending on accounts and cards. Okay. So for some reason, as we discussed, this cards is taking a long time to return data. So say for example, my accounts is returning cards in say maybe 5 seconds. Even this is long time, but just assume it returns me in 0.5 seconds, like half a second. And this card is taking like 2 minutes to process a request, maybe due to some backend DB slowness or memory overload, whatever it is, right? So this, as we discussed earlier, if your profile is going to take 2.5 seconds just to load one data and you're getting 100 requests per second, it's going to slow down your overall system. Because say assume whenever a user opens your application, this is the first API that is going to the server. And if you are going to wait 2.5 minutes just to kind of load this profile data, that's going to give a very bad user experience. So what we can do in this case of scenario is, we can have some timeouts. So wherein what we say is, if I make an API call and that call breaches a threshold. So say for example, I set a rule like, any API call should not take more than maybe 2 seconds to return a data. And if it takes more than 2 seconds to return a data, I can again define a fallback mechanism wherein I will say either I can just return a null data depending on the scenario, or I can return some default data in order to just quickly bring up my API. And behind the scenes, I can write some business logic wherein I can again, after some time, make a call back to the card that called to the API that didn't work and refresh the data on my screen. So this is all the based on the business scenario where you're working. It's never like one size fits all. So depending on the application and the business you're working, you can define all this. But what I'm trying to say is these are the various possibilities or options which are available to you in order to implement this resiliency. So now naturally the question comes as how do we handle it in our microservices? And why this question is more important for microservices? Because see, whenever you develop any microservice, so say for example, even if it is the bank, right? The same as our demo. So a bank will have different departments, you will have accounts, you will have cards, you will have loans, you will have say insurance, you will have your HR department, you will have your marketing and sales department, you will have your operations department, so on and so forth. So again, each of these department will have many microservices exposed, right? So maybe this will have my account, this will have profile, this will have maybe something like settings, so on and so forth. So just imagine if you have I'm just taking a very conservative number. Obviously, many organizations have more than this. So assume that you have just 10 departments in your organization, multiplied by, and each department has say at least 5 microservices. So you have to now manage 50 microservices just for your organization. And this I'm telling is a very conservative number, right? Because obviously any organization will have more than 10 departments, and every department obviously will have more than 5 functionalities or features. So even if you take this conservative number, so I have to now manage 50 microservices. So far we have seen a few challenges how can we make the configuration of this independent from the code? How can we ensure that all these 50 microservices are able to discover and talk to each other and load balance each other? So those issues we have tackled so far. The next challenge that we are going to discuss today is if I have this 50 microservices within my organization, right? So how do I now ensure that all these 50 microservices are kind of running all the time, and even if they are not running all the time, that is if in the case of failures, which will happen in the real life, right? So whenever your application is in production, it's not always that all your microservices instance will be always up 100% of time. There will be cases where due to unforeseen circumstances, a few of the instances might go down. So the challenge or the task that we are going to do in this week is we are going to ensure that even if one of these microservices is not responding or is responding very slowly, how do I ensure the rest of my microservices is not affected by it and my overall application is still able to work fine? And why this is important is, as I said, whenever a microservice goes down or it is performing very slowly, it will have unintended consequences on other microservices because internally they might depend on each other. So that is why this is very important. And the way we deal with it is what is the concept of resiliency all about. And similar to how we saw in the previous weeks, so whenever we have a challenge, our Spring and Java ecosystem also gives us a few tools in order to kind of tackle with it. So when it comes to resiliency, we have a few tools which helps us to kind of build this fault tolerance or resiliency in our application. So in the earlier days, the most favorite tool that was used by all was Netflix Hystrix. So this was a tool which is kind of popular and even still popular to some extent. But Netflix Hystrix has kind of gone into a maintenance mode where they are no longer kind of developing new features in this product. So that's the reason we are not kind of using this in our demo, because I want you guys to learn the latest state-of-art tools. So that's why we will not be focusing on Netflix Hystrix. But rather what we will do is we will be focusing on a tool which is called as Resilience 4J. Okay, so this is the new tool or the latest popular library which is used for fault tolerance in Java. So what happens is Resilience 4J the biggest advantage is it has a very small library footprint, that it does not have a lot of external dependencies. So it makes it quite small and very performant. So that is the greatest advantage which resilience has over Restrix. And also it is actively maintained, which means that every few months or few years you will see some new features added. Whereas now Restrix is in a maintenance mode, and slowly it will be like outdated or decommissioned. So that's deprecated rather. So that is the reason, like, we are going to focus on the Resilience 4J library. And the way that Resilience 4J works is, Resilience 4J gives you certain patterns. Okay, so patterns are nothing but, which you'll be seeing in the next topic. So patterns are nothing but, you can just understand that these are a few methods, standard methods I would say, by which you can handle fault tolerance, right? So this is similar to a real world scenario, right? So I'll just give you a simple example. So assume that, this is your house, okay, and this is the EB or the electrical wire that is coming from the power station, okay. So what happens is, so assume that, this power station has now kind of like, the standard volt which we get in our home, as you know, in India is 220 volts, right? So assume suddenly this, due to some issue, the transmission power line currently suddenly spikes, and now the voltage that comes into your house is 500 volt. If you don't build fault tolerance in your home, what happens? This 500 volt will enter all the electrical appliances in your house, and obviously in no time your entire house will be up in fires, right? Because due to the increased thermal load and all that stuff. So a similar concept also applies here. So what the Resilience 4J does is, it will kind of give you certain patterns or certain methods by which you can ensure that, even if there are certain microservices goes down, or like, they are responding slowly. So how can we handle the fault tolerance in these kind of scenarios? So I hope now it is very clear to you how we are going to, like, what is fault tolerance all about, what is resiliency all about, why it's required. And before we get into the next section, I just want to quickly show you the website of Resilience 4J. So just go to Google and search for Resilience 4J. The first link that you see over here, resilience4j.readme.io. So this is the site or the official documentation library for Resilience 4J. So here you will get a good kind of like, overview of what is Resilience 4J, which also I try to explain. And here you also see a comparison with Netflix Restrix. So whatever we discussed, the same thing is over here as well. And as I said, the way it implements the fault tolerance or resiliency is by providing certain patterns. What are these? We will be seeing in the next slide or the next session. And what I would really recommend is, at the end of this week, just go through this once, so you'll get a better idea of, like, what you're doing, how you're doing, and all the inner details of this working. Also, if you are interested, they also give you kind of like, the ready starter packs, like, or sample codes where you can just understand how to start using Resilience 4J. So if I just click on Spring Boot here, getting started, you'll see that, they have given us a demo like how we can do it. They also given a link to the code. So if you're interested, you can just go through this. Anyways, you'll be seeing it in action. So you'll be like going through all this stuff anyways. But just for your further understanding and better knowledge on the subject, I recommend that, you just go through the documentation of this whenever you get time. So with that, we have come to end of this first session. In the next session, we will understand what are the various patterns by which we can implement resiliency using Resiliency 4J. And we'll be going through them in detail. Thank you. Hello everyone, and welcome to the second session, wherein we'll be talking about the resilience patterns. So as we discussed in the previous session, Resilience 4J implements a few patterns or modules by which you can handle the resiliency in your application. So these patterns are nothing but kind of established they are kind of the best practices and techniques which are implemented to prevent any untoward functioning in case of failures, thus making the work of microservice architect or developer easy. So why this is important, as we already discussed, whenever you are developing any microservices, or if you are an architect who is going to kind of design the entire application, resiliency also should be one of the fundamental core features of your application, wherein you decide, in case if one of the microservices or a bunch of microservices go down, what are the fallback mechanisms or what are the patterns which will be implemented in order to ensure that it's not affecting your entire application. So some of the commonly used resilience patterns are as follows. So one, we have circuit breaker The second is retry pattern. The third is rate limiter. And also we have a few other patterns like bulkhead patterns and so on. So for the purpose of this course, we'll be focusing on these 3 patterns mainly. We'll also implement them in our microservices and see how it works. For your self-learning and like a take-home assignment, you can also just look into other patterns at the end of this course for your own knowledge. So the first pattern which we'll be going to look today is the circuit breaker pattern. And before we get into circuit breaker pattern, I want to quickly get you back to the Resilience 4J website once. So remember that when we showed you the Resilience 4J website, I told that it has few modules or the few patterns which is implemented. So these are those. So it has the circuit breaker pattern, it has the bulkhead pattern. So this is something which we are not covering today. So this is something you can also read in your free time. It also has something like a rate limiter stuff, and it also has something like a cache. So what we'll do is from and commonly used perspective, we'll be looking at circuit breaker, rate limiter and retry, because this is also kind of more relevant to the examples which we are building, and also it is easy for us to kind of visualize how it works. Okay. So the first pattern which we are going to look today is the circuit breaker pattern. So let's come back. To the slide. So what is circuit breaker pattern is nothing but to prevent the services from being overloaded during a suspected failure. The circuit breaker pattern helps in limiting the number of requests to a service based on pre-configured threshold. This ensures that any request to a service which may be down is not sent repeatedly for a longer time and is rather limited once the threshold is reached. So a circuit breaker pattern has basically 3 states. It has closed state, which means the request is kind of going to the service. A half open state, which means a limited set of requests is allowed to be routed. And an open state, which means the requests are not allowed to be routed to that particular microservice. So let's see how circuit breaker pattern works, and let's also implement it in our banking microservice. So first, let's try to understand what the circuit breaker is all about. So let's take the same banking example or our profile example. Why I'm taking the profile example? Because in the previous week, we have implemented this profile in our accounts, which is internally calling both your accounts microservice and also your cards API microservice, right? So let's take the same example and assume that you are the end user who is calling this slash profile API, right? So what happens is, so the same example which we took, so assume the cards API has gone down, okay? And now users are repeatedly calling the slash profile API. So what the circuit breaker does is, for the first request that goes through, it finds that the card is down, okay? The second request comes, it again finds the card is down. So assume that we have sent a threshold. We say that after say maybe 3 requests, if there is an error, just remove this card from being served. So what happens is, say if 3 times this profile is being accessed by some user. So from the 4th request, what happens is your circuit breaker will not make any calls to this API. Okay. And what instead it will do is, you can either return an error directly, or you can also kind of implement a fallback, as we discussed, wherein you can return some default data back to the profile API. So that is kind of the concept of circuit breaker. And in order to understand this even better, let's take an real life example. Why it is called, some of you might think why it is called a circuit breaker, right? So this goes back to our electrical basics, which we have studied in our school and engineering days. Okay. So take the same example of our house, right? So assume this is your house, okay? And you have this electrical wires which comes from your transmission line, right? Or the transformer in your local area. So what basically happens is, the transmission line or the electrical line is set to operate at 220 volt, and all the appliances in your house are expected to work at 220 volt. If there is a spike in the voltage, definitely it will affect all your appliances, and even the wires in your house are not designed to handle more load than this. So take a scenario where due to some reason the transformer in your area just goes bad, and instead of 220 it is now sending say 500 or 550 volt of current, which is more than double and rated capacity. So in normal scenario, if you are not put any circuit breakers or any failure resilience mechanism in your house, this 550 volt of current will simply directly pass through all the appliances in your house and wires in your house, and your house will just go up in the fire, right? So that is the worst case scenario which happens when the resiliency is not there in your house. But in our modern house, or even in house which were built like 50-60 years back, we had this concept of fuse or circuit breaker, right? So I'm sure that most of you would have seen it in the main boards of your house. And these days we call it as MCB, right? So both are the same stuff. So where you would have seen that wherever there is a main electrical board in your house, you would see a series of small flip-flop switches which just trips whenever there is a short circuit, or the current in the main line is high. So what is the fundamental concept of this fuse or circuit breaker or MCB? So basically what it does is, so assume that this is the power that comes from external power, transmission line, and this is the point where it supplies to your house, okay, and in between is where your circuit breaker is sitting, okay. So when I say I close the circuit, it means that this circuit breaker would allow the current to pass. So this is called as I am closing a circuit, meaning I allow the current to pass through from the power transmission line to my house. So this is called as a closed state. Similarly, if say due to some reason the voltage is, so this is in the normal scenario where the current is 220 volt, right? So assume that my current is greater than 220 volt. It can be any number. So in this case, what my circuit breaker does is, it will not allow the current to pass. So this circuit will be in a open state. Okay, so this is called as open state because I'm not closing the power, I'm not closing the circuit. And when I'm not closing the circuit, the current from external transmission line will not reach my house. So this breaks the circuit, right? So this is how the concept of closed and open works in a electrical world. So now let's try to understand the same thing with the help of how the circuit breaker does it. So circuit breaker also has a similar kind of scenario or a similar kind of setup where it uses this open and closed states in order to manage your request flow to the individual microservices. But since this is software, we also can have additional states and additional patterns. So what circuit breaker basically does is, it has 3 states, okay? So the first state is closed state, which is the normal state, or it allows all the requests to pass through, okay? The second state is the open state, wherein it does not allow any request to pass through, okay? And that we also optionally have a third state, which is called as a half open state. So this is kind of a transition state wherein it will just check if what are a few requests which are passing or not. So let's try to understand each of them now. So first is the closed state. So closed state means that all the requests from my /profile will be allowed to pass to both accounts and cards by default. Okay, so this is the initial state wherein I just normally allow all the requests to pass to both my accounts and cards from the profile API. Okay, so this is closed or the normal state where all the requests are allowed to pass. So now assume that I have detected some failure. I come to know that my cards is failing multiple times. So what happens is, from closed state, automatically my circuit breaker will get into open state. So open state means that the circuit breaker now sees that due to some threshold, as I said, we can set a threshold. Threshold is nothing but limit. So assume that I set after 3 attempted failures of any of the service, open the circuit breaker. So what it does is, if I have made 3 calls to my profile and the cards is down for all the 3 times, so now my circuit breaker activates, and what it will do is, it will simply open the circuit or open the pathway, which will ensure that all the requests to my cards are not going now. It will just ensure that all the requests to cards is just simply failed. So that is the open state. The next state that we have is kind of called as an half open state. So what happens in half open state is, periodically my circuit breaker will check if this particular request is up or not, because see, it makes sense, right? So if there is a temporary issue, say due to some network issue, my card has just gone temporarily, or maybe I had a memory overload which has resolved now. If we just permanently keep it in open state, there is no way I'll come to know when my card is up. So what my circuit breaker periodically does is, a small section of request, right, which comes in the future, it will allow a few requests to pass through this cards just to check if it is back up or not. So just for example, so say assume I have 100 requests coming to /profile, and currently my state is in open state. So based on the threshold that we defined, maybe 98% of the request will fail, but my circuit breaker will still allow these 2 requests to pass, right, through the cards just to check whether it has become up or not. And in case if it finds that the cards is back working fine and all the requests are getting processed, it will bring it back to the closed state. Else, if it still finds that my cards is still down, it will again take the state back to the open state. So this is the whole concept. So just to revise, what we can do is we can just also go back to the Resilience4j website where they have also explained the same concept here, right? So initially you will be in the closed state. If the failure rate is above a threshold, it goes to the open state. Then if the failure rate above, if what we do is after a certain period, we allow a few requests to pass through the circuit breaker again. If it passes, well and good, we just again close the state and we say that everything is working fine. But if it's still failing, then what we do is we push it back to the open state. So this is how basically the circuit breaker works. And the way it determines this threshold is either you can have a count based sliding window, which means that you say how many count of APIs or how many counts of the request has to fail in order to trigger all this. Or you can also have a time based sliding window wherein you say after this particular window, let's kind of try to do it again. So that's pretty much about the circuit breaker concepts. I hope it is now clear to you. And before we proceed any further with the code, I just want to quickly tell you where the circuit breaker will be useful, right? So the basic usage of circuit breaker is if you want to fail fast, right? What is meaning of fail fast? You know that there is some failure in your application and you want to quickly ensure that we catch it. So that is these are the scenarios where circuit breaker works. Say for example, I say after 3 repeated failures, I want the circuit to be opened, right? So this is the concept of where we say it is fail fast, because we quickly determine that a particular instance is down, and instead of waiting for it to degrade our entire application, we quickly fail it. So that is called as fail fast. The next advantage or the scenario where we want to quickly we can use this circuit breaker is if there is any transient network issues, or you want to ensure that you also recover quickly, you can use this circuit breaker. So wherein, if you remember, we have this half open state, right? So what is half open state? Even when there is failure, a section of your request or after a particular threshold, a request will still be routed to the service which is failed. So just to check whether it is up or not. And in case if it is up, your entire application will be working fine again. So that is why it is also useful in the scenarios where you want to recover fast. And the third advantage where it will be useful, and this kind of applies to all the circuit breaker patterns, you want to have a graceful handling of failure. So what it means is you can have a fallback mechanism which will ensure that whenever there is a failure detected, you can either return null data, you can either call alternative data sources or API to return some data, or you can return some default data. So the fallback mechanisms is purely up to the business to determine what they require. As I said, if it is not a critical data, you can return some default data like your theme colors or something. If it is a critical data and some data has to be returned, maybe you can call some other alternative or backup APIs to ensure that you get the relevant data. And in case if it is okay, if you don't return the data, like in case of our cards, you can also do null, just return the null data. So that is also fine. So this is how what are the advantages of the circuit breaker pattern. So with that said, now let's jump into the code and understand how to implement the circuit breaker pattern. So before we start, just ensure that all your servers are down. So I've already killed all my servers. So how you can check is just come to your console in the Eclipse at the bottom. And if you see any red button over here, it means the server is up. Just ensure you kill them all. And you should just have clear console, no running servers here for any of the microservices. This is important because as I said, if you are working with a limited RAM and you have a lot of applications running, it's better that you just kind of kill all your unwanted processes when you're working for better experience. So for circuit breaker patterns to be implemented, or for that matter to implement Resilience4j, fortunately we don't require to implement a new server or a central server which will be monitoring all this. We just need to add the dependencies to each of our microservices and we are good to go. So the first thing that we'll do is we'll come into our accounts microservice and we'll go to so this is the same pattern which we do every week, right? So if we are going to add any new feature to our existing microservice, the first thing that we have to do is we have to go to the POM XML and add the dependency for that particular library or service which we are using. So in our case, since we are going to implement Resilience4j, it is important that we add this circuit breaker. So for that, what I will do is after like in my pom.xml, so maybe at the bottom after maybe my project Lombok or Spring Boot, I can just have a new space. And now I need to add a few dependencies. So let me just quickly add it. So over here, I'm just adding a few bunch of data. So what are these? So these are just like standard libraries which we add for Resilience 4J. So first is the Resilience 4J itself. After that, we add inside Resilience 4J, we are adding the circuit breaker. Then we are calling the time limiter, and that's it. And also additionally, this Resilience 4J also requires AOP, aspect oriented programming, which is also a dependency. So that's why we have added this as well. So internally it uses AOP for managing a few stuff. So that's the reason we have added. So just to revise, I have added these 4 dependencies over here. So the first dependency is your Resilience 4J. Internally, Resilience 4J also requires the circuit breaker module. So we have added that. As a circuit breaker module, we are going to implement the time limiter based approach. So I have also added the dependency for time limiter. And also since it uses the AOP concepts, so that's why we have also added the Spring Boot AOP, starter AOP. So that is step number 1. So even in the future patterns, whenever we implement, these are going to be the similar patterns. So first we will, instead of circuit breaker, we will just have the related dependencies installed and the changes will be done accordingly. So if you are able to catch hold of this or understand this, the future patterns will be quite easy for you to understand. So I hope this is clear to you. So after your project Lombok, or you just after the dependency, all the dependencies, you just need to add these 4 dependencies. Okay, so that is step number 1. So these are pretty much the standard syntax which pom.xml offers to you. So that's why I have just quickly copy pasted. You are free to just ensure that you can type it out. I'll just pause the video, type it out, and just ensure you also maintain the same kind of alignment. So it's easy for us to quickly read it whenever we want it. So that is step number 1. So next is step number 2, wherein we directly go into our accounts controller. So src main accounts controller. So why we are coming to accounts controller is, this is where we have defined all our APIs, right? Accounts, config props, profile, and the API which we are interested into like implementing our circuit breaker is the profile API. So you may ask, why not accounts or why not config props? Yes, for sure you can implement on, ideally you should implement it in all the APIs. But the reason why I'm doing specifically for profile now for our demo is, this profile internally calls both your accounts API and also the cards API. So any failure in profile will kind of still hit your accounts and cards internally. So that's the reason I'm doing it for profile. If you're interested, maybe as your personal assignment, you can also implement it for accounts and config props at the end of this course and try it for yourself. So this is going to be a complex implementation, because since profile internally depends on both the cards and accounts, so that's why I'm taking this one. These two are fairly simple, so you'd be able to do it as a personal assignment as well. So the first thing which we do whenever we kind of implement a circuit breaker is, after this profile API declaration, that is @post mapping, we kind of have to add this circuit breaker annotation. So just come to a new line. So add circuit breaker. And before you proceed, just ensure you import it. So just click on this error, you'll see this automatically coming up. How it came up is, since we added it in the POM XML, your Eclipse in the background will run the maven install command, where it will just pull all the latest dependencies which got updated. So that is the beauty of the maven and Eclipse, where it does all these things behind the scenes for you. So the next thing which we want to do is, we want to give a name for this circuit breaker. So what I can give is name equals to, so I can also give the same name as my method. So just for standard purpose, I just give it the same name. Okay. And once I'm done with this, the next step which we have to do is, we have to update the application.properties, where we have to configure a few properties of accounts. So if you remember from our config discussion, either you can do it in the application properties, or you are also free to do it in the GitHub config page. So if you remember, we added all these properties in our GitHub, right? The last week, wherein a couple of weeks back rather. So wherein we defined all the basic application related properties. And even in the previous week, if you remember, for the Eureka servers, we had defined a few properties over here. So you are free to add it over here as well for the accounts.properties. But since, like, just to save some time, where instead of checking in, checking out and doing all that, what I'm doing is I'm just coming to my accounts and adding it to my accounts.property directly. And another reason for doing this is, since we are currently just testing it out, it's better we just have it in local. So in case we have to change some parameters, it becomes easy for us. So I'll be adding a few properties here right now. So just give me a second. I'll just quickly add it and then we'll discuss what it is all about. So I added a few properties over here, all the highlighted ones that you see, which starts with resilience. So these are the properties which I have added right now. So let's understand what are these. So whenever you have to configure anything of resilience, so usually be it for any library, you first give the name of that library. Say for example, if it's Eureka, it starts with Eureka. If it is like, Spring, it starts with Spring. So similarly for resilience, the standard convention like they follow is, it first you give resilience. After that, the module name, which is circuit breaker, since we are going to implement the circuit breaker pattern. And after that, in configuration, we say the default register health indicator is equal to true. So it means that, this circuit breaker would be kind of periodically checking what is the health of all the microservices to which, the requests are made. The second is, we say circuit breaker dot instances dot get customer details. So what is this is? So instances are nothing but all the rules that you have defined or all the circuit breakers that you have defined. So in our case, what we have done is we have just defined one circuit breaker right now. So if you just come to your accounts controller, you see that we have just defined one circuit breaker and the name of that circuit breaker is get customer details. And the same name is what you'll be using over here. So that's why you say instances dot get customer detail, which is the name of that circuit breaker. And we say minimum number of calls is 2. So remember I said there is a threshold which we can set the count based on the count. So what we say is, if 2 calls are failing, from the third call, don't make call to that particular microservice. So that's what this means. The next property which we make is get customer details dot failure rate threshold, which is we have set to 50. So what that means is, if 50% of the calls are failing, right? This 50 over here means the percentage of the calls, right? So if 50% of the calls are failing, just mark that state back to failure, okay? And after that, we have something called wait duration in open state, which is currently we have set to 30,000 milliseconds, which is nothing but 30 seconds. So what it means is, if I have failed, okay, if the calls have failed and I'm not making the calls now to the card service. So what is the period which I have to wait now? So, which means that once my card has failed and I'm not making any calls to the card, what is the minimum time which I have to wait, after which I can again start making calls to the card service in half open state. So that I have currently set to 30 seconds. And why I have set to 30 seconds is because currently the profile API takes like about 3 to 4 seconds, to get the data. And also, if you want to start the accounts application on the whole, it takes like 13 seconds. So just on the safer side, I have set to 30 seconds for our demo purposes. But in real life, these values are purely depends on the application and the business that you're working on. The next is permitted number of calls in half open state. We have set to 2. So remember when I said, once you have a failure, it goes into a closed state. And in closed state, what happens is we wait for a certain threshold, and after that it goes to a half open state. And in half open state, what we do is we set how many requests are allowed in half open. So once my state enters half open state, I will say just make 2 calls or 3 calls to the card services just to check it is up or not. And again, if it fails, it goes back to the open state, and if it passes, it goes back to the closed state. So remember the diagram which we talked about, right? So what we saw in the diagram is what we are doing right now, right? So first we set a failure rate. We say that if 50% of the calls are failing, or if the number of calls that is failing reaches a threshold, go to the open state. In the open state, we determine that, just wait for at least 30 seconds before getting into the half open state. In the half open state, we say that, just pass 2 calls of whatever is reaching you to the half open state, that is to the cards microservice. If it is failing, take it back to the open state. If it is passing, then take it back to the closed state. So this is what we are currently implementing using the properties. So I hope this part is clear to you now. So what I will do is, we need to check it right now. So in order to check it, the best way we can check it is by actually not starting the cards microservice. I hope you understand, right? So we have to check whether our application works fine even when the card is down, right? So that is the reason we have implemented this circuit breaker. So what I will do is, except card, I will start my rest of my servers. So first, always remember this sequence, even for the future weeks. So whenever you start your servers after you have your config and Eureka configured, so always first start your config server, because it has to start serving the configuration during the runtime. So always ensure that you start the config server first. So either you can start from here or from here, it's up to you. So I first start my config server, wait till the config server says that it is started successfully. And once this config server is up, the next server we can start is the Eureka server. So this is to ensure that your service discovery, registration clients and all those things are up again. So next I will start my Eureka server. And once my Eureka server is up, I can start my account servers. So I'm just waiting for the Eureka to start. So generally the config and Eureka won't take much time to start, because the number of dependencies are less and we don't have like a lot of things happening over there. So usually they just start quickly. So you see that Eureka started in 21 seconds. And now and this time will vary depending on your computer speed as well. So it's not like all the services in all the computers will start at the same time. So the next service which you are going to start is the account service. Okay. Just ensure you are not starting the card service, because we want to test if our profile API works even when the card is down. Okay. So don't start your card service. We just have our 3 servers up. So you see over here, we have config server started by Eureka server, and now we have the accounts application starting up. So you see that it has started the GP entity, and it is telling for cards URL is not provided. So what it means is, when the application starts up, initially it won't have the address of cards in the cache. So that is why it is saying that it will go and check it with Eureka. So yeah, you see that accounts is working fine now. And remember, in the last week we have implemented Eureka server. So what we can do is just come to your Eureka server port 8070 and just refresh it. So what this does is, it will give you the summary of all the instances that are running. So remember, we had registered accounts and cards with Eureka. We have not registered config server with Eureka, because config server does not hold any business logic. So we are not going to manage it or look it up from Eureka. So that's why we have not registered it. But you can see that now the accounts is up, and when you click on the info, you see the info coming, which means the account is ready, up and running, and the card is not. We have not started the card, so it is not coming up over here. So this is step number 1. Just ensure that your accounts is up and running. So I hope now you kind of appreciate why we did Eureka in the last week, right? So instead of you manually going and checking the logs or doing all the Postman stuff, you can quickly get the summary of all the services that are running from your Eureka dashboard, which is running in 8070 port. So now what we will do is, we want to check if our circuit breaker that we have implemented is working fine or not. So one way of checking it is, before we even get into the part of checking the circuit breaker, what I want to do is, I will show you something. Okay. So what I will do is, I will go to the accounts actuator. So what is Actuator? Remember, when we are selecting our dependencies, we selected something called as a Spring Boot Actuator, right, for all our microservices. So what it does is, it lets you monitor and manage your application. That's as simple as that. So what we'll do is, Actuator is nothing but it just exposes a set of APIs by which you can manage and observe your application. So when I kind of search this, hit this Actuator URL for my account. So similarly, Actuator is also enabled for rest of the services, right? You can open Actuator for Eureka server, config server, and if cards is up, you can also open the Actuator for card service. Just change the port. So over here, now since we have enabled circuit breaker, if you just search for circuit, you see that there are a bunch of APIs which are now exposed. So one of that API which we are interested in is called the circuit breaker events. So what we can do is we can just copy the circuit breaker events. Okay. Come to our Postman. And here we'll just create a new request. So how do you create a new request? So just click on the collection, click on new add request. At the top, you can just give a name. So I'll just say the name as circuit breaker. So this is just for your reference. Okay. And then over here, I'll just paste this query. And when I hit send, you see that, now it is showing the name, like it is showing a key with the name circuit breaker event and it is empty. Meaning so far there is no event which is triggered, and that's why there is no log which is being maintained. Why this API is useful is whenever we want to monitor if there was any failure or any service error that happened, or if our circuit breaker was triggered, you can call this API and this will tell you the entire list of summary that happened. Okay. So this is the first thing which I wanted to show you. And also the other thing which I wanted to tell you is you can also further add query parameters to it. Meaning if I want to only specify, now this will give you the entire list, right? But what if I just want to know the events for the circuit breaker which we have defined, right? So say for example, I have 10 circuit breakers in my application, but due to some debugging or some cases, I just want to know how many times the circuit breaker get customer details was invoked. So in that kind of scenario, what I have to do is I have to pass a query parameter, that is name equals to customer details. Okay. So this is the query parameter which I will pass. So once you add over here, automatically your Postman will detect that it is a query parameter and it will automatically add it over here as well. So once I hit on send, you see that it's still empty because so far there is no circuit breaker events which got triggered. Okay. So now let's try to trigger a circuit breaker event and see what happens. And before we do that, I just want to quickly refresh your memory. So remember we said the minimum number of calls that has to fail is 2 and the failure threshold is 50%. The wait period is 30 seconds and the permitted number of calls in the half open state is 2, just for your reference. Okay. So what it means is the first time I make a call to my profile, okay, so it will take the normal amount of time and it will fail as usual, without just how it works without circuit breaker, it will work in the same way. The second time I make a call, it will fail in the same way. Like how it will work even without circuit breaker, the same behavior will happen that time also. From the third time is where the magic will happen. Now let's see what happens. Okay, so already we will first hit send. You see that now it is taking some time because it will wait for the cards API, and since cards is down, that's why you see the internal server error and it's throwing 500. The second time I do the same thing, it will wait for some time and it will then throw this 500 internal service error. Now you see. Now the next time I do, now let's see the logs what happens. So if I come to my Chrome browser or even to my Postman and come to the circuit breaker URL, right? So this actuator / circuit breaker event with the query parameter of get customer detail. This get customer detail is the name of the circuit breaker which we had defined over in our accounts controller, this one, right? So now if I earlier remember this was returning an empty event. So now when I do send, you will see that it has generated a list of events. So let's see what are these. So the first event is the first time I made a call, it gave me an error because the cards was down. The second time the type was again error because the card was down. The third time you see now the state has changed. It is telling that failure rate exited, meaning in our application.properties we had set that if minimum 2 number of calls fails, you activate the circuit breaker. So now what happens is, since my 2 calls have already failed with the type error, so the third time when the same API call happens, I will not allow my call to go to card service. I will go to a closed state. That's why it is saying failure rate exited. And after that, when I make the future calls, so it will now tell it is a state transition, meaning it goes to a from a closed state to an open state because it has wait for 30 seconds. And after that, it again goes to an open state to check whether after the third call, since now it knows that this cards microservices is down now, it will permanently open the circuit and it will wait for the threshold time till my circuit breaker will again check if I can permit a few calls to my half open state. So now since we have waited for more than 30 seconds, now when I make a call again, this time it will again make a call to a cards API. And now if I check my circuit breaker log again, you will see that Yeah. So you see that, since my card is still down, you'll see that, it is telling it is still as not permitted. Why? Because even now, after the threshold period and when my state is in half open state, the calls to my cards microservices is not going through, and that's why it is still in open state, and it is not allowing me to make the call to the card state. Okay. So this is the very crude implementation of circuit breaker, but it really does not solve a problem in all aspects. So in one aspect, it is solving that, if it finds that the card microservice is failing, it will going for after the threshold, it is not allowing it the calls to go to it. That is fine. But still, if you see, I'm not getting a response, right? I'm just getting a kind of failure. So if I call my microservice profile, you see that I'm not getting data even for my accounts. I'm just getting just a 500 error, which is also something which we have to handle. And in order to handle that, we have something called as a fallback mechanism. So what is fallback mechanism is, so in case when I determine that, there is some error in my one of the microservices, so instead of just returning the error and closing the connection, I can kind of also return some default data just to ensure the API itself does not fail or the end customer gets some data. So how to do that is very simple. So the first step is, in my circuit breaker, I add one more parameter or argument called as fallback method. Okay. And this method name can be similar to this. So what I can say is get customer details fallback. Okay. So this is the fallback mechanism method which we are determining, and the same which we are going to invoke. And you have the next step we have to do is we have to also create a new method with the same name, which will be invoked whenever there is a error, okay, or a failure. So what I'll do is, after my customer profile, I'll create a new method. So what I'll do is, I'll say private. Why private? Because I'm not exposing it to other classes. It's going to be internal implementation. So private details, the same name what we gave up, and this, the argument that will be passed is the same customers. So I'll say, so whatever you see over here, right, the same thing will also be the argument over here. And since it also throws you an error, so you have to also pass the error which was thrown. So we say T throwable, which means the error that got passed. Okay. So that's it. So now here you're free to kind of now write the business logic which is required. And before you proceed, just ensure you import customers and throwable. So what we do is, for throwable, so just for temporary purpose, I am returning, just to add the import, I'm just doing return empty. So you'll see an error over here. So don't worry, once we implement the logic, it will be gone. So the first step that I want to do is, so now we assume that, the card service is down. So what we first do is, we know the accounts is up. So in this case, we say, we will do the same thing over here. So we'll just copy it and we'll paste it. So what we are doing is, we are basically calling the accounts model or the accounts repository and getting the data from the accounts, right? And now we won't call the cards data, okay? Since we know that since the card is down, we will just take the accounts data, set it to the customer details, and we will return this customer details as we do above. Okay. So just to recap what we have done. So what we are basically doing in customer details, the original method is, whenever someone calls the profile, we make a call to accounts, to the accounts API. We make a call to the cards API. We get both the data and we set it into our customer details model, and we return this customer detail model back as a response. But now, since we know that the cards API is failing, so why we know that cards API is failing is, we have in our example, we are specifically not bringing up the cards, right? So we know the cards is failing. But in the runtime, it is not always the case that you will know which API will fail. So in that kind of scenario, what you do is, based on the error you get or based on the service you get, you will make the changes. That's why I said this part is purely on the business. But just to show you the beauty of it, I am specifically assuming that the cards is down. So since card is down, what I'm doing is, I'm just making the call to accounts microservice which is up, getting the data from accounts microservice and setting it in my customer details model and returning just the customer detail back to the client. So in this case, what happens is, my card details will be set to null. Okay. So I hope you got this point, because even for the future patterns that we will be implementing, which is retry and rate limiter, the same logic will be used. Only thing is the implementation over here will change. Okay. So I hope this is clear to you now. And since we have added this new method, what I need to do is I will just quickly stop and start my accounts application again. So I'll just stop it and I'll just start the application again. So I'll just start my accounts application again. So your accounts is started now. So let's try to now hit our profile API and see what happens. Okay. So since this is again starting, it will start from the scratch. It will check, like, it will wait for the first two APIs to fail. So that's why if I come to my Actuator now, you'll see everything is kind of empty because we have restarted the server. So now let's try to check it again. So first I will go to my profile, hit for the first time. I'll get error, which is expected, because for the first two kind of calls, once the cards is not going through, I'll get an error, like the circuit breaker will determine that it's an error. But since we said, like, we are going to implement a fallback mechanism, which means that, even if there's an error with the card microservice, I'm going to invoke this fallback method. So that is why you see now the first time itself it has succeeded. And since my card has a failure or error, that's why I have not got the data from here, because here we are not setting any data for the customer. We are just setting it for the accounts and sending it back. So similarly, if you want to set some default data, you can also do. So here, like the way we do it for here, like instead of this cards, you can set some, like, random data and send it back. But since this is a banking application, we don't want to set any default data. That's why we are returning null, meaning to the customer either the data is not present or there is some error. Okay. So this is the beauty of fallback. So now you see that how many number of times I hit the API. This cards will now be still returning null, but I'll be getting the data for account. And if I change the parameters over here, so instead of 2, if I send 1, it still works, right? So that is the beauty. So what is the fallback mechanism is, if one of the services fail, it will still return you the data for other microservices. And you can also implement further business logic over here, where you can either return empty data, you can query some other API to get the data, and so on and so forth. So I hope with that you are now clear how circuit breaker pattern is implemented. So in the future sections, we will next check how rate limiter works and how retry pattern works. They also have similar mechanisms, only the logic changes and the scenario changes where they need to be implemented. But overall, if you see, this is the pattern that we will follow even for the future patterns. So thank you. With that, we have come to end of this second session, and I'm looking forward to see you in the next session. Bye. Hello everyone, and welcome to this third session where we'll be looking into the retry pattern. So the retry pattern is preferred to handle temporary failures. It is also similar to circuit breaker, but here the concept is it retries a failed request for a specific number of times till the microservice is up to service the request. So unlike your circuit breaker, where it simply just stops the request from flowing into circuit breaker, from flowing into the failed microservice, and waits for a certain time and just allows a few requests to pass. So here the concept is like it just keeps on trying to a particular failed request for number of times, and it will basically check if that service is up again or not. So retry pattern is generally used for transient failures. What we mean by transient failures is kind of failures which self-correct after a certain period of time. So for example, like memory overload, slowness in database server, etc. So these kind of issues are kind of transient or temporary, wherein like if your RAM is now overloaded or your CPU is overloaded, over the time or after some time, normally it will come down once that blocking process is completed. Or similarly, if there's a network failure, slowness, or your database server is fully loaded, even these kind of failures normally tend to resolve after a certain period of time. So a retry pattern basically has 3 strategies or 3 things which you can configure. So one thing is cancel, where it says you return exception if the failure isn't temporary, meaning, so in our case, the card service is permanently down, like we have not started the card service. So in that kind of scenario, it just says cancel, means you just return the exception. The next one is retry, where we say if it is a rare exception or it is like, just happening very infrequently, then you just retry after some time. And retry after delay means you just wait for some time before retrying. Why it makes sense is, why we have retry after delay is, so we just simply keep on retrying. It also kind of puts load on your network. So it's better that, just try to retry it after some delay. So you just expect after that delay, maybe the service is up. So that's why we have this retry after delay as well. So now let's try to look into retry pattern a bit in detail and implement it in our banking microservices. So if I come back to my Resilience 4J website on the retry, so you see from the documentation, this is the same thing which we discussed. And also you see that, from the application properties, we are able to kind of configure these many number of properties which is available. So we will be doing a few of that as well. So just to give you kind of an overview. So this has a few code and other things. So whenever you're free, maybe you can just have a look, understand how it works, and you can see at this retry example as well. So coming back to the whiteboard. So what we will do is we'll first try to conceptually understand, just ensure that we understand how retry works, so that it will make us life easier when we are implementing the code, right? So as we discussed, retry pattern is nothing but it just helps you to kind of just retry to a service for a particular number of time, and if it still fails, it will just mark it as cancel or fail state. But if not, we can again bring that microservice back into the network. Okay, so the same logic also applies over here. So assume that you have this profile which depends on accounts and cards, and you have your user who is making the request. So what happens in retry is, so assume that my card is now down temporarily. Okay, so my retry pattern will keep on trying to this card. We can have some threshold defined. So say for example, I can say max attempt. So I say attempt for at least 5 times. Okay, so it will keep trying to this card microservice for 5 times. And what it will do is, we can also define the wait period between each of the retries. So I can say between each try, you have a wait period of say maybe 15 seconds or 5 seconds, depending on the scenario that you require. And also we can also have additional few scenarios or additional few properties defined. So wherein I can say, I can also kind of configure when I want to retry and when I don't want to retry. What I mean by that is, so say for example, I know that my card is, now when I retry, when I hit card service, I'll get error, right? So normally we get error that it is 404 not found, because this card service itself is not up, so that we will get this 404 error saying that the card itself is down. So I can also configure my retry pattern to say to execute only for certain kind of errors and not retry for certain kind of errors. Meaning, say if my server is down, okay, in this kind of scenario, it doesn't make sense for me to just keep on trying again and again, because I know their server is down. So what I will do is, I'll just mark the server as failure and get about with my business and retry after certain period of time. But there are also certain scenarios where I would like to keep on trying, or I would just kind of just ignore those kind of failures and just keep on trying. So what I mean by that is, so say for example, I have maybe a 500 error exception, or maybe I have timeout exception, something like that. So I know in these kind of scenarios, these are errors which might resolve after a certain period of time, because internally they are happening due to certain timeout issues or something. So if I have a timeout issue or something like that, so what I can do is, in this kind of scenario, I can ask, or I can configure my retry pattern to keep trying. But in certain scenarios, where I get server down, or I have some code issues like null pointer exceptions and so on, I know that this will not self-resolve. So in these kind of scenarios, I will simply mark this service as failure, and I will just invoke my fallback mechanism. So this is the concept of retry mechanism. So I hope that is clear to you, and let's see it in code right now. So this also works with the similar pattern like what we did for circuit breaker. The same logic applies even here as well. So what I need to do now is, the first thing that we do is, we'll just come, since we have already added the POM dependencies and other things for the cards. So I'll just quickly go through. So since in the pom.xml, in the last session, we added the dependencies for Resilience 4J already. So that's the reason we don't really need to add any further dependencies right now. So we are good to go from that perspective. So we have added all the requisite dependencies that is required. So for retry and rate limiter, we don't really require to touch the POM XML again. What we need to do is we just need to update and modify the, like, first comment out the circuit breaker related configuration that we made, and we will add the retry stuff right now. So it is very simple. So what we need to do is first just comment this circuit breaker. So a shortcut to comment is you can just press control and / together. It will add this 2/, or you can manually add this 2/ as well. It's up to you. The next thing which I want to do is, before I do anything, I just want to copy this arguments, because this arguments is going to be the same for all the patterns. So the next thing that I want to do is, since I'm going to implement a retry pattern right now, I will give @, and before I do that, please ensure that your accounts service is down. Like, you just bring down your account server, so that we can start it together later after all the changes are done. So the first thing, just like @ circuit breaker, I will now give @ retry, because that is a pattern which we are using. And after that, just like how we give the parameters above, the same parameters I'll give for this, because as I said, we are going to reuse the same code for all the patterns, and you have to ensure that you import this retry. And once you do that, that's it. So you see now, the code is really simple. Since we have already implemented for circuit breaker, the same code also now applies for retry as well. So just to refresh your memory and recap what we did for circuit breaker, let's see it from a retry perspective. So the first thing what I've done is, in my API which I want to implement this retry. Okay, so since we are taking profile, because internally it calls both the accounts and cards, so that's the reason I'm implementing this retry pattern for profile. But you're also free to try it on accounts or config props or any of the API that you want. Okay, so the first step is we just add this retry annotation, and inside that we first say what is the instance name. So here we are giving the instance name as get customer detail, because that is the name of my method as well. So it really becomes easy for us to know for which API am I doing it, right? The second thing is we have also defined the fallback method. So just as we saw in the previous demo, if you don't give the fallback, the API will fail. But we don't want the API to fail and at least return some data which is available. So that's why we have also added the fallback method. So what happens in fallback method is you just give a name, and below that you implement that method, wherein it still gets the same customer request body which this original method receives. So this still is passed to that, and along with that also the exception. And this is where, like, you remember from the whiteboard discussion, we said that we can also have certain scenarios determined for a retry. So I said, say if your error type is maybe like a timeout exception, or if your error type is say maybe like a null pointer exception. So you can kind of determine or configure your retry in such a way that whenever you have timeout related exception, you can ignore that exception and still keep trying. And when you have exceptions like null pointer exceptions, which we know will not resolve on its own, because this requires manual human intervention to manually debug and see where the error is and fix the code. So in these kind of scenarios, I will simply mark it as failure and invoke my fallback mechanism automatically. So this is the concept, for which we require this throwability, wherein you can determine what is the type of error that you got, and based on the business logic you can implement all that. So for purpose of our demo, we are just kind of taking the accounts microservice data and putting it in the customer details and returning it. So we want to ensure even if the card is down, we at least send the accounts detail back to the user. Okay, and similar to what we did in the previous demo, we will also update the application.properties. So in the previous demo, we added the properties for circuit breaker. So similarly, even for retry, we need to add a couple of properties. So let's see what are these. So either you can just comment this out like this, or you can also keep it. It's up to you. So it will not impact anything. So if you want to comment it, just add hash at the start, or you can just select all of these together and press control / together. It will automatically add the hash in front of it. So what I will do is, since I have to put for resilience, let me add a couple of properties. So the first thing is, I'll just simply copy resilience 4j. Okay, dot, and since I'm going to do it for retry, the name of the module is retry. So I'm doing retry, then config, then default. So what I'm saying is the default method or the default instance which I'm going to invoke for this retry is the same stuff. So what I will do is first I will say read default, and here I'll give my method name. So my method name which I determined over, which I given over here is, or the instance name is get customer details. So the same name is what I will be giving over here. Okay. So I say true. And after that, I just copy these two again because it's common. The next I will say is instances dot, again the same name of the method which I give it. So in my case, it was the same thing. So you just can copy paste it to avoid any typos. And here we can determine, like, we can set how many times you want to retry. So I will say max retry attempts 2. So I'm just saying just attempt for 2 times, and after that you just mark it as failure and wait for the threshold time. So the next configuration which we can give is what is the wait duration. So what is the wait time that you want to have between 2 attempts, right? So I will maybe give it as 5000 millisecond, which means 5 seconds. So always remember that whatever number you give over here, or for that matter in most of the other configuration as well, it is usually in milliseconds. So you have to convert it into, if you want to have it in seconds, you just multiply 1000 with the seconds you want. So if I want to wait for 5, so just multiply 5 into 1000. That's why I have given 5000. And here, since I have to wait for 30 seconds, I just multiply it by 1000. So that's why I have given 30,000. Okay. So these are the bare minimal configuration which we require for Resilience 4J. But if you check the documentation of retry, you'll see that there are also a few other stuff which you can kind of determine, like add and configure. But for our case, these are not really required. So that's why I'm not adding all this. So what we will do is, so remember I said, we can also say, what is the ignore exceptions, meaning like what are the exceptions which it can ignore, how many times you want to fail after max attempts and all that stuff. So there are a lot of things which you can configure, but for our case I think these two are more than enough. So what we do now is we have kind of configured our retry pattern stuff. So now let's go and bring up the accounts microservice and check how it works. Always, even here, always ensure that your cards is not up, because if the card is up, then we cannot really test if our application is working fine in case of failure. So always ensure your card service is down. Just ensure your config server is started first. Since we have already kept it started for circuit breaker, I assume even in your machine it is started. But if not, ensure the config server is started, Eureka server is started next, and after that we start the accounts microservice. So now I am starting my accounts microservice. So we'll wait for a few minutes or few seconds till it gets started. So you can see that in my console now it has started to load. So we'll just wait for a couple of seconds till this gets loaded. So you see now that the accounts, so you now see that the accounts application is loaded. And just like how we check the logs for circuit breaker using Actuator, the same logic applies here as well. So what I will do is I will just go and hit my Actuator URL from my Chrome. You can also hit it from your Postman. So you'll get the list of all the URLs that are exposed by your Actuator. And since we are interested to check about retry, I'll just search for retry. So similar to the circuit breaker event, you will also see that there is something called as a retry event. So what I will do is I'll just simply copy this retry, because the rest of the URL is going to be same anyways. So I'll just come back over here and I'll create a new request. So I'll do a add request. So why I'm creating all these requests is, so in future if you want to quickly refer any functionality directly from Postman, you can just go to that API and invoke it. Okay, so I'll just give retry pattern and I'll paste this for now, and I'll just take the complete URL from here, right? So just see what I'm doing. So I'm just copying the complete circuit breaker URL, and the only change that we need to do is just replace the circuit breaker with retry. The rest of the things are going to be same. Okay. And since we are only interested to know about the get customer detail, that's why I also added the query parameter. But even if you don't add, that is fine, because we only have defined one retry event in our application. Okay. So let's go ahead and search it, like make a call to it. You see that, as of now it is empty because we have not yet started to make any call. So the next thing which I want to do is, in the same Postman, I'll just go to my profile API and let me make a call now to this profile API. So you see the first time I do it, It takes some time because it keeps retrying to this card application a couple of times. And if it fails, then it goes to the fallback, and that's why you see that, now I'm getting cards as null. The second time I do it, the same thing, it will wait for some time, it will hit the cards for 2 times. It will hit the card, and since it gets the error, it will just get me the data and give. But from the third time onwards, like what happens is it determines that the card is down. So once the threshold period is passed, and if it's still not getting up, it will just mark it as failure and wait for some time before trying again. So now you see that, my profile is kind of working fine, though my card is down, right? And if I now come back and just hit on my retry URL once, so you will see that it has now logged all the kind of events, and you'll see here that number of attempts. So you'll see that how many times have I attempted. So here it has attempted for 1 time, here it has attempted for 2 times. But since we tried again and again within the threshold, so that's why it didn't attempt multiple times. And the last time when I tried after a certain time. That's why it is saying number of attempts as 2. So it will try for 2 times, and if it is still down, it will just mark it as failure and again go back and retry after some time just to see if the card is up. So why it will keep on retrying is, if the card is up, then it will again kind of not invoke the fallback mechanism, but allow the calls to pass through the cards API, right? So that is pretty much about the retry pattern. So just to summarize, so retry pattern is basically used in scenarios where you have transient or temporary issues, right? So you know that the issue might resolve after some time. So what basically you do is you just keep retrying for a certain number of times, and if the service is up in that particular threshold, you kind of allow the calls to pass through that API. But if the calls is still failing and the service is not up, you kind of just mark that service as failure, and after the threshold period of time, you just keep on trying again and again. So generally we only implement retry for scenarios where we know a certain API will go through certain transient failures, okay? And yeah, that's pretty much about it. And since we have already implemented circuit breaker, this session was quite short because we didn't have to write a lot of code. And just to summarize what we did, the first step to add any pattern in our application is we go to the pom.xml of the accounts or whichever microservices you want to implement resiliency. So the first thing you do is, in the pom.xml, you add these bunch of dependencies. So you add your resilience, circuit breaker, because we wanted to do circuit breaker, you added it. For retry and rate limiter, this thing takes care of that. The time limiter dependency takes care of that. And internally, this resilience 4j depends on the Spring Boot AOP, so that's why we added this as well. Okay. So that was step number 1. Step number 2, we came into the accounts controller, and under the post mapping API where we want to implement the circuit breaker, so in our case it is profile, we added an annotation of @retry, marking this particular method as a retry instance. Then we gave a name of this instance as get customer detail, which is nothing but the same name of what you defined over here. So this is just to ensure that we can easily understand for which API are we doing it. And we have also defined a fallback method. So remember, if I don't define a fallback method, whenever any service is down, I won't get data, but instead just an error. So in case if I don't want to return an error but give some default data or just send the existing data, available data, I send the fallback method. So under the fallback method, what I've done for our scenario is, since I know the accounts application is up, I just make the call to the accounts application, set the accounts data into my customer details model, and return that to the end customer. So that is why you see whenever I make a call to my profile when the card is down, I only get the details for my accounts and my card is null. So that's pretty much about it. And from a application properties perspective, for retry, these are a few things which you can set. So one thing is, you can say that all the configuration for this, what is the default configuration. I can say that this customer details is the default configuration for my retry. And the second thing is, for this customer details, I can set the maximum number of retry attempts as 2. So just keep retrying for 2 times and fail after that. And the second thing is, for the customer details, I can also set the wait duration as 5 seconds. So which means between 2 retry, at least wait for 5 seconds as a buffer time to wait for the service to get up, right? So that's pretty much about the retry pattern. And in the next session, we will be understanding about the rate limiter pattern. Thank you and see you in the next session. Hello everyone and welcome to this fourth session. In this session, we'll be looking at rate limiter pattern. So the rate limiter pattern controls the resources used by incoming request. It imposes a rate limit of microservices that can access the resources, and the traffic to the microservices can be reduced and the throughput can be improvised by better utilization of resources. So before we go any further, we'll just understand what are the various throttling strategies which rate limiter pattern uses. So either you can limit the number of operations. Example, we can say just have 25,000 requests executing per second. We can also limit the amount of data that is getting passed. We can say just process 25 GB of data per second. Or we can also say throttle the relative cost of operations, wherein we can say just have 25,000 request unit per second. Okay. So these are kind of the various strategies which is used by the rate limiter pattern. And now let's just understand it in a bit more details and jump into the code implementation. So let's understand how the rate limiter pattern is different from the other two strategies that we saw. So in case of the circuit breaker pattern and in case of retry pattern, the scenario was that you had a service which was down and you were trying to now make connection to the service. So wherein we had the circuit breaker pattern which said I will just close the service and periodically then try to check it if it is up. If it is up, I will then make it up. If not, every time I'll be just invoking my fallback mechanism. And in case of retry pattern, what we said is whenever a service is down, I'll just keep retrying to the service after a threshold period of time, right? And if I find that the service is up, I will just make the calls as usual. If not, I will be invoking my fallback as usual. So this was what we saw so far. But the rate limiter pattern is a bit different. Okay. So here what we are telling is, remember in the initial session when I said, if we want to ensure even we want to ensure that even in case of slowness and other things, we should be able to perform well. So this rate limiter pattern is more like I would say a precautionary measure, wherein we say that even if the load is high, there is a sudden peak in the load in the system, so we should not be degrading the performance. So in order to do that proactively, what we do is we set certain limits in our microservice processing. So what I mean by that is, so assume that you have this /profile API which is now making call to say internally to say your accounts and your cards. Okay. And assume that my application is super famous. I have at least 1 million users who are using my profile API. I mean to say that they're using my application which is calling my profile API. So what happens is, so assume out of this 1 million, now 10,000 people have made a concurrent request to my /profile. So in the normal scenario, what happens is, if my accounts is up and if my cards is up, suddenly, since I'm getting 10,000 parallel requests at the same time, even though I may have certain things in place, like I may dynamically scale up my microservice, scale down my microservice and do all that thing. But if suddenly a large number of requests comes into your network, it will kind of slow down your entire system. Why? Because suddenly the accounts has to deal with all this 10,000 requests, the cards has to deal with all this 10,000 requests. Your profile has to wait till your accounts and cards has processed, and then it will do its own calculations or updates before sending back the request. So overall what happens is there will be a certain kind of slowness in your system. 10,000 is just a trivial number, but it depends on case to case basis depending on the configuration you have. So what happens is my entire system can get slowed down until the point where the new instances are getting up. I may have slowness in my application. So in order to avoid those kind of scenarios and ensure that whoever is the existing user, they are able to kind of get better experience, I have this rate limiter pattern now. Okay. So what the rate limiter pattern says is, I can kind of manage a certain the request in my network based on certain parameters. So what I can say is, if you just see the slide, so I say that either I can have the number of operations. So I can say if there are 25,000 operations, at the maximum I can allow is 25,000 requests per second. Or I can say that I can maximum allow 25 GB of data per second. Why this is also important? Say if you are into some streaming or some other stuff where even the large number of data is getting passed. For a usual application, normally we don't have large number of data passing. But if you're handling multimedia, say you have sites like YouTube or Netflix, where the data is actually the videos that is being sent. So it's also important that you kind of throttle or set a limit that what is the maximum amount of data which can be processed per second, right? And similarly, we can also have something called as relative cost of operations, where we say that you can maximum handle 25,000 request units per second. Okay. So now you may have a query of what is this request units, right? What is request and what is request per unit, or what is request unit or relative cost of operation? Let's try to understand that with an example. So I'll come to my whiteboard. So one request is anything that you say as standard, right? So when I say process 25,000 request, so let's take the normal scenario, right? When I say process 25,000 requests per second. So here a request is a request where we just say that any request that comes in, just treat it as a request. Meaning, if I have, so I'll just take a hypothetical scenario, right? So I just say that, I have a scenario where my user will normally query for a list of names, okay? So maybe just imagine that, I have a university building app, and I have a university application where the receptionist is free to query the names of students in the database. Okay. So here I'm not differentiating whether she's querying one user for one student, or she's passing name of 5 students, or she's passing name of 100 students. For me, each of these is just one request as it is, right? And I'm saying irrespective of how the request is coming, I'm just allowing 25,000 requests to pass per second. Similarly, I can also put a cap that, I can have maximum 25 GB of data passing per second through my microservice. What I mean by that is, say if I have a site like Netflix or Facebook, where I have a heavy usage of multimedia, where my user is constantly uploading or downloading the data. So in those kind of scenarios, I say if the total number of requests that is going through passes 25 GB, limit it. Okay. And the third scenario is nothing but the relative cost of operation, or the request unit. So what is this request unit? Let's try to understand it. So what we basically do is, we kind of first set a standard scenario or standard ideal, what an ideal request should be like. So I'll give you an example. So I say when one request comes into my application, it can at max query for one record. Okay. And it should probably just return one data or one set of record. So this is what I define as an ideal request. Okay. And when I get now request wherein I say one request just searches for one student. So maybe the query is just for maybe say ABC. Okay. So this is kind of following my ideal request. But what if I get a request? Okay. So wherein they search for A, they search for B, they search for C, so on. And maybe they are searching for 25,000 entries. So in this kind of scenarios, it is not a ideal request, but it is 25,000 times the ideal request, because I was just expecting one record, but here actually I'm being searched for 25,000 records. So this is what I mean by a request unit. Okay. So in this case, this query is actually 25,000 times my normal request unit. And in case, and this is my limit, right? So this is the limit that I've set, the hypothetical limit I'm saying. And in case if there's a request which is coming for maybe 1,25,000 entries of search record, this will just throttle this request. It will put it on wait for some time and then execute it. Why this is being done is, if I just allow any number of data to pass my microservices or request to pass my microservice, it will slow down my system gradually or eventually. Because as I said, even though microservices have this feature of dynamically bringing up new instances, bringing down new instances and all that thing, but suddenly if in a short span of time, if a large number of requests hits my server, definitely there'll be some slowness in my network. So in order to avoid that, what we do is we set some rate limits. How we by what means we set is up to us, whether we want to do by request unit, request, or just the data, that is up to us. But what generally happens is, once you have set certain rate limits, right, of whatever data or request or whatever, then you can define certain properties. Okay. So you can say, so maybe I can set the timeout duration. So what is timeout duration is, if a new request comes in, right, to my microservice, I can define certain timeout duration, saying that what is the wait time of that. So which means what is a wait time before a request starts getting processed by my microservice. That is defined by the timeout property. You can also have a limit for period property. So what it means is, within a period of time. Okay. So say for example, my period of time is say 30 seconds, which I have decided. So within this window of 30 seconds, how much request or how much request can be handled by my service. So this can be defined with limit for period. The next is limit refresh period. So these are kind of the application properties which you'll be setting. So I'm just giving you an idea of what it is. So this tells that what is the period of my time or the period of a limit refresh. Okay. So what it means is, after each period, the rate limiter will be reset to the original value. So I'll just give you a simple example. So assume that, I say ideally each of my seconds should wait for 2 seconds. The window to wait, that the total window of execution is 30 seconds. And in this 30 seconds, I can allow maximum 5 requests to pass through. So what happens is, whenever a new request comes in, it will wait for 2 seconds. Then it will then check if the time window is, then the timer will be kicking, like it will start from 30 and it will go, just keep on decrementing till it is 0. So within this 30 to 0 seconds, if any request comes in, it will be executed till total 5 number of requests are executed. Once the 6th request comes within this 30-second window, it will be again put on wait for 2 seconds. And after it reaches 0, my timer will again go to 30 and start again. And it will again start accepting new requests. So this is how this rate limiter pattern works. So essentially what happens is, you sort of have a timer that is running, and when that timer is running, based on whatever limit you have set, the request will be allowed to execute. And if the limit is breached, it then goes into a wait state where it will just wait for this timer to again reset back to 30 or allowed, and then it will go back and execute. So that's how your rate limiter works. So I hope you now got an idea of what is rate limiter pattern. So now let's go quickly and just implement it again in our code. So as I said earlier, since we have already kind of added the POM dependencies, we don't really need to add it again. So we just go to pom.xml, you will see that we have added this time limiter over here, which will take care of the rate limiter stuff. And we have also added the resilience 4J earlier, the circuit breaker earlier. Circuit breaker is not required for this session. It was added for a first session, but still we have kept it. And internally, since the resiliency uses aspect oriented programming, we have added that as well. So you don't need to bother what each of this does internally. You just kind of need to add all these dependencies, and your Eclipse will automatically import all these libraries for you. Okay, so that was step number 1. So step number 2, if you recall, we just come to our accounts controller. We come to our API where we want to implement this rate limiter pattern. So what I'll do is the same thing I'll do like what we did for earlier. So I'll just comment out this retry pattern that we did, and I'll just come to a new line. And over here, now I have to define the rate limiter pattern. So I'll just put rate limiter, and then I have to import it. So I'll just click on this, import it. And after this, I have to give a name to this rate limiter. So what I'll do is I'll just take the same thing as the top. So I'll just copy the same thing, and I will put it over here. So what we basically do is we give an instance name to this instance as whatever the method that is below. So we give the same name. This is just for standard purpose. And the next is the fallback method. So this will be invoked whenever, say, if I'm keeping my thread waiting for a long time, or if there is any error or issues. So in those kind of scenarios, the fallback method would be invoked. Okay. And one more thing is, you guys would have noticed that even in the previous video, in the previous session, we are seeing kind of an error over here or a warning over here, which says that, this get customer details fallback is kind of not invoked anywhere, and that's why the Eclipse is asking us to remove it. That's why you see this warning. Why this is happening is, internally, all the retry pattern or the circuit breaker or rate limiter will call this fallback internally. Like we are just passing it as a reference. We are not actually calling this method over here. Since we are passing it under string, it is more like a string, which the rate limiter will internally invoke. But for our Eclipse, it does not know that, it thinks that we are not calling this because we are explicitly not calling it like this, right? We are not invoking this method anywhere. So that's why this is throwing this error. And in case you feel that, this is distracting and you want to just suppress this error, there's a very simple way you can do it. You can just add @suppress warnings. And over here, you can just add which type of warning you want to suppress. So we'll just suppress the unused warning. So now you see that, this error is gone. So just to repeat what I did. So if you don't add this, it's still fine. But if you remove it, you see that, your Eclipse kind of gives a warning over here that, this is unused and, it should be removed. So but since we know that we use it as a fallback method, that's why we cannot remove it. So rather what I will do is I'll just suppress the warning just for this type of error which is unused. Okay. And even when you write your normal code for your applications, always ensure that you are not suppressing a lot of errors. Only when the scenarios like this where you know that this is just a false alert, actually we are using this method, you can do the suppress warning. Okay, it will just keep your code clean and without any unwanted errors. So with that said, I think we have completed our config. So the rest of the things remain same. So the rate limiter will work here, and if it finds that there is any error, it will go to the fallback. In the fallback, it will we are just returning the accounts details and setting it in the customers and returning it back. Okay. So the next thing that we have to do is, if you remember, in the application.properties, we have to set a few rate limiter related settings. So just to avoid confusion, I will just comment out the retry related properties. Even if you keep all this enabled, it is fine. But just to avoid any confusion, I'm just kind of commenting it out. So now you'll see that for rate limiter, we also have a few properties which we discussed, right? Like timeout duration, limit refresh, and limit for period. So those kind of things we have to kind of define now. So which I'll just quickly do. So let's quickly add these properties. So there are these 4 properties which got added, which I just added now. So this is similar to the circuit breaker properties that we added. So if we first call the rate limiter module in the resilience, then we say go to config default register health indicator true, which means that we'll be periodically checking what is the health status of the microservice. The next is we are just calling the instance's name, which is the get customer detail which we have defined, and we are defining the timeout duration as 2 seconds. Okay. So what timeout duration means is whenever there is a throttling of the request, it will just wait for this 2 seconds. Okay. And then again go on and check if it is allowed to execute. The next is limit for refresh period. We have set it to 10 seconds. So what it means by that is in 10 seconds. So what it means is in 10 seconds, I am allowed to kind of execute 2 threads. So that's why I say 10 seconds and limit for period is 2. So which means that in 10 seconds at max, I can allow execution of 2 threads. Okay. So just to kind of refresh your memory, what I mean to say is we have defined the time period as 10 seconds. So for every 10 seconds, I'm allowed to only execute 2 threads or 2 requests. And if I'm getting more requests in that period, it will go into a wait state of at least 2 seconds before again retrying. So that is what I'm just setting right now. There are also a few other properties. If you just go to the resilience site and check on rate limiter, you'll see that there are a few more properties, a few more things that you can do. Not properties, I would say, a few more things which you can do. But for our demo perspective and for your knowledge perspective, I think we have covered pretty much whatever is required. And here is the kind of the cycle, the kind of the concept which they have explained. When you look at it the first time, it might look a bit threatening. So that's why I gave a simple example. But this is also telling the same stuff. When time starts and there are 2 threads running. So how based on the cycle or based on the period of time, you can either execute it or keep it on hold. So that's what this is talking about. So coming back, now what we will do is we'll just stop our accounts application if it is already running and then just quickly start it again. So this is to ensure that it picks up all the changes related to the rate limiter. So I'm starting my accounts application and as you can see, it is now starting. So this will take a few seconds. So let's wait till then. So in order to check this, if this rate limiter is working fine, what we have to do is we will first kind of make a request quickly, 2 requests quickly within the time period of 10 seconds. And again, we'll try to make another request within that same time period. That is within 10 seconds, we'll try to make 3 requests. And we will notice that the first 2 requests will kind of execute quickly in the usual time. But the third request will kind of take some time because it also enters into that wait cycle. So that is what we are going to kind of check now. So yeah, the accounts is still starting. It will be up anytime. Yep. So now the accounts is started. So the same drill we'll follow. So first we'll go into Actuator. We'll see whether the service is now returning values. And in the Actuator of accounts, we will, since we are going to do rate limiter, we will first check if the rate limiters API is exposed. We see that it is exposed. We see rate limiters and rate limiter events. We are always interested in this rate limiter events. So since we are implementing rate limiter event now. So what I will do is I'll quickly come into my Postman. I'll just create a new request. So I'll just give it the name of rate limiter and I'll just copy the same URL from retry, put it over here, and here the only changes, you have to just give this name, right? The rate limiter event. So the same thing I'll give, rate limiter events. And here you can still give the same name, or even if you don't give it is fine, because we have just implemented one method. But in case you have multiple instances, like you have implemented for a lot of API and you just want to filter for one API, you can just give query parameter, you can give name equals to whatever the method name, right? So now I give send. So you see it is empty by default because we have not yet started hitting our API. So now let's quickly try to hit this profile 3 times within 10 seconds. So this is my first, second, third. So now you see it is taking some time, right? Because within 10 seconds, if I try to do more times, it will just try to throttle it. And when I come to my rate limiter, repeat the part of API testing. So repeat from the part where I say, now let's test the profile. So let's quickly test this profile and now see what happens. So what happens is basically when I hit my profile for first time, second time, so you can see that, the third time it had to wait for some time and then it gave the response, because we were trying to make too quickly, too fast, right? Within 10 seconds, we tried for 3 times. But if I try now, you see that, for the first 2 requests, it comes quite fast. And the third request, if I again make it within the 10 seconds, it's taking some time and then coming. Okay. So that is the beauty of kind of the rate limiters. And the other thing which I also wanted to show you is this rate limiters also has one more API called as the rate limiters. So instead of events, I want you to show what this rate limiter does, right? So I'll just go to the rate limiters. So here it will give me the name of whatever instance I have. So I have this instance of get customer detail, right? And after that, my actuator also kind of exposes a few metrics. So what I can do is I can go to actuator metrics. So you may ask this question, how I'm getting all this, right? So all you need to do is just make a call to your 8080 actuator. And here you will see there is something called as metrics. And under metrics, again, you can have all this log resilience related stuff. So what I will do is I'll just make a call to this metrics resilience 4j dot rate limiter dot available permissions. So what this is, so this is nothing but just telling me what is the permission that I have right now for my rate limiter. So it says that the available permission that I have is 2, meaning I can execute 2 requests per unit time that is defined. So this is called as available permissions, right? So similarly, I can also have other metrics where I can say for my rate limiter, right? I can also check what are the waiting threads that are there. So say I can put waiting threads. So unlike the other events, right, where we got it in the logs, here you can also dynamically check what is the current status. So if I give waiting threads, you will see that number of waiting threads as of now is 0 because we are not executing the profile. But I cannot show you to you in action, because by the time I make the call and it's waiting and I come here and execute it, the thread would already be executed, right? Because it's a very fast performing thread. But in an enterprise application where you might have a few hundred or thousands of requests waiting in the thread, so that's why it will show you the dynamic count of it as and when it's getting executed. So this is another API which helps you to monitor the waiting threads. So with that, we have also completed the rate limiter pattern, and I hope you understood. So just to quickly summarize, we just saw 3 patterns today and implemented it. So the first we saw was the circuit breaker. The second that we saw was the retry pattern, and the third was the rate limiter. And even for this week, what you can do is now you can just quickly recreate the Docker image only for the accounts, and you can just push it into the Docker Hub. There is no changes required for the Docker compose file here, because we are not added any new kind of services, or we are not changed any dependency. This is just like a implicit code change that we did. So we don't really need to do any of the Docker changes or other stuff. For your practice, what I would recommend is you just try to kind of create the Docker image and push it into the hub. And in case if you just forgot or not really sure about it, I'll just quickly show to you what needs to be done. Since the accounts is using Docker file to create the Docker images, so the first thing that I will do is, so you can see that it has Docker file. So when you have Docker, when you're creating image through Docker file, the first thing that you have to do is you have to run the Maven clean install. So I'll just come to run configuration, and since I've already defined maven clean install in the goals, I can just run it. So when I run maven clean install, it will first generate the latest jar file for me. Okay. So this is step number 1. So we'll just wait for a few seconds while it is creating the build. So it's currently testing our application, and once the test is completed, it will kind of build it. So if you don't want to really wait till the test is completed, as I said earlier, you can also give skip test is equal to true. But that's fine. I mean, like in your normal applications, you never kind of disable it as a best practice. So you always write test cases and ensure it is passing. So now it is getting completed. The testing is done, and yeah, so you see the test has run, no failures, and now it will quickly build the jar, and yeah, you see the build is success. So now we can see that under the target folder, a new jar has been created. Okay. So the next step, if you remember, we have to now run the docker build image command. So what we will do is we will just go open this accounts from our explorer. So we just right click on the accounts, go to show in, go to system explorer, and from here you can just directly open the accounts, and you just directly open command prompt from here. So it will give you the same path. Here the command is simple, docker build, because we want to build a new image from where the current folder, that's why dot, and what is the tag you give? It is backend, because in my case the docker desktop or the docker user ID is backend123, that's why I'm giving that. For your case it will be different, whatever, based on whatever you created. And after that, what is my package name? So here it is accounts. So basically you have to give the same tag, like that is coming over here, backend123 accounts, right? Enter. So now it will start creating the new account, this thing for you. And if you just check over here and in your docker desktop, so we created accounts sometime back. So now if you just keep refreshing it, once the build is done, you'll see that a latest tag of accounts is getting created, which is showing less than 1 minute ago, which means that our accounts image got successfully created. And if you see a older version of accounts with the tag none, as I said earlier, you just remove it. And why we remove it is because each of this image takes some considerable space. Like in our case, it is taking 509.61 MB. So if you keep on accumulating unwanted images over the time, your system will run out of space. So that's why we always remove the tags with none. So I'll just go here, click remove, done. The next step is we have to now push it into the Docker Hub. So for that, yesterday I told you, we can either do it from command prompt by giving docker push and the image name, or we can do it from here simply. Just click here and click on push to hub. It will start pushing the image to the Docker Hub. So we see that it's going fast now. So if you just wait for a few more seconds, this will be done as well. So to verify it, just go to your hub.docker.com repositories. And the last time we pushed it was 17 hours ago. But once this process is completed, it will be updated over here as well. So we'll just wait for a few seconds for this to complete. So based on your network speed and computer speed, this might take some time. And once it's completed and we refresh our hub.docker, you will see that even this gets updated. So as of now, it is showing pushed 20 hours ago. So once this is completed, it will show pushed just now, just like the way we saw it earlier. So with that, we have also completed updating the Docker image, creating the Docker image for accounts, and pushed it. So you may have a question that this time why we have not updated the images for cards, config or Euro, because Eureka server, because we have not made any changes to any of them. So in this session, we have just updated the rate limiter pattern for profile. And that's the reason we have just updated the Docker image for accounts and pushed it. If we did any changes for cards, config or Eureka, only in those scenarios we have to update these images and push them as well. So with that said, let's quickly summarize what we have learned today. So we first understood the basics of resiliency and why it's important for applications. Then we saw a few patterns of resilience like circuit breaker pattern, retry pattern and rate limiter pattern. And also we saw how we can implement resiliency in our banking microservices using all these 3 patterns. And also I showed you a few actuator related URLs where you can monitor the logs and the current status of the application based on the resiliency pattern that you have implemented. So that's it for today. Thank you for your time and looking forward to see you in the next week. Bye. Hello everyone. and welcome to this week 8 of Microservices using Java, Spring and Docker course. In this week, we'll be focusing on the cross-cutting concerns and routing in microservices. So let's do a quick recap. In the previous week, we learned the basics of resiliency and why it's important for application. We learned about the patterns of resiliency. We saw and implemented circuit breaker pattern, retry pattern and rate limiter pattern. And finally, we saw how can we implement these resilience pattern in our banking services. So if you remember, we implemented all these 3 patterns one by one in our profile microservice and saw how they work. So in this week, the following are the main table of contents or the topics which we are going to discuss. The first, we'll discuss what is routing, introduce ourselves to the concept of routing. The next, we will understand what is the cross-cutting concerns, what do we mean by them. Next, we'll see what is Spring Cloud Gateway and how it helps us to kind of help resolve the challenges associated with routing and cross-cutting concerns. Then we will be implementing our routing and cross-cutting concerns with the help of Spring Cloud Gateway. And for the cross-cutting concerns, we will be taking the example of tracing. There are multiple examples of cross-cutting concerns which we can implement as you will see in the course. But for the sake of the demo, we will be taking tracing and implement it. And finally, we will also then update our Docker configuration for Spring Cloud Gateway and get it pushed into our Docker Hub. So the learning objectives of this week is we are going to learn about what is routing and cross-cutting concerns and the challenges associated with it. We will then see what is the Spring Cloud Gateway and how it helps us to resolve the issues or challenges faced while routing or cross-cutting concerns. Then we will be implementing the custom routing and cross-cutting concerns in our banking application, and we'll be taking the example of tracing for cross-cutting concerns. And finally, we'll be updating our Docker image configuration for the Spring Cloud Gateway server. So let's get started. So first, let's try to understand what is routing. So far we have discussed a bit about routing indirectly when you were discussing about the config server and also the Eureka server. So what we basically mean by routing is you have multiple services that are running in your applications, right? So there will be multiple services that run in their own containers. And there's also a possibility that some of these services may interact with each other and pass the data along. Say for example, the profile API. It depends on both the accounts as well as the card microservices. Here the routing deals with the interaction between the services. So what we basically mean by routing is how data flows from one microservice to another microservice and what is the dependencies between them. So that is what is the routing in simple words. And also we have this scenario of custom routing, wherein we say based on certain parameters, we might need to kind of pass certain requests to a particular API, and for other scenarios, we might pass it to other API. I'll give a simple example. So say for example, we have 2 versions of our application. One is the normal version which everyone like you and me use, and there's also beta version which you only want to give access to specific kind of users. So in those kind of scenarios, what you will do is the normal users will be doing the static route, like we will be doing the static routing for the normal users, wherein we will say any request which comes via the normal URL, just redirect them to the particular APIs. But if we pass certain parameters in the URL, like say /beta/account, for example, then we want those kind of requests to be forwarded to a special instance of accounts which is running the beta version. And why we want to have the special instances? Say suppose you want to test a new feature in the market and you don't really want to expose to all the user, but you only want to expose to certain users who are your beta testers. So beta test is nothing but before your launch, you just ask a few of your actual end users to test it. So that is called as beta testing. So I hope would have also heard about it, like in some of your popular apps when you say there's a beta version available. So what happens is when the beta versions are out, or when you want just a few users to test it, so you will designate these users as beta testers, and whenever the request is made from their application, the request will be going to the beta version of the account. And if that is the case, we want a mechanism where we could do those routing dynamically based on the input parameters that are received. Or another example would be maybe you have 2 versions of your application. So one is the normal version, one is the premium version, and you want the premium users to get access fast and get their request fulfilled quickly. So you can kind of route those premium users to a server which can run fast and the normal user to the usual servers. So even that is another example. So next, let's try to understand what is the cross-cutting concern. So the cross-cutting concerns deal with the patterns or areas within the microservice that is common across all independent services running in their own containers. So say for example, when I say a cross-cutting concern, it means that those are those features or functionalities which are common across all the microservices. And another concept to remember over here is cross-cutting concerns are not business logic. So say for example, if I'm going to implement a banking or a shopping website, cross-cutting concern does not mean like how my user will going to add a item to the cart or how they are going to make a payment. Cross-cutting concern generally means any functionality that is common to all the microservices that is running. So say for example, it could be logging, it could be auditing, it could be security, it could be analytics and so on. So in all of these functionality, if you see, it is independent independent of what business logic you write, right? So logging means like I just want to log like, maybe the warning events or the error events. Auditing means that, I just want to ensure that whatever actions the user takes, all of them are kind of logged and I'm able to audit it for the future purpose. Security means that, I want to ensure that only the authorized users are able to use my microservices and are not able to perform any unwanted actions. Analytics means it is part of auditing again. So I will take all my logged data and I'll be performing analytics just to find like, what is the pattern of my users using my microservice. So all these kind of things is something what we call as cross-cutting concern. So remember that a cross-cutting concern is not a business logic. So it is not something like your specific feature which you develop, but it is kind of the thing that, which applies to all the functionalities or microservices which you develop. So a challenge during the development of microservices for application is that when you develop standardized cross-cutting concerns across all microservices, you could have cross-cutting concerns like logging, auditing, and so on. So what we mean by that is, as you may be aware that microservices, you can develop many microservices in parallel, right? So as we discussed in the initial few weeks, the advantage that microservices offer us is that we don't really have to wait for the team to develop each and every functionality one after the other, just like a waterfall model. We could have multiple independent teams working on different functionalities or areas of your application and develop all of them independently. So one common challenge which comes during such a development process is how can we standardize all this cross-cutting concerns across all the microservices? So say for example, if a team is developing accounts microservice and a team is developing the cards microservice, how can I ensure that the logging or the tracing or the auditing mechanism which the team for cards is doing, the same thing even the accounts team is doing? Because since each team is independent, I don't want every team to be doing their own way of all these common things, because if every team is having their own way of doing the common cross-cutting concerns, then over the time the compatibility between the microservices will take a hit. So it is better that all these common things should be standardized in a way and developed in a common fashion. And there are also a few challenges regarding routing. There are situations where the requests are routed to a specific microservice depending on custom requirement. So as I said, like, it could be a difference between your premium user and normal user. It could be a difference between a normal user and a beta user. And also sometimes it could be like, you want to give different versions of your app. So maybe like, I hope you would have seen that, there are some certain app where you even get a light version, like, where they have a limited set of functionality. So when you want to like do all those kind of switches dynamically, like, based on the request coming, so that becomes a challenge in the traditional environment. So far you must have seen that we have implemented the Eureka server, right? So the predominant use of Eureka server is, so whenever a service is getting started, it will register itself with Eureka. And whenever a request hits Eureka server, it will find out based on the application that it wants to access, which microservice do I have to route. But Eureka is not really capable of doing all this stuff, because all this dynamic routing and static routing kind of stuff where you want to ensure that you are routing the request to the proper server based on certain parameters. So all these things Eureka won't be able to do. I also want you to understand the difference between what we have done so far and what we are trying to do right now. We are more concerned about how can we do custom routing and how can we implement standardized cross-cutting concerns across our entire microservices. So the other concern or other challenge that we have while developing microservices, the PEP concern. PEP is nothing but policy enforcement point. So what we mean to say is we should have a central gateway which will enforce all the configured policies for microservice. So a PEP is what will be used to evaluate an authorization decision, and no authorization logic is implemented in PEP, and it can be independently applied to all microservices individually. This ensures that authorization verification is performed independently at various points during application runtime. So what I mean by that? So just take this example, right? Assume that, I'm developing 10 microservices, and in all my microservices for a bank, okay? And all my microservices, the requirement is that you should only allow the execution of the microservice if the user is authenticated, right? So what I need to have is kind of a central gateway where it will ensure that, any request hitting my microservices, any of my microservices, it will first hit this central gateway. That gateway will first validate if this user has been validated. And if that is the case, it will be allowed to execute. If not, it won't be allowed to execute. So that is the kind of a concern which we have, where we want to ensure that certain policies are enforced before the microservices are allowed to execute. So far we have seen a few challenges that is like, we'll face while designing microservices. So we will now see how we can mitigate these potential challenges by using the Spring Cloud Gateway project. So before we go any further, I just want to quickly recap what we have learned in the whiteboard so that the concepts really become clear to you. So what we have learned so far, like let me quickly also recap what we have done so far in our microservices. So in the week 3, what we did is we just implemented a simple microservice for accounts and cards, right? We developed them as 2 separate microservices. That we first did that. In the next week, what we did, we kind of implemented the Docker image for these accounts and cards. We saw that how is it for us to kind of just make it them our Docker image so that we can just run it across any platform and also share it across to the anyone in the world using the hub.docker.com. And after that, we saw a key challenge that since we have now n number of configurations or application property entries which we have to enter in accounts and cards, we then implemented the concept of config server. Why we implemented that, as I said, we really wanted to separate the configuration from the application and also ensure that we are able to refresh or update the configuration on the go without having to restart the application every time. So that's the reason we implemented config server. After that, we implemented something called the Eureka server. So what is the Eureka server? So Eureka server was basically used for the service discovery and registration process. So wherein we said, if there are say 50 microservices within my organization, how will each of these microservices communicate with each other? And also, if I'm an external client and I want to interact with microservice inside my organization, how can I do that without having to worry about the actual IP address and port of each of these microservices? So to solve all that issues, we had the Eureka server. And after that, we saw how we can build some resiliency in our application using Resiliency 4J. So why we used Resiliency 4J was, so far we have developed the microservice, but what in case one of the microservice fails or, and we don't want to kind of just overload that microservice network. So that's the reason we went and implemented Resiliency 4J in the last week. And in the current week, what we are talking about is implementing a gateway. So before we directly jump into implementing the gateway, I first want you to understand. So if you see, it's a gradual evolution. We are doing step by step first. And even before this, we just saw the basics of what is a microservice and why we need microservice and all that stuff, right? So if you see how the topics are progressing, it is a gradual evolution, right? So first we implemented a basic microservice. Then we saw what is the challenge just running the microservice in your local or server. So we went into Docker. Then we saw the problems with configuration. We went into config server. Then we saw that, hey, I cannot remember the IPs of each of my microservice. So to resolve that, we went to Eureka server. Then we saw potentially if my servers are down, I want to kind of gracefully handle it. So we went to Resiliency 4J. And now the challenges. So there are basically we are talking about the two challenges over here. So what are the challenges we face and how the Spring Cloud Gateway will help us to resolve it? So the first one that I'm talking about is custom routing. And the second thing that I'm talking about is a policy enforcement point or a central gateway, which will act as a central gateway to all my microservices. So what is the custom routing talking about is, I will take a simple example. Let's assume that, I am having a microservice, which is say localhost 8080/accounts. So we all know about this API which we developed. So this is a normal API which the user will hit and it will be going to the accounts service. What if I have a service, I have a request from a user which says /beta/accounts, right? So far we have not implemented any routing policies or principles which will allow us to kind of specially route this particular routing request to a particular instance of accounts. Okay. And the reason for that is Eureka server does not specifically allow all this configuration. Eureka server is not technically your central gateway. It is only for service discovery and registration. And in order to implement all this stuff, we need to have a central gateway which will be able to do it. Okay. So that is the first challenge that we have. The second challenge that we have is we also need to have a central gateway through which we can implement all our cross-cutting concerns and keep it as a policy enforcement point. Meaning, if I decide tomorrow that all my microservices in my application should log their data properly, should have a tracer implemented properly, and should be able to do analytics properly. So if I just ask each of my microservices team, that is accounts, cards and all those people to develop all this their cross-cutting concerns by themselves, it will be a mess because each team will be following their own standards and end of the day, there might be issues of incompatibility between the microservices when I'm trying to manage them centrally. So in order to avoid all this, I'm going to develop this Spring Cloud Gateway. So what happens is in the future sessions, we will see how Spring Cloud Gateway architecture looks like and how it works. So you will get a better understanding of how Spring Cloud Gateway works. So with that said, let's now see about what is Spring Cloud Gateway. So for the challenges that we saw so far, Spring Cloud Gateway is one of the solution and it is a project for Spring framework which is used to build an API gateway. So the keyword here is API gateway. So an API gateway processes requests that are sent to the application and API gateways help us to intercept, analyze, and act on request. The request can be routed to specific microservices based on custom configurations and query parameters, and the cross-cutting concerns for each individual request can be handled with ease using Spring Cloud Gateway. And cross-cutting concerns, we have seen the examples like login, authentication, tracing, auditing. So all these are kind of cross-cutting concerns. When I mean cross-cutting concerns, it means that, if we are not going to implement any business logic in it, these are purely just the functionalities which is required for us to manage our application better. So the Spring Cloud Gateway communicates between the client and microservices. So it kind of sits in the between. So here the client is anyone who sends the request. It could be the end user, the application from which you send the request, postman or whatever. And microservice is nothing but the server that is going to receive the request. So in our case, it will be accounts, cards, and all those kind of servers. So hence all the requests that pass through Spring Cloud Gateway. So Spring Cloud Gateway ensures that all the requests only hits the gateway first and then proceeds to individual request. This also ensures that the gateway acts as a single source of policy enforcement point for all the requests being sent. So you see the advantage, right? We have now made the Spring Cloud Gateway sit between the client and the microservice in between. So any request that passes from the client to the server or back from the server to the client has to pass now from Spring Cloud Gateway. So by default, this can now act as policy enforcement point. So we can ensure that, any cross-cutting concerns or any custom routing or any application specific feature which has to be implemented across any microservices, those can be now implemented using the Spring Cloud Gateway. So this is a sample architecture of how Spring Cloud Gateway works. So you can see that this is my end user who is using my application or your mobile or whatever it is. And even it could be a postman for that matter, the way we are testing it right now. So when a user is trying to hit any application, right, internally it will be calling the APIs. So for our case, just assume it is the cards, profile or accounts API. And internally what happens is the Spring Cloud Gateway has this mechanism, right? So it will have a routing or gateway handle, just like how you saw in Eureka that you can have multiple instances of Eureka running in parallel. So similarly, here you'll have multiple handlers within the cloud gateway which will be running in parallel. So what each of these handler does is they will have a predicate and they will have a filters. And what predicate basically does is, so it will first check if your conditions are fulfilled before even allowing this request to proceed further. So say for example, I have given a condition that whenever a user is making a request to my API, they should definitely pass their user type in the request header. So if I see that request user type is not present, I will simply just reject the call here itself. I will not let it proceed further. Okay. So those are some kind of the pre-filters or you could say certain preconditions which we can set and monitor here even before proceeding further. Okay. And once it passes this stage, we have filters. So filters are of two types. That's why we are given two over here. One is the pre-filter and one is the post-filter. So what is pre-filter is? Pre-filters executes all the tracing, auditing, security kind of cross-cutting concerns. So anything which we want to do when the request starts processing, we will be implementing in the pre-filters. And post-filters is nothing but once the request is completed executing and going back to the user, we may want to do certain additional processing on top of it. Say for example, I want to validate if the response is in the correct format, or I want to just audit how much time it took for my server to execute the process, or I want to just add some custom headers back in the HTTP call. So all those kind of things I can do in the post filter. Okay. So these are some of the key things which we kind of do. And once it passes that stage, then it comes to something called a netty server. This is nothing but just an internal server implementation which Spring Cloud Gateway uses for then routing the request to the particular microservice based on whatever the request is coming. So say for in my case, if I make a call to profile, so it will pass through all this, check everything, and if I have implemented any cross-cutting concern, that's also just applied to that. And finally, when it comes to my netty server, it will then decide, okay, where I have to go. So since I have to go to my accounts, it will go to accounts, and internally from accounts, using my Eureka server, then my request will proceed to cards, process it, and the request will come back to the user after passing through the post filter over here. So this is how the cloud gateway architecture works. So since we have discussed a lot about the Spring Cloud Gateway, so listed below a few things which we are going to implement today, that is now, in our banking microservices, which we have built already. So first thing, we will implement the cloud gateway service. We will then implement the custom routing. We'll just take the example of a beta version and see how we can dynamically route the beta version to our accounts microservice. And also we will see certain cross-cutting concerns. So say for today's example, we will be implementing tracing. Okay. So what is tracing? Just before we get into that, so assume that you are a support person. So when I mean a support person, just assume that you are a person who's going to support an application from a developer perspective. Okay. So assume that, there's an application which is running for a long time and now they are recruiting you to kind of support it whenever something wrong happens in the application. So if I ask you, if tomorrow say the application goes down, the user says that, I'm not able to maybe check out my cart. Okay. So how will you find or how will you debug the problem? So the first thing that you will obviously do is go in and check in the application logs just to find where it went wrong. But when you have a microservice setup where you have hundreds and thousands of servers running and even multiple instances running, it is very difficult for you to find where the request started, where it flowed and where it failed and all that stuff. Example, if you take the profile microservice. So profile microservice depends on accounts microservice and also cards microservice. So that was still a simple example, but you can also have microservice which may depend on 50 other microservices. So in those kind of scenarios, if I ask you that, hey, can you please debug my application? It's going to be a nightmare for you. So just to avoid that situation, we have this concept called as tracing, which is also a cross-cutting concern. So basically what tracing does is it will add a unique ID to each of your requests that is flowing through the microservice. So what happens is if I hit a request now, so it will generate a unique trace ID will get generated for that. So the advantage of that is if I want to just check which all parts of my application did this trace ID flow before failing or getting an error, I can simply just search all my logs for this particular trace ID and it will give me the summary of it. So how can I search all my logs across all my microservices for this trace ID? So don't worry about that. We will see a bit detail about that in the next week. So where we will be talking about the Spring Sleuth and Zipkin. So for now, just remember this part, that tracing just means that, whenever I want to debug my application, I just want some unique ID to be attached to each of the transaction or the request that goes through. And that is the concept of tracing. So now we will start setting up our Spring Cloud Gateway. But since this is going to be lengthy part, let's take this in the next session. So we have come to the end of the first session and I'll be looking forward to see you in the next session where we'll be starting to implement the Spring Cloud Gateway. Thank you. Hello everyone and welcome to the second session of the Spring Cloud Gateway discussion. So now let's get into the demo of setting up the Spring Cloud Gateway server in our banking microservices and see how it works. And before we proceed, I just want to quickly revise or recap why we are doing this. So as we discussed, we want a kind of a gateway to sit in between the users or other microservices which are going to access our application. So something like this, right? So we want a gateway in between, which will be the central hub or the central gateway through which we want all the requests to be flowing to our individual microservice. So it could be accounts, it could be cards, it could be loans, and all the other maybe 1,000 microservices which we develop, right? So the use of this is, it basically helps us to solve two challenges. One is, how can we handle custom routing? Okay, so this is currently something which we have not yet handled. And if you understand that, as we said, and if we want to just route based on the parameters or the URLs which the user is accessing, so those kind of custom routing is still a challenge. We will not be able to do it. And also the second thing which we talked about was the implementing the cross-cutting concerns. So something like tracing, logging, and etc. So these two are the challenges which we'll be now trying to eliminate with the help of Spring Cloud Gateway. Okay. So the first thing which we do whenever we want to create a new server or a new microservice application is, as you know, we just come back to our start.spring.io website. The rest of the parameters are same, like how we did for the last time for Eureka and config server. Keep it Maven project, Java version 2.7.4. If you see a higher version over here in 2 series, it is fine. And for the artifact name, just give it as gateway server. And the name, automatically this name will come as gateway server. Description, you can just give like gateway server for bank microservices. Packaging name will also get auto-populated. Ensure the packaging is jar and the Java version is 11. Okay. So the next thing, we have to select the dependencies. So since we are going to develop a gateway, so the first dependency that we will add is the gateway. Okay. So this will provide us method of routing the APIs and also doing the cross-cutting concerns. Okay. So this is the Spring Cloud Gateway. The next thing that we will use is the usual stuff which we do as always. So the first thing, we will just select the actuator, the Spring Actuator. So select Spring Boot Actuator. And after this, now for this gateway server, we also wanted to interface with our config client. Why we want to interface with our config client is, I will be adding a few application properties to my remote GitHub repository. So remember I said we have this config server to which we can connect our microservices to fetch the configuration. So since I'm creating a new application, I'm directly selecting the config client over here so that it will be able to connect with my config server and fetch the application configuration. The next thing which I need to add is the Eureka discovery client. Why I need to add Eureka discovery client is, remember from our Eureka server discussion, this is also one of the microservices which we are having, and also we want to ensure that we get the details of all the microservices which are up and running. So that is the reason we will have this Eureka discovery client, so that we will be able to do the load balancing and failovers. Okay, and optionally, for this demo, I will also be adding one more tool, which is the Spring Boot Dev Tools. So what is the advantage of this is, it will allow you to quickly restart the application and do live reloading. So remember, like whenever we used to kind of develop any features, we had to stop a server and restart it, right? In order for that changes to take place, to take effect. But rather, even in our dev server, we don't have to restart it again and again if we just use the Spring Boot Dev Tools. So that is all we require. This is optional. It is only I'm adding for the development experience. And even for that matter, you can add this even for the application which you did for earlier. Okay, so it's not mandatory, but it's kind of a nice to have where you not have to restart your application frequently. In our case, we generally just wrote the code once, and later we just started the server. So this was not really very helpful so far. But now, since we might be testing a few changes which might require frequent reloads, so that's the reason I'm adding it. And once you click on explore, you will see, if you go to the pom.xml, you will see that all the dependencies that we added, like the Spring Boot, the Spring Cloud, the gateway servers, and everything is now added. You also added the Eureka client, discovery tools, and all that thing. So now we are good to go. So you can just hit on generate. So this will generate the gateway server. Now you know the drill. So you just open this gateway server and extract the content of this gateway server to whatever folder location you have put the rest of your files. So in my case, I have just extracted all the content of the gateway server and placed it in the same folder where my accounts, cards, config, and Eureka is also present. And one more thing, just for your information, now since we have 5 instances of servers running in parallel, so whenever you're starting things like Docker Compose and things like that, just be careful that your computer is able to take the load, because when you start it locally, it is fine because it will be just 5 Tomcat processes running. But when you run it as Docker image, even your Docker runner will consume some space. So always just be careful that so you have sufficient RAM and CPU power in your laptop or computer, whichever you're running. So yeah, this is just for your information. So once we have added the gateway folder into our home folder where rest of the projects are present, the next thing that you will do is import it into our workspace. So just go to file, import existing Maven project. Here just browse to the folder which has your code. So in my case, I'm just coming over here, I'm selecting gateway server. And once I select gateway server, just do add to the working set. So now it will add the gateway server, and you'll see automatically the Maven will start importing and installing all the dependencies for this gateway server. So once this is completed, we can start our changes. So meanwhile, if you remember from our previous discussion, I said that whenever you add a new server, it's also important that we'll be creating the Docker image for it. And the way to create Docker image for a new server using the build pack method is, you just need to add these 3 lines, right, in the configuration. So just ensure that you just copy these 3 lines from cards or Eureka or config server. Any 3 is fine, not from accounts, because in accounts we have created it from Docker file. So you can copy this 3 lines from any of the other micro servers that you have, like APIs that you have, either cards or config or Eureka. So just copy this. Now I see that still it is downloading. So what I will do is, I'll just wait for the process to complete, or meanwhile I'll just come down. I'll just come to this place of build, and here I see even the configuration is missing. So I have to also copy this entire block. So just ensure that you copy configuration image, these 4 lines, and later we have to close the configuration. Okay, so just copy this 4 line, come to the gateway, and here after this Maven plugin line, here just give one enter. So now you see that the installation is completed. At the bottom, I don't see any progress. So which means the installation is completed. So I can just go and place this. And after this, I also need to close the configuration property which is opened above. So I'll just give configuration. And that's it. When you save it, just ensure there's no errors. If there is any error in your file, just delete that lines and just ensure to add this part alone. So what we have added is, we are just telling the So we are just telling the build pack that, this is the name of the Docker image which you will create, which in our case is backend123. For my case, it is backend123. For you, it will be your Docker user ID. And this will be the project artifact ID. So in this case, it will be gateway server. So with that, we have completed the first step of our Docker configuration. So if you can just recollect on a high level what we did so far with any other new servers. So first we did the POM XML. The second thing, obviously, we have to also edit the application properties of gateway server in order to let it know that what are the few properties which we need to add. And also remember that we are also connecting with the config server. We also have the config server. So what I will do is, just to ensure that we test if the config server is working fine, I will add some properties in my application properties and some properties in my config server properties. Why? Because a few properties I may change over the development and I don't really want to go back to GitHub and change the properties every time. So what I will do is, I'll just split and add the properties. So a few properties I will add in my application.properties, add a few properties. What I will do is, for you, what you need to do is just create a file called as gateway server.property, just the way how you created for Eureka server. Just create one more file in your GitHub repository. So I told you the last way, the way you create any new file in your repository is just go here, add file. Either you can create one from your local and upload it, or you can directly create it from here as well. Just give the name as gateway server.properties. And inside that, I'm just adding 3 properties. So one is info app name, info app description, and info app version. So if you remember our discussion from Eureka server, so why I'm adding this is, when your application is up and you see a link over here, so this link is nothing but it will be pointing to your Actuator info, right? So that is the reason I've just given that, so that whenever I hit that link, I'll be seeing this details. Okay, so this I'm not going to change. That's why I'm just kept it in the config server. And the rest of the application properties, I'll be adding it in my application properties directly. So if you want to test it, maybe after this course, what you can do is you can move all these properties directly to the GitHub repository as well. So even that works fine. So let me add a few properties over here and we'll quickly go through what they are. So what I'm going to do is, in my gateway server under SRC main resources, I've opened the application properties. I've added a few properties over here. Now let's quickly go through what they are. So the first is simple, right? For our config server to know what is my application name, I've added Spring application name. So this will ensure that it will only pick up the config properties of gateway server with the file name gateway server. And since here I'm not going to have multiple environments like default, prod, dev and all, so that's why I've not given the profile name for this. So if you remember from our discussion in Eureka gateway, right? Or maybe, yeah, so if you just go to Eureka gateway application properties, so normally what we do is we also give the environment. So maybe I'll just take the cards, right? So that's where we have multiple environment. So normally what we do is we also give this profile active. Here we have said default, but you can also give as dev or prod. And if you don't give this line, it just means it will take the default properties, right? So since I don't have multiple files, I've not given it. The next is where I want to import my config from. So this will be the same thing, right? We have our config server running at 8071. And now I've also checked in all my changes of gateway server over here. So that's why I've given the config server name. So next time when my application boots up, it will locate the server file name, gateway server name, and pick this up, right? So all these are already we have seen in the previous week. So just a quick recap of that. And this is for our Eureka server. So wherein I say this is for our gateway server. So wherein I say discovery locator is enabled. So when I say discovery locator is enabled, it is important for me to fetch all the running instances of microservice from the Eureka server. So that is what this means. The second thing that I have added this lowercase service ID. So what this lowercase service ID does is, so by default, whenever this Spring Gateway server is configured, it will be configured with the router name of in capital letters. So what is this? Don't worry, I'll show you to an actual demo. It will be easy for you. So for now, just remember that by default your Spring Gateway assigns the routing name in capital. Like instead of small accounts, it will give it as capital accounts. So just to bypass that and keep it in the smaller case, that's why we use it. So by default it is false. So that's why I've kept it false, because in the demo I will be showing to you how we can make it true and do all that stuff. So that's why I just kept it as false for now. The next is web exposure include. So remember, this we have done multiple times so far. So what it basically does is, if under your actuator, that property helps us to expose all the URLs under your which is available under the actuators. Okay, so that was this part. After that, which port we want to run our gateway server. So since we have already used 8070 and 8071, so now we are using 8072 for our gateway server. And all these ports are not mandatory. You can also you're free to give your own port number as well, as long as it is not clashing with any other application. And finally, we come to a few things related to the Eureka stuff. So Eureka instance prefer IP. So remember from a Eureka discussion, this means that it will identify each and every microservice, microservice through their IP address, because IP address is dynamic. So that's why we have set it to true. And we say Eureka client register with Eureka because we want our gateway server to talk with Eureka and be present with Eureka and be managed Eureka. That's why we give register with Eureka. And we also gave fetch registry true because we also want to know like what are the other microservices which are running. And finally, for the Eureka client service URL, this is the Eureka dashboard. So this is nothing but the URL where our gateway server will go and register once it is up, right? And that's how you will see it in the dashboard of the Eureka. And finally, we'll also be doing some debugging and other stuff. I want to show you how the tracing and other things work. So that's why just I've enabled the logging level in gateway server and I've set it to debug. So which means that, as and when a certain commands are executed, we'll be able to see the logs properly in the console. Okay. So this is just for the demo purpose I've added because I wanted to show you how tracing works and other things over the course of time. So with that said, we are done with the application properties, and remember to also kind of check in your changes into your repository which you created for all the config. So just ensure you give the file name as gateway server.properties and you have these 3 lines added over here. So as I said earlier, these are nothing but just the application information detail which will come once you click on this. It will show you the details, right? So now let's do one thing. So we have completed the basic setup of our gateway server. Okay. So now our gateway server is ready to kind of be the central gateway of our entire microservice application and serve us the applications. So let's test if it's really working. So what I will do is I'll just save this and let's start each of the servers one by one. So remember, as I said in the previous week as well, so going forward, whenever we start all our servers, the default or the standard order in which we have to start is first we start the config server. So first start the config server. Either start from here or you just go to src main java of config and give run as java. Anything is fine. So first let the config server complete its booting. Okay, so we see the config server is up. Next, start the Eureka server. So these two are important, right? So first we want our config to be up so that the Eureka and other servers can pick up their configuration. Then we start the Eureka server because once Eureka is up, it will start listening to all the instances that are up. So we just want to ensure that whichever servers are starting after it, they are able to catch it. And after this, you are now free to kind of just go ahead and, start your accounts and cards application. So I'll first go and start my maybe accounts application first, followed by my cards application. So I'll just wait for the accounts to be up and then I will start my cards. We can start multiple servers in parallel. We can just go and click and start, but just to ensure that initially the RAM load or the CPU utilization is not high, I just wait for a few seconds for the server to start loading and then I will load rest of the things in sequence. If your laptop is powerful enough, you can also do this in parallel, no worries. So once I will just start my, so accounts is up. Now I'll start my cards. And finally, I will start my gateway server. So some of you might ask, why didn't we start gateway server initially? We can start it as well. So once you have your config and Eureka up, you can also start your gateway first and then start your accounts and cards. But that's trivial, right? We are not immediately going to start using our application. So that's why I'm starting gateway last. So that is fine. So for gateway server, now I'll just click on this gateway server application.java, go to run as, and now give it. So now I'll give it as run as Java application. So why I'm doing like this for gateways, since we have not yet started a gateway server even once, it's not coming in the dropdown. So since now I have started it, it will start appearing in the dropdown going forward. So you see now, even the gateway server is coming now. So now we'll just wait for a few seconds for the gateway server also to get up. And once it is up, we will first quickly check if it is getting all the servers are being shown in the Eureka dashboard. And then we'll go about checking the gateway properties. So now you see that, Git discovery client, gateway server. So it's now registering with Eureka and doing all this stuff. So yeah, the gateway server is up. So now if you come to Eureka and just refresh, you will see that the gateway server is also kind of listed over here along with accounts and cards. So this is important. So we first have to ensure that, whatever servers we have, everything is up and running. The next thing that we want to do is, you may now ask why we haven't, as we discussed earlier, the config server is not listed over here, because config server is really not the server which is handling the business logic, and also it is not something that, it is kind of the predominant service which is kind of a dependency for many other servers. So that's why we have not added it over here. So this was first thing. So we can verify that gateway server is added. So the next thing which I want you to do, as usual, let's go and explore the actuator for the gateway server. So I'll just go to 8072. So this was the port. So now you see the actuator has kind of exposed a bunch of different APIs. So if you are not able to read from this, you can also make this get call for this URL from Postman. So where it will nicely format you in a JSON structure. So that is fine. So the next thing which I want to show you is under the actuator. So there is something called as a gateway. So you see over here, there is actuator/gateway. So what this does is, it exposes a few URLs which tells us what are the routes which are configured for this gateway. So what I'll do is, I'll just come to my Postman and I will just create a new request. So I'll just call it gateway routes, and here I will just type my URL, which is 8072/actuator/gateway/routes. And if I just hit this URL, you will see that, now it is showing me the list of all the default routes which has been configured. So you see that, so this is what I meant, if you remember from the properties file, by default, the Spring Gateway keeps all the routes in capital, right? So if you see, it has configured this accounts to be in capital, but you know that so far we have been using the APIs in lower cases. So in order to enable that, that's why we set this property to true. So I hope now you are clear why we use this lowercase service ID property. I have, by default it is false, and that's why I have also set it as false. But if you want to just bring all the URLs to lowercase, you can just set it to true. So I can also show you that. So if I just set it to true, save this. So now you see that automatically my gateway server is restarting, because we have kind of added the debug tool dependency. So that's why you'll see that my gateway server, as soon as I make any change over here, it will restart by itself. That's the reason why I added the debug, because I'll be doing a few runtime changes and I don't want to just kill and start my gateway server every time. So that's the reason we have added it in this week. So now the gateway server is starting up. Yeah, so now it is started. Just come back to my Postman and execute the same call. You see that all the URLs have gone to lowercase now. So that is the beauty of it, right? So you see now the path is gateway. So don't worry about this URI. Okay. So this is just for the load balancers. So this always will be in the cap. But I, as an end user, I don't need to now give gateway server or accounts or cards or any of these URLs in capital. I can now live with the smaller case. Okay. So what are the few things? So first thing, as we discussed in the architecture of Spring Gateway, we have three main parts, right? We have a predicate, we have a pre-filter, and we have a post-filter. So in the predicate, we just give what is the path it has to go. And so far there's no other conditions given. It just says matching trailing / as true. So any other conditions also you can mention over here. So after that, we say what is the port number in which it is running. So gateway server runs in 8072, accounts it is running in 8080, cards it is running in 9000, so on and so forth. After that, we also say what are the filters we need to do. So what we say is, anything or any letters that comes after gateway server, just route it to that particular route. Okay. So what we mean by that, I will show to you in demo right now. So what I mean by this, right? When I say rewrite path account / whatever and reroute it to / whatever the text. So what this means is, so let me just go to my Postman and maybe I'll just create a new request. Okay. So I'll just give it the name of gateway request. I'll make a post call. So basically what I'm going to do is, I'm just going to call my accounts API. Okay. So what I will do is, so instead of directly calling it from 8080 port, now let me call it from my gateway server, which is 8072. So this is the change. Remember that I'm not calling my accounts directly or through Eureka server. I'm calling it now from my gateway server. Okay. So now when I run this, so you see now it gives us 404. Why? So that is the reason I said you'll understand it in detail. So basically what my routes does is, so it will first check what is the initial URL, right? So after my 8072, I'm giving accounts, right? So after that, what it will do is whatever parameters or whatever routes we give after this account, it will now route your request to the port 8080 and that request. So say for example, if after accounts I give profile, it will invoke the profile API running on 8080. If I give accounts again, so inside my accounts microservice, it will invoke the accounts API. If I give actuator, it will invoke the actuator. So I just can't give accounts alone. If I just give this part, my gateway won't know what specific API I have to invoke inside the accounts. Okay, so you got that, right? So if I have to invoke the same accounts API, which we do always for 8080, all I need to do is after this accounts, I have to give one more accounts, right? And in my body, I have to give this request body, which is what we give as usual, customer ID 2. And now when I execute this, you see that, I get my response. And similarly, instead of accounts, if I want to maybe invoke my profile, right? The profile API. So the same concept. I just need to change this accounts to profile. I give send. And now you see that, the data is returned where I get both the accounts and cards. Similarly, if I want to just check what is the actuator that is being exposed. So here I just change the call to get. So you see that, all the URLs is exposed now for actuator. So this is how I can access any URLs of account microservices by just appending the word account and adding whatever the specific URL I need to access after that. So here also one beauty that you will observe is I'm now accessing my Spring gateway, right? I'm not accessing directly the 8080 port. So I'm not bothered where my accounts is executing or where it is running. All I'm bothered is I have an application called accounts, and inside that there is some API which I have to execute. So automatically the Spring Gateway does all this mapping where it will first check what is the name of the application which I'm accessing. Then internally it will see what is the port where it is running using the Eureka. And from there, it will just then based on whatever is the API that you give, it will route that request to that particular API. So this is how your gateway works. So I'm sure now you have got a fair understanding of how the Spring Gateway works and how we do it. So let me just quickly recap what we have done so far, setting up the gateway. So the first thing that we did in the gateway service was we first created the Spring Gateway server from the Spring Initializer website, added these following dependencies. The bare minimum requirement is we have to add the gateway dependency, which tells that, this is going to act as a Spring Gateway. The next we add is the Spring Boot Actuator. This is required because since we are going to also access the actuator APIs, that's why we need it. Then since we are going to register our gateway server as a config client, that is we are going to read the config remotely, we are added config client. We want the Eureka discovery client because we want to ensure that we are able to do the load balancing and failovers. That's why we added this. And finally, we just for our local development, I also showed how to use Spring Dev Tools. So this ensures that we are able to do a live reloading and all that stuff. So this is just from a developer perspective, while these four are mandatory. So once you download it and import it in your Eclipse, we first go to the pom.xml, and in order to create the automatic Docker image, we added this configuration image configuration property where we just say what is your Docker user ID and what is the artifact which needs to be generated. So this is something we have been adding all along, so it is easy for you to remember. The next thing we did is we added the application.properties. So wherein this is the standard things that we normally add. So first thing for the config server, we say what is my application name. So it will fetch all the properties names which is having this. Next we say what is the address of my config server. Then for my gateway discovery, I have enabled the locator, and for gateway discovery, I am also enabled the lowercase. So we saw why we are doing this, because by default the Spring Gateway has all these URLs in caps, but since we are following the lowercase normally, so we have enabled as true, okay, so that all our APIs are in lowercase. Then we expose all the actuator based URLs. Then we are running our port in 8072, and for Eureka we have just given the standard configuration, enable prefer IP address and register with Eureka. And for the Eureka client, the same stuff, like we just fetch registry is true so that we get the details of all other instances. And we have given the Eureka URL where we have to register. And just for the tracing purpose, that is like in the future session, I'll be showing you some tracing stuff. So that is why I also enable the logging. And once I do this, that's it. I am not doing any other configuration. So if you see over here, I haven't touched Eureka server, config server, accounts or cards in this session so far. The reason for that is this all you need to do. Your gateway server is, your Spring Cloud gateway server is smart enough to determine what routes it has to do and how it has to route your application. So with that, we are good to go. And finally, what we did, we just started all our servers. Then I showed you how the gateway routes are configured. So for that, what I did, I just pointed to 8072 port, which is where our gateway server is running. I went into Actuator and there is a URL exposed called as gateway routes. So when I hit this, you saw all the routes that have been pre-configured. So for now, we have this accounts and cards which are running along with the gateway server, right? And I also showed you how you can access any APIs from the gateway server going forward. So all you need to do is just go localhost 8072, which is our port number. Then after that, give the name of the application. So in our case, it is accounts, like whatever is the application name. And after that, you give the actual API name. So if you want to access accounts inside accounts, give accounts. So that will ensure you are able to hit the accounts API. And if you want to hit the profile, just give account/profile. It will hit the profile API. And similarly, if you want to hit your cards API, right? So you just give cards, and again you have to give cards, because inside cards application which API. So now it ensures that even the cards is working fine. And similarly, if you want to just access maybe Actuator info, just for example, so you can just do that. So this will return the info details of the card API. So this will be a get call. So yeah, so now you see the details are coming. By this, I can now quickly access the APIs of any of my microservices without having to worry about which port or which server they are running. So that is the beauty of my Spring Gateway, where it does all the automatic routing by itself. So this was the one part of discussion. The next part of discussion, which is one of the challenge of implementing microservice, wherein how can we implement custom routing. So far we saw that your gateway gives you certain default routing, right? It gives you certain predicates and stuff like that. But what if I now have a scenario? I'll just give you a scenario. So just imagine, like, if this is my, so I have a API URL like this, beta accounts, and then I do a profile. Okay. So currently if I try to hit this URL, right, router, so it will say that 404 not found, because we have not configured this. And as I said, one of the use case for this is, what if I have two versions of my application and I want to ensure that the beta users are kind of routed to a different instance of account, wherein I don't want to really do all that routing by myself. So for this kind of scenarios, how to implement it without doing much changes to your application logic, we will be seeing in the next session, which is called as the custom routing. And finally, we'll be also looking into the cross-cutting concerns. So that's it for now. We have come to the end of the second session, and I'm looking forward to see you in the next session. Thank you. Hello everyone, and welcome to this session of implementation of custom routing. So in this session, we'll be seeing how can we implement custom routes based on the Spring Gateway server which we have implemented in the previous session. So now let's go back to our application which we have developed so far. So just to quickly recap, we have so far implemented our Spring Gateway server, and we also saw that a few default routes which the gateway server provides to us. So we saw that it gives us, writes a few default rules where anything after the accounts will be routed to the port 8080, anything after cards will be routed to 9000, so on and so forth. The Spring Gateway does automatically based on the Eureka server configuration which we already have. So now the requirement is, as I said, what if I have a URL like this, right? So if I want to access something like /beta/account/profile, right? So wherein I say, instead of directly accessing accounts profile, I want a section of my user to be redirected to a different server based on certain parameters in my URL. So how can I do this routing? So if it is a traditional way of doing it, I hope you know that I have to first create a project with the name beta, then define the routes inside the beta, and we can do it. But I don't want to really go that route and just duplicate my code just for a few changes. So rather what I will do is, I will just implement custom routing in my Spring Gateway, wherein I would say that if there is any request that is coming as /beta/accounts, so I will just still route it to my 8080 accounts. Okay. So here what I'm going to do is, even though it is a different URL, I'll still kind of route it back to my accounts. This is for the demo, but you also can implement it in a way where instead of routing it to accounts, you could also route it to a different microservice instance altogether. So that is up to you. So I'll first show you the probability or what are the things that we can do with this. So to do that, the first thing that I want to do is, let's get into the main class or the gateway server application.java. So this is where we kind of have to define the custom routing part. So how we do that is, so there are a few configurations which we need to add here. And remember that in the previous session, we just, since we have also connected it with the Eureka client, it is better that we add this enable Eureka client annotation in case if you have also not added, because since we are going to connect this gateway server with Eureka client, it is important that you also annotate it with the enable Eureka client. So this is not part of the custom routing, but yeah, just since we saw it, it's better, we thought we will update it. So now what are the things that we need to do? So the first thing that we need to do is we have to define a bean annotation. Okay, so this is a Spring Boot bean annotation. So we also need to import it. So after that, so basically what is a bean if you know a bit of Java? So basically whenever we apply the bean annotation on a method, it just tells the Spring Boot that we have to return a bean out of it, which will be managed by the Spring context. Okay, so what this basically means is, as you may know that in Java we have this concept of Java beans, which is nothing but it's just an encapsulation of one or more objects into a single object. So basically what happens is, whatever objects we define inside now this method, all this will be returned as a single method at the runtime and will be managed by the Spring context. Okay, so at the runtime. So that is what this bean annotation does. So after that, we'll be defining a method. Would be route locator. The type of the method would be route locator, since we are going to define custom routes. And here you can give the name of the method. You can give my routes, or you can give maybe custom routes, like whatever you want to define, that's up to you. After that, in the argument you have to send the builder, so which is the default data that gets passed. So the type of that is route locator, and the name would be builder. So next, just define a method, and while you do that, now you are free to import all these things that are pending. So import route locator builder, import route locator. Yes, and now inside this you are kind of free to define, and this error that you see will be gone once you define the body, right? So what we do is we have to now return this builder with the routes that we define. Okay, so anything that you define now will be considered as part of the custom routes. Okay, so just for better readability, what I'll do is I'll just type in the next line, so it becomes a bit easy for us to know what we are typing. Okay, so the first route which I want to define is for maybe my account services, right? So I'll just take, so this is just the standard syntax. Okay, so there's nothing that you have to remember over here, so just follow along. So first I say p, which is nothing but the path. So I say this path, and inside that I just say patterns. So there'll be a few automatically happening. So I would say that ensure that you just don't follow that, and just type the code as I'm typing over here. So just give me a few seconds. I'll quickly type it. This auto completion is just throwing some issues. So I've just typed all this in a notepad and pasting it here directly. I just had some issues with my data. So what we have done, just let's quickly go through so it's easy for you to understand. So this is all standard syntax, which is we have to follow from the cloud gateway. So nothing like specific we have to remember. You can even look it up in the internet, you will find it. So the first thing is we are just annotating it with bean, which means that all these objects which we are defining now will be returned as a single object and managed by the Spring context. So that's why we annotate it with the bean annotation. After that, we define a method called as my routes, or you can name it any right. You can also give it custom routes if you like, or like any other names which is relevant. After that, you give it the type of route locator, and inside that you pass it a builder which is of the type route locator builder. And basically what you need to do is this method has to return this builder routes, so where we define each and every route. So ensure that every route is also connected with a dot, meaning that we have to chain every route. You cannot have independent route. So you have to, at the end of every route, if you have further routes, ensure that at the end of it you also chain it with a dot. So here what we say is for the path, we define the path. So we say that any URL which starts with /beta/accounts, then we add our filters. So we say that in the pre-filter, if any URL comes with beta/beta/account, then whatever is the segment or whatever is the URL that comes after the accounts, we just take that part and we will be adding a response header to it. Okay, so what is this response header is, we are just telling that, if anything is kind of /beta/account, for now I'm just adding a response header to this HTTP request with that name of version beta. Okay, and similarly I'm just telling that, if any request comes with /beta/account, you just kind of load balance it and send it to the accounts application. And similarly for the next path, I'm also doing the same stuff. So if anything is coming with /beta/cards, I'll just rewrite the path. I'll just take the segments after this beta and I'll be routing it back to the cards. Right, and here also I'm adding a response header of version beta. So here it's basically nothing but a post filter, right? I'm adding a response header. So what I'm doing basically is, in a central location, I'm just marking whatever beta request I'm getting. I'm just marking the header or response of that particular HTTP with the version beta, just to let my user know that, hey, you're using a beta version URL. Okay, so this is also some of the probabilities. So we said, right, a gateway server has both a pre-filter and post-filter, and we can do certain common concerns. So one of the concerns is this. So if you want to add kind of a response header into the HTTP request, so we can do that from here. Okay, so with that, we are good to go. So as I said, I'm just repeating myself again. So what we are telling over here is, if there is any URL request which comes with /beta/accounts after my gateway server port, so I'm telling that you just take the segment or the URL which comes after this accounts and you directly route it to that particular application which will be running inside my accounts application, right? So when I say .uri lb accounts, it means that all this request will be now routed to this account application. So similarly, if you have any other application, maybe like beta account, here you can define that LB is beta/account or beta accounts or whatever it is, right? So that is how we kind of now reroute our existing URL to a different application. And also I've added another kind of and functionality where I'm just adding a response header to this HTTP request. So what is this header is nothing but, see the postman, right? So whenever we make any call, so just assume that I made this call. So normally we just check the body, but you also have something called a header which is attached with this request. So wherein the server will attach a few details along with this. So normally you will just have the content type, which is application JSON, because any API call that you make, REST call that you make, it is of the type application JSON, and it will say what is the content length. So but here I'm also attaching a custom key which is the version, and I'm saying it is beta. So that is what is happening over here. And same I'm doing for cards as well. So if anyone is now accessing beta cards or beta accounts, they'll be routed to my accounts and cards, and they also will see a custom response. Okay, so just ensure that all your servers are up. Okay, and since my gateway is, I've added this auto restart functionality, so it will automatically update. So you can see over here it is now shutting down, and once I save it, it shut down and it just restarts the server. So once this is completed, what I can do is, yes, I can see now it is up. So I can just go back to my postman. So just to verify, the last time when I ran /beta accounts profile, it gave me an error, right? It threw me an error stating it is not found. And in the header also, I don't see any custom response. But now if I just run it again, you see now, no, I got a new header called as version, and the beta is added because that is coming from a Spring Gateway. And similarly, in the body, you see now I'm getting the response. And similarly, if instead of profile, even if I run some other API, so maybe I'll just run accounts again. Right, so you see now that it's returning me the accounts detail. And similarly, instead of accounts, if I do it for cards, so always remember, you have to, after the beta cards, you have to pass the name of the API which you want to invoke. So if I just want to access cards, so now you see that even the cards response is coming fine. So this is how we can implement the custom routing in the Spring Gateway service. So I hope that is clear to you what we have done so far. So I'll just quickly recap what we have done so that this really stays in your head. So step 1, we first understood why we require the Spring Gateway, because we wanted to have this capabilities of doing custom routing, and also at the same time implement the common cross-cutting concerns like logging, tracing, auditing and all. So that is the reason we have the Spring Cloud Gateway which will manage the routing and all the stuff for your entire microservices. And the Spring Cloud Gateway in turn will be talking with your Eureka server in order to get the real-time details about all the microservices, instances and all that stuff. So that is how it is able to create the first default routing by itself. The next thing that we have, or the concern that we had, was we also had a situation, say like in tomorrow we want to have a new URL, right? So say to my end user, or based on certain parameters in my query, I want to ensure that this particular request goes to a particular server. So in our case, we just took a simple example where I just appended /beta in front of my accounts and cards, but still I want to route it to the same accounts or cards microservices. in this kind of scenarios, what I basically will do is I'll just define a custom routing. So how to define a custom routing is just open the main class of your gateway server, which is gateway server application.java. Over here, we just have to define a method called, just give it a name, maybe custom route. And inside that, by default, you'll get this builder passed to it. So inside the builder, we have to define the route. So this is the standard template. One single route will have this much, like, you have to define this. So we say inside the route for this path, which is /beta accounts, we then apply the filters. We say rewrite path miss. We just kind of take the segment of the URL which is coming after the accounts and we just reroute to that particular account. So that's why we say rewrite path. And also optionally, as I said, we can add cross-cutting concerns. So one kind of the demo which I did over here is I'm adding a response header to it, which is like I'm just telling, please mark this API call with the response header of version and the value as beta. So similarly, and also finally, any request that comes to beta accounts, reroute it to the accounts application which is running on 8080 port. How will you know it is running on 8080? Because from the Eureka server, this will find out where the accounts is running. So similarly, even for cards, I'm doing the same stuff. Any request which comes with /beta/cards, I just rewrite. I just first fetch all the segment details of this beta cards and then directly route it to that segment API. And in this case, I'll be routing it to my cards application. And finally, I'll also be like kind of adding this response header of version beta. And finally, when we complete all the route, we just invoke this build as well. So this is how we kind of do the custom routing. So that was a very simple example of how we can do it. Once you do that and come here and hit your APIs, you will see that now in the headers, you will see this version beta is now getting appended by default for all the calls for where you have beta and accounts. But remember that, in case I'm just hitting the normal kind of accounts, right? I'm not going the beta route. So if I just remove the beta now and I just hit the normal cards. So here now you'll see the version beta is missing because this is a custom route and only the routes which are matching this particular criteria, only those would be kind of handled by this custom route. So for all other routes, it will be going through the default method. So similarly, even for your accounts, the same thing will happen. So if I do accounts, you'll see that there is no header added but still I'm getting the data as usual because it is following the default route. So I hope with that it is now clear how the gateway works. And just before we wrap up this session, I just want to quickly revise the schematic diagram of how our microservices is currently working. So this just makes the idea clear to you. First, understand that we have developed two microservices, right? One is your accounts, one is your cards. And in your assignments, you're also doing your loans in parallel, right? So we have these three microservices. So initially what we did is all these three microservices using our, like if you are going the Docker image path, we have kind of made them all sit together in a network called as the bank network. Okay, so we'll just consider that scenario for now. Okay, and even in your local server, when you run, all of them are running in a different port, and if they want, you can still talk with each other, right? All these three microservices, they are running independently in their own ports, right? And in Docker Compose, they are all connected in a virtual network called as bank network. So the first thing that we did is we understood that each of them have their own application properties or configurations which needs to be taken out of this application. So that is the reason what we did. We developed something called as the config server, right? So what the config server does is it is also a different server, just like accounts cards, it's also a microservice. Since it's isolated, what it does is it will read the data from GitHub, all the configuration from GitHub, and it will then pass it to these applications. So that was step number one we did. After that, we understood that, if I have like thousands and hundreds of applications of my microservices running, how do I ensure that accounts is able to talk with cards just with the name of the card, but not knowing the IP address and port of it? So that is the area where we thought, okay, let's now implement the Eureka server. So what is Eureka server? It is nothing but your service discovery and registration service. So here what basically happens is, just like config server, it is also a separate microservice which is running. And as I said, it's not necessary that you should have only one Eureka server running. You can have even as many instances of Eureka server running. So what basically happens is, in my Eureka server, I will basically configure it in such a way that I will have a server running, and each of microservices which is running will become a client of this Eureka server. So that's why, if you remember, even now when I created gateway server, I kind of added this enable Eureka client now. now, because since this is also depending on Eureka server, it has to be marked as a client. So the next thing that happens is, once I had this Eureka server, now every time any of my microservices is up or down, it will communicate that to this Eureka server, and Eureka server will also monitor how much instances are up and down. And also another beauty of Eureka servers is Eureka servers know that which application is running in which IP and port. In case if I want a scenario where my account has to talk with cards, right? That happened with our profile API. So when we hit our profile API, from our accounts, we are talking with cards, right? So in these kind of scenarios, what happens is I don't have to manually call each and every port. So I don't have to say local, like, the card is sitting in localhost, maybe like, 9000. So I don't have to invoke the API like this. All I need to do is, if you just remember the code that we saw yesterday, so I'll just quickly show it to you. So remember, we defined this card fiend client in yesterday under the account. So what we do over here is we just simply do a simple request mapping where we say that, just make a post call, or the API URL that we will call is the cards, and it is of the type application JSON. That's it. So automatically what happens is internally your Eureka will determine which IP and port are my cards application running, and using load balancing mechanism, it will route it to one of the instance that is running. So that is the beauty of Eureka server. So now today, the other challenge that we saw is, hey, but is there a way that whenever an external client is kind of like accessing my server, is there a way I can just have a central gateway server which will kind of act as a policy enforcement point and also implement cross-cutting concerns and custom routing? So far we have seen what is custom routing. So just an example is, if to the outer world you have just exposed /cards, but to a few of the user you want to give access to a special version of cards. So say maybe I would say /cards/ maybe new version, something like this, right? So these kind of scenarios, I just want to ensure, like, at ad hoc or random times when I do such ad hoc changes. So instead of going and doing changes to my entire microservice architecture, I can quickly just do those changes in my gateway server through custom routing. And also, since now all my request is going to go through my custom gateway server to the microservice, it is important that the gateway server also talks with the Eureka server to get all the instance details and all the stuff, all the health status. So that is why we have added the gateway server as a client to Eureka server, so that it's also able to talk and get all the instance details. And finally, in the next session, what we are going to do is, so far we have understood how to do the custom routing part. The only part that is now remaining is the cross-cutting concern. We already saw a bit of it when we added the header part to all of our requests, which is coming from /beta/account. But what we will do going forward is, in the next session is, we'll be adding a bit of tracing capabilities. So as I said, what is tracing capabilities? So just a quick understanding of that before we get started. So let's assume that, just take a hypothetical scenario. Say, assume that this is my user who is hitting my application, like my API, and assume that, this is an API. So maybe say it is /profile. Okay. And this profile internally calls maybe 3 applications. So say one is accounts, one is cards, one is loans. And assume that even inside accounts, I may have some 2 services. One could be saving back account services, one could be current account. Even in card, I could have 2 API services. One could be your credit card, one could be your debit card. And under loans, I could have like, maybe home loan, vehicle loan, personal loan, so on and so forth. And now assume that, today at 12 o'clock, one of my customer is opening my application and he or she is seeing an error. Okay. And you as a support person or a developer who is supporting the application now has to fix it. So if in this kind of scenario, assume that I tell you that, hey, please go and debug the application. Imagine the pain that you will have to go to see each and every logs, each and every server, and find out where the request came, when the request came, how the request came, and where it failed. Because as of now, you have no tracing mechanism or no such mechanism where you can say that, maybe at this time or this point, this request originated here, then it went here, then it went here. It also went over here, then it went here. And probably it might have failed over here. And due to that, the rest of the things also failed. So if you do it in a manual sense, what you have to do is you have to technically log into each and every server, scan the entire log. Like, maybe if the error occurred at 12 o'clock, maybe from 11:55 to maybe 12:05, I'm just giving a random time window. You have to see the entire log to understand where the issue happened, when it happened, how it happened. And in case you're not able to find it in one server, you have to repeat it in all other servers. Okay. So in order for us to kind of quickly find out how long the request got executed before it failed and where it failed, we have this concept of tracing. So what the tracing basically does is, I'll just conceptually explain in the same example. So assume that this is my slash profile, and from slash profile, I have my accounts, I have my cards, I have my loans, and again I have 3 microservices under it. So this is how my microservices call each other. So what happens is, when my user is calling the slash profile, I would here create a unique trace ID for this particular transaction. So what happens is, whenever I create this unique trace ID, and whenever this request now flows at each level, right, the same trace ID would be carried forward at each level, and say tomorrow if I have to debug this application, or even for that matter know what is the total turnaround time for a single request, all I need to do is I need to search the servers for this particular trace ID, and in whichever servers see an error for this particular trace ID in the log, I know that in that particular server the request has failed. Now you may have another question that, but still I have to kind of search each and every server, right, for this particular trace ID. What is the solution for that? That is also a manual process. So don't worry, in the next week, that is in the week 9, we will be seeing something called as the Zipkin, which is kind of an aggregator for all the logs in your servers, and it gives you a nice dashboard which gives you all the status. And also I'll be covering a bit about the Spring Sleuth. So what is Spring Sleuth is, though in this week we'll be adding trace ID just to show the functionality, but to do the actual tracing and make it really quick, we have a dedicated module in the Spring Cloud which is called as Spring Sleuth, through which we can achieve this very quickly. So what happens is, the Sleuth will kind of do the tracing part, and it will dump the data into Zipkin, which will give you a ready-made dashboard with all the details. So that was kind of a summary or a prelude to what we will be doing in the next week. But for now, just don't worry, just to show you how we can implement cross-cutting concerns. So as I said, cross-cutting concerns can be of many types. It could be security, it could be auditing, it could be logging, it could be tracing, so on and so forth, right? But since we cannot cover everything in this short video, so it is better that and all of these are a course in themselves. So what I will do is, I'll just take the small example of tracing, and I will show you how we can implement tracing using the Spring Gateway. Okay. So this is one way of implementing this tracing method. But also in the next week, I will show you what is a better way of implementing tracing using the Spring Sleuth. Okay. So don't get confused why we are doing the same tracing twice. So this is just for a demo to show you how the cross-cutting works in Spring Gateway. But the actual tracing which we will implement will be using Spring Sleuth. So with that, we have come to end of this session 3rd. And in the next session, we will be now implementing the tracing on the Spring Gateway. Thank you, and looking forward to see you in the next session. Bye. Hello everyone, and welcome to this 4th session of the demo on implementing the cross-cutting concerns through tracing. So as we discussed in the previous session, just to show the functionalities of Spring Gateway server and how it implements the cross-cutting concerns, we will be taking the example of tracing and implement it. So in order to implement tracing, the thing that we need to do is in our gateway server. So it is very simple and straightforward. Since all our requests are going to flow through gateway server, we just need to kind of implement these in our gateway server itself. We don't need to touch our other images. So the thing that we need to do is, in order to implement this cross-cutting concern, we have to implement a few filters. So if you remember from our discussion of Spring Gateway architecture, we saw that a Spring Gateway has pre-filters and post-filters, and it has certain predicates, right? So here, since we are going to implement the cross-cutting concerns, we'll be implementing a few pre-filters wherein we'll be adding all this tracing capabilities. So I will just tell you first what we are going to do, so it becomes easy for you to visualize, and when we implement it, it becomes easy for you to understand as well. So coming to our whiteboard, so I'll just tell you what we are doing right now. So assume that this is my user who is making a request, all my microservices which is over here. So he can request any number of microservices. And what I have over here is my gateway server, right? So what I'm saying now is, whenever there is an HTTP API request or REST call that is being made over here, I want my gateway server to first check if there is any tracing ID or generated for this request. Since this request is coming new for the first time, so obviously there will be no tracing ID generated. So what my gateway server will do is, using the pre-filters, it will generate a trace ID, a unique trace ID. That's important. Okay. So unique trace ID for each of these requests, okay, and add it before sending to my microservices, okay, and my microservices internally can call each and every one, like how we saw for profile. So when that happens, this trace ID will still be used across all that flow, okay. And finally, when my request is completed and it reaches my gateway server, now I can also send back this trace ID back to my user as well, okay. So whatever trace ID got generated, probably I could also add it to my response header and send it back to the user. So this is usually not done, in most of the scenarios we don't really expose our internal data to the external users, but you may have certain scenarios, right? So assume that you are a support developer and now you want to actually check which trace ID got generated for your record, and you want to just kind of do a quick debugging. So in this kind of scenario, it will make sense that if you are getting back in response what trace ID was used, so it might help you in future as well. So just to know that which trace ID was used, and it will be easy for you to kind of debug. So that's what we are going to do. So just to recap, whatever incoming request is coming into our gateway server, we will be generating a trace ID and adding it to the request. And once the request goes to our microservice, gets executed and comes back, we will be appending the same trace ID back in the response header as well. Okay. So this is what we are going to do. And how we are going to do it, since we saw in the architecture of Spring Gateway that we have something called as the filters, that is the pre-filters and post-filters. So using pre-filters, we will first generate the trace ID and put it in the request. Using the post-filters, we will add that trace ID back to the response header and send it back to the user. Okay, so basically we'll be utilizing filters of Spring Gateway to do it. So with that clear, now let's get back to the application. So what we need to do first is, in the gateway server application, we first have to create a new package in order for us to define all our filters. So what I will do is, I'll just go to Java, this src main Java new package, the same nomenclature what we used. So usually what we do is in.bank. Because that is what the group ID is, so we always give the same ID. After that, the artifact name, which is your gateway server. After that, you just give filters. Okay. So when that is done, now you see a new package is created. So inside this, we now have to create a pre-Java file. So what are they? So first is, we have to create the pre-filter or the request trace filter file. Then we also have to create the response trace filter file, right? And also we will create a utility file which will do the work of creating and setting the trace IDs. So first, let me just create the utility file. So I'll just do a new class, and here I'll give the name of this file. So I'll just say it as filter utility, or you can also give it the name as trace utility. It's up to you. Okay, so this is just a utility class which will be used by my filters. So what I'll do in this is, so first I will annotate it with the component annotation and ensure that you kind of import it as well. And what this @component does is, so it basically tells the Spring Boot application during the startup, you have to auto detect these classes and you add it for the dependency injection. So it kind of is available to your entire application. So that is the use of having this @component. Okay. After that, we have to now also define what is the string ID. So the name of our trace ID. So we can give it a name. So generally the name that we prefer is the correlation ID. So I will just declare public static final string correlation ID, and this will be the name which will be returned in our response header as well. So we'll just give it the name correlation ID. Okay. After this, now we have to create kind of helper methods which help us to get and set this correlation ID. Okay. So what I'll do is, first I will define a method which will get me the correlation ID. So I'll say public, because I have to expose it. So public string get correlation ID. Why we are putting HTTP addresses? Because I'm going to listen to the incoming request, right? So I'll say request headers. So first I will check in the incoming request header if there is any correlation ID set or not. So by default it won't be set. So that's why, like, we say that, in the first time when there is no trace ID found, we will just go and set the trace ID. There's a small typo over here. I have given single quotes. It should be double quotes always. And after that, now we have to return, write our logic over here. So what I will do is, it's a simple if condition. So I will just say request headers dot get if there is a correlation ID which is not equal to null, then I say request ID. Okay. So what I'm basically doing is, if I see the correlation ID present in the request header, I first populate all the kind of the correlation ID which I get as a list. And after that, just ensure to import the list, and also this null has to be in lowercase thing. Okay. After this, you just return list dot stream find first, and we will also add a else statement, return null. So which means that there is no correlation ID present in the request header. I'll just quickly recap what we have done. So we are telling that, when you get a request header, just check if there is something called as a correlation ID. What is this correlation ID? But nothing but this correlation ID string in the header. If it is present, not equal to null means if it is present, then what we do is we just get whatever is the value of that correlation ID and return it. Okay. So what this find first get does is, so whatever is the first instance of this correlation ID. So generally we just have one header with name correlation ID, but generally for the safer side, if there are multiple values passed, so just on the safer side, we just get the first occurrence of it and we return it. So here my HTTP header is not yet imported. So just ensure that you are importing this HTTP header from Spring framework.http. And once you add that, all these errors are gone. So this was the first utility that I created. Okay. So the reason I'm first creating utility classes, then it will be easy for us to understand how our the request and the response tracing filters are working. So after this, I just need to create two more utility classes, or rather methods. So one is setting my request header, and second is setting my correlation ID. So first, I will create the method for setting the request header, when it is sent back to my user. So I would say public. The data type is server web exchange, because we are dealing with the REST APIs. So these are all pre-built types which we get. After that, set request header. Again, give the name of that as maybe exchange. Then we also get the name and we get value. So these are the arguments which will be passed to this by default. So once we get that, so all we need to do is we just return a single line which states exchange.mutate. Why mutate? Because we are going to change the request header, that's why. So we say request exchange.getRequest dot mutate dot header name, and since the header always has a name and value, that's why we put name and value dot build. So this name and value will be nothing but the name will be passed as correlation ID and value would be whatever the tracing ID we generate. So we will see how we do that when we actually build our filter classes. And after that we just build this and set it. So once we are done with this, similarly, we also need to have a utility class which will be setting our correlation ID. So far we have just set request header with the correlation ID. Similarly, we also want to now set the correlation ID itself to the request header. How to do that is, so the same stuff, server web exchange. Just return this dot set request header exchange correlation ID. So it automatically generated everything. Only single correction which we have to do is just replace this correlation ID with this ID, and the rest of the things remain as it is. So once we do that, we are now good to go. We have built our utility classes. So one utility class, what it does is it will set the correlation ID to the request header, and this request header is nothing but you just get the correlation ID from here and you just mutate your API call and set the request from there. So now let's build the request and response trace filter. So that will give us an idea of what is happening. So the first thing that I do is, in my filters, I will first create a filter for the request, for the pre-filters. So what I will do is I will just go to right click on my package. I'll go to new. I will click on new class. So maybe I can give it a name of, say, we can give it any name. So we can also give it name like pre-filter tracing, or you can give it name like trace filter, or whatever you want. So you can just give it any name. So I would say pre-filter tracing, or I can even say pre-filter request trace, something like that. I give finish, and we'll also create one more filter now itself. We will call it the post filter request trace. Okay, so don't get confused. What we are doing is, if you remember from the architecture of Spring Gateway, we just said we have a pre-filter and post filter. So one filter works on the request as it comes in, where we are actually setting the correlation ID, and the other request, which is a post request, will then set this correlation ID to the response header and send back to the client. So that's why we have two request filters, and there are a few methods which we will be using in both of the methods, or we want it to be outside the filter methods. So that's why we have created a utility class, so we can keep it externally and call it or use it in any of these filters. Okay, so that's why we have the utility class. That's it. So first, let's see what we put inside the trace filter. So remember that this will be the first filter which gets executed anytime your request comes in. So we have an annotation for that which says order 1, which means that this takes a higher priority than other things. So just ensure to import it. So this is the first annotation, and the second annotation is, obviously we have to also put the component annotation stating that this has to be auto detected and injected across your application. So now this is going to implement a global filter. Okay, so we are going to inherit global filter class from Spring Gateway. So we have to put this global filter, so which will give us some extra utilities. So just ensure to import this global filter, and once you do that, it's pretty much the standard code that we usually write, right? So the first statement is you have to now define a logger. So why we require logger is, as I said, a trace ID is only generated for the logging statements, right? So that's why it's important that now you have to kind of define the logger. So what we do is private static final, it's the type logger, and the name of the variable will be logger. So remember that type always is in caps and the variable is always in smaller case. Then we say logger factory. First we'll type it and then we will import all the things. So we say get logger. So inside this, I have to now give my same class and dot class. So basically I'm telling just get the logging of this pre-filter request trace class. Okay, so now quickly just import all the loggers over here. So for logging, ensure that you are importing the SL4J logger. Okay, and similarly, yeah, so I think we are good to go. So after that, we have to now give auto wired because we have to like ensure that this filter utility is bound. So we just give auto wired filter utility. This filter utility is nothing but what we created now, right? After that, we now have to override a method which your global filter implements. So we give this override annotation and we say public mono of the type void, give it a name filter, server web exchange, gateway. So these are some of the utilities which your Spring Gateway exposes. So don't worry, we don't really have to bother what they do internally. But these are some of the utilities or filters which your Spring Boot offers. Also ensure your override OS capital and you import it as well. So import auto. So whenever you see this import error, just quickly import it. Import mono as well. And so once that is done, we now just have to define our method. So what this does is basically we are just overriding the default, the method which is given by your global filter and writing our own custom method. So what we are saying over here, it's very simple. So we say if the correlation ID is present, then fine, we just say what is the correlation ID found and we log it. Else, we just create a new correlation ID and log it as saying generated correlation ID. So we are adding this logging statement just for our understanding, just to know that if a correlation ID was found or whether we are generating it. It's just for demo purpose. So we'll just quickly add it. Yes. So we have completed the coding. I'll just quickly walk you through what we have done. So far, I hope you understood that, we have created a filter utility which we have auto-wired. After that, we are overriding the default method which is provided by global filter. That's why we added override mono void filter. That is the name of our method. So what we are basically doing is, in this we are first fetching the HTTP headers which is coming in. We will check whether in that HTTP header if the correlation ID is present. So this is nothing but we have defined it over here. So what we are basically telling is inside our filter utility we have defined this get correlation ID, right? So if you see over here, we have defined this get correlation ID. So basically what it does is it will check the request header if there is something called as correlation ID, which is having the string this. If that is that, it will return that particular correlation ID value. If not, it will return null. So here in the pre-filter, what we are doing is we first check if that correlation ID is present. If it is present, I am just to know that, to let us know that it is happening, I'm just writing a logging statement, logger debug correlation ID is found. If not, I just say that, I first create a new correlation ID. For that also, I'm using the filter utility. So in that, I have this method called as set correlation ID, where I now manually set the request header with the correlation ID. So that's what I'm doing over here. And also I'm logging a statement, a debug statement called as, which states that, correlation ID generated with in the tracing filter, and this is having this correlation ID. And finally, I'm just returning the chain.filter, which will be used for the further processing in the gateway. Okay. So this is what I've done. And, we are ready to test if our trace request filter is working fine. So how we can test it is quite simple. What I'll do is I'll just call any of my API, and that should trigger the logs over here, right? So what I'll do is I'll just come to my gateway server application, and I will also clear the console. How to clear the console is this fourth button over here. This is the clear console. So what I will do is I'll just go and clear the consoles in my gateway server application so that we can easily find the logs which is coming here. So if we just make a call, right? So if I just make a call to maybe my filter, right? So through the gateway, or maybe even to the accounts. So you see that, now we are getting this log correlation ID generated in the tracing filter, and this is the tracing ID which was generated. So now if you have to check the logs, right? So what happens is in our application, this request will now be generated with this tracing ID, and all the logs will be now using this tracing ID. So we have completed one part of the process where we have now actually generated a tracing ID. But we'll also do the next part of our work, wherein we also want to return this tracing ID back to the user. So now if you check the Postman, in my headers, there is no correlation ID present, right? So I also want to now show you how we can add a post filter tracing mechanism, wherein I can also now add back this request ID back into my request response as well. So to do that, it is a similar stuff what we did over here. So we just need to kind of define a global filter where it will be hiding this correlation ID back into my response header. So let me just quickly do that. And also we need to do a few changes inside our accounts and cards because it has to accept this correlation ID. So I will also show you how we can do that. So first let me quickly complete this post filter request file. First quickly type and then tell you what we have done. So for now this file is blank. Let me just quickly type it out. So ensure to always import this logger from SL4J and not from any of these other utilities, or else this will throw you error. Okay. And also import the mono. So I think we are good. HTTP headers imported from the Spring. Yeah. I've written that code. Now let's quickly see what this post filter does. So basically what we are doing is we say that this is a configuration. That's why we added this configuration bean. So which will be processed and used by Spring to generate the definitions. So here again, invoking this SL4J logger where we say get the logger from this class. And what we are doing over here is, and we have also wired the filter utility because we are going to invoke certain methods from there. So what we did is we have now defined this global filter. Okay. And this global filter, what it's going to do is it is just going to, from whatever request we are getting, it is going to kind of get the request header and it will check what is the correlation ID which is already present and add it to this particular header and send it back. And also just to know that we have added it to the response header, I'm also logging it as a statement stating logger.debug added this response header. Okay, so now we have added this correlation ID back to the trace ID, and if we can also quickly verify it using Postman. So if I come to my accounts and now I hit on this and I come to my header, you will see that a correlation ID is present with whatever trace is generated. And you want to know if this is the correct trace, just see the first few characters, right? 2CF3. And here in the log, if you just check for gateway server, just come to the log of the gateway server, you will see that 2CF3 was the one which got generated for this request. So we are good in that aspect. So that's how you kind of add this correlation ID. And I hope now you got an idea of how we work with this. So I hope now you got how we can add the pre and post filters. So this was just a simple example where I just added a trace ID, and also in the post filter I sent that trace ID back to the client. Now there's also another utility or another usage of this. So assume that inside my application I have some requirement wherein based on certain business decisions, the requirement is that even the APIs which are running in my accounts or cards should be able to consume or know what is the current trace ID for the request. Maybe they are doing some logging or some other stuff. So in order to do that, we just need to kind of also consume the request header which is coming. So for now, if you just see, right, what we are basically doing is we are just consuming the request body that is coming in. But if you also want to listen to what request header parameters are coming in, like the correlation ID or anything else, we can also consume that. So to do that, it is very simple. All you need to do is just before this request ID, you also have to now kind of pass the request header as well. So I can just say @request header. And the one that I want to read is the correlation ID. Okay, because that is what is being sent. So if you just come to the Postman, you'll see that we are sending it as correlation ID. So that is what I want it to be sent as, and I can give it a name of string and say correlation ID. Okay, and similarly in my cards detail also I have to now send this correlation ID, because here I'm invoking the cards API. So I have to ensure that I send this correlation ID over there. And also since I'm sending now it to the cards detail API, I have to ensure that I am updating this as well. So for that, what I need to do is just get into the cards detail API, and the same thing you will do over here. So not to just type the entire thing again, I'll just copy this entire bit and ensure that you import the request header as well. And inside my card details, I just need to add this back. That's it. And here also I just need to import it. So just ensure that this request header is coming from the Spring framework and we are good to go. And one more thing, since we have also implemented our resiliency in the previous week, so just ensure that when you come into your accounts, and we have also defined a fallback, right? So let me just quickly show it to you. For the profile, and also one more thing, just remember that the last time we also implemented the circuit breaker patterns, right, where we implemented this fallback method. So ensure that you are also adding this request header over here, and also like when you add it over here. So that is the one thing also which you have to remember. Oops, that is a typo. Yeah, so that's what I wanted to say. So just a quick recap, I just said whenever we want to consume this trace ID within our application, it is important that along with your request body, we also pass this request header of correlation ID, so that if in your application you want to do something, you can do that, and it becomes available inside your application. So with that said, since we have made the changes to the account server, I will just quickly start it again, and also our cards application as well. So we are not doing anything with this correlation right now. I just shown you how we can add it just for your reference. So that's pretty much about it. And now we'll see the final part of this exercise, where we'll also see how we can add create the Docker image for gateway server, and I will also show you what will happen for our Docker compose file. Okay, so before that, just stop all the servers, because now we are going to create our Docker images, so it's better that you just kill all the servers that are running. And before we do that, I just wanted to quickly bring up the accounts and card services once, just to ensure that it is working fine, because whenever we make any changes, it is important that you just quickly test it once. So since I've added this request header now inside my accounts and cards, I just want to ensure that it's working fine even after this change. So why I added this request header is, like, if you have any scenarios in future where you want to consume this correlation ID within your application for some reason, you can do that now as well. So that's why I've added this request header, to show you how it is done. So now my accounts is starting, and also my cards is starting. So both the servers are starting now. We'll just quickly check if still all the requests are going fine. So that's why I just quickly restarted both these servers, and yeah, so it seems that accounts has started, and I hope even the cards has started. Yes, so I'll just quickly go to my Postman. The quick way I can validate is either check for accounts. So I see that I'm getting the data, and also I can check for profile, which will in both the accounts as well as the cards. So I can see that I'm getting data, which means my server is working fine. And always ensure that you just save all your changes that you have done. So now we are good to go. Stop all the servers which is present. So why I'm doing that is, now we are going to make changes to our Docker compose, and we'll just quickly create the Docker image for gateway server as well. So in this demo, we are not going to go through the entire process of creating Docker image for each and every services and bringing it up. I'm sure fairly by now you would have understood how we do it. I'll just overly quickly tell it how we do it. But before that, I'll just quickly show you what are the changes in the Docker compose file which we need to do. So first we have to add a configuration for config server, and also now in the depends on, we have to add the gateway server. So I'll just quickly do that first and show you the changes. So let's quickly get the information. So I've added it now. So let's see what are the things that we changed. So for config, no change. For Eureka server, there's no change. For accounts, there is no change. Right, we already are using the same stuff. We have just added now quickly a gateway configuration for the new gateway that we have created. So we say the image name is backend gateway server latest, same as others. We say let's run it on 8072 port. It's going to run on the same bank network, and it is now, this is what I said, we have to also add the dependency. So we say that this too, in order for gateway server to run, your config server, Eureka server, accounts and card has to be up, because then only it will be able to serve the request. That's why we say this. And also we say the deploy policy, which is similar like others. We just say like restart policy on failure, just after a delay of 30 seconds, try for 3 times within a window of 120 seconds. And we have also defined a few application properties where we say like the profiles active is default. So even if this is not given, it is fine because we just have one property file. We also say what is the config server address, and we also say like what is the Eureka server which it has to connect, and finally the bank network as it is. So these are the only changes. So the only change in this week is we have added this configuration for gateway server. Rest of the things remain as it is. So once you add it, now you know the drill. So in order to create the gateway server image, what we do is we just right click on this, go to run as, go to run configuration. So what I will do is I'll just copy one of the previous commands of config or cards. So we just need to have this command for the goals. So now for the gateway server, what I will do is I will just go to run configuration and I will just create a new Maven build configuration. So how we can do it is just click here, run as, give Maven build. So automatically in the goals, you can just give Spring Boot build image, just give apply. So the next time we can just directly do it and just give run. So since the first time I'm creating it, that's why I'm not getting it option to run directly. But the next time I do it, I will be able to do it from like, here as well. So yeah, now my Docker image creation process has started. So similarly in the background, you can start creating the Docker image for your accounts since you have made a bunch of changes. You can also start creating the Docker image for cards by the same process. Just give run as. In the run configuration, you can directly run the card Spring build, or also you can also run it from here as well since we have run it a lot of times. Similarly for config server and Eureka, you can run it, just give the Maven Spring Boot build image. And for accounts, if you forgot, since we have the Docker file, first we have to do Maven clean install. So from here, first you execute accounts clean install. So since we have already saved a configuration, we can just go to run as, run configuration. Over here you will find this clean install option. So run that first. It will create the latest jar for you. So I will do that as well. So yeah, so now you will see that it is now starting and creating the new jar. Meanwhile, my gateway image is getting created. And also create your images for all the other applications. Once you are done, if you see any tag with the none, just ensure to remove it, right? And once you're done, finally you just click on here and to push each of these into the remote repository. So as I said, I'm not doing it again because we have done enough of time and by now we should be quite conversant with it. And now you can see that my gateway server image is now getting created. So hopefully in a few minutes this will be done. So with that we have reached to the end of this week. So as a take-home assignment, you can just complete the image creation and push it into the hub.docker.com website. So as I told you, just once the image is created, just click on this dots and click on push to image, right? So once it's created, it will be listed over here. You just need to refresh it once. Okay. So for now, it is still creating. So meanwhile, we can go back and just summarize what we have learned so far. So in this week, we have so far learned about what is routing and cross-cutting concerns or challenges that we face while implementing any microservices. Then we see how the Spring Cloud Gateway helps us to alleviate the problems of routing and cross-cutting. Then we also used a Spring Cloud Gateway to implement the custom routing and cross-cutting concerns. We saw how we can do logging and tracing. So I give you an example where we logged in a statement saying that we are creating the correlation ID or we are setting the correlation ID, which gets kind of triggered whenever a new request comes in. And also I showed you how we can enable tracing using both the pre-filters where we set the tracing ID, the request header coming in, and also using the post-filter tracing file, we set this request ID back to the user when the request was going back. And finally, I showed you what a docker compose.yml changes for the gateway server, and we finally also completed the configuration of Docker. So with that, we have reached to the end of this week. Thank you and looking forward to see you in the next week. Hello everyone and welcome to this third session of the fifth week, wherein we will be now continuing our configuration of the Spring Cloud config client setup for account and cards microservices. So just to quickly recall, what we have done so far is we have created a config server. We created this project from scratch using Spring Initializer website. and we then configured the pom.xml and added a few properties for it to read it from our GitHub config repository. After that, we now started configuring our accounts microservice in order to consume this configuration from the remote file and to show it in our application. So for that, the first step that we did was we added this dependency management thing, and also we added this dependency for the Spring Cloud Starter config. So these are the two dependencies which we added in our pom.xml. And after that, we also updated the application.properties so that our accounts microservices is able to connect with the configuration server. So the application name means the name of the project, which will be the same name which the config server will use to match with the file name present in the GitHub. The environment we are given as prod, so it will pick up the account prod properties, and we have given the address of the config server from where it will be fetching this information. So with this being said, now the next step which you have to do is just the way how we created the repository and controllers in our accounts to read the data from the H2 database which we created. So the similar way we have to now configure our application in order to read all the JSON data coming from the config server. So the first thing that we will do is we will now create a service which will be the account config service, which will be reading this configuration for our account microservice. So how to do that is we first create a package under our src main Java. So just come over here, right click, new package. Here we give the name. So always remember that whenever you create any new package, it has to follow the same naming convention, which is in.bank. And since we are doing for accounts .config, because we are going to read from the config server, so it is like for easy understanding, we are giving it as .config. So once you created that, just create a new class inside this config package. The name of this class can be accounts config service. Give finish. And once you create that, just come inside the class which you have just created. And now we have to do the configurations. So what we'll do is we'll first annotate this class with whatever utilities we require for Spring Boot. The first thing is, since we are going to use this to read the configuration, we are going to give this annotation of configuration. So that is, and you also need to import it. So just right click here, just click on the error and import configuration. The second thing we have to do is we have to tell the configuration server what is the properties or what is the name of the file which you have to read. So in our case, it's going to be, the prefix is going to be accounts. So what we'll do is we'll just give configuration properties prefix equals to accounts. Next, since we also need to have getter and setter for automatic mapping of the property values from the methods, we will also use the project Lombok's getter and setter. So if you just recall from the second week, we saw that we don't need to explicitly set getter and setter. So just by using this annotations, you can directly get all the values by using get the value name. So like get message or get build version, something like that. And also we need annotation of toString. So this will convert all the JSON data into string format. So this is also given by Lombok. So just add toString and import by this. So and with that we have completed all the annotation part. And now we need to define what is the data which we are going to read. So if you remember, I'll just take you back to our GitHub. So if you come into our GitHub and open one of the properties, so I'm just opening account.properties. So these are the main variables which are defined, right? So why we are given prefixes, because all this messages have this, all these values have this account's name. So that is why we have given your prefix equals to accounts, which means that all these variables will be prefixed with this name of accounts. So this is given just for standardization, just to ensure that you know which application is using which variable. Okay. So in our case, what are the major values which you receive is message, build version, mail details. Inside that we have hostname, port, from, subject, and also we have active branches 0, 1, 2, which means that it's kind of an array and it has 3 values. One is Delhi, Chennai and Mumbai. The value can change as well. So now we need to kind of define these objects. So what I'll do is first I will define the message. So since it is of the type string, I'm giving it as string. Ensure the name is same as what we give here. So it should not be a different name. The next is build version. So the same thing, build version is also string. So I'll just give string. And just remember that you have to give it as camel casing. Your Lombok is intelligent enough to kind of convert it from the hyphen to camel casing. Next is a map. And why it is a map? Because it is a object. If you just see the properties, it is mail details is nothing but an object having 4 keys. One is hostname, port, from, and subject. So, and all of them have the value of string. So that's why I've given string. And the object name is just copied from here. Mail details. Finally, we have this active branches. Active branches is nothing but your list. So that's why you're given the data type as list and the same name as active branches. So whatever name over here, the same name we have given. And now we just need to import a few things. So first import the map from Java util. Then you import the list. That's it. So once you're done with your service file, which is kind of like, now get all the data from your config API and give it to us. So the next step which we have to do is now we have to define the model for this config prop service. So what we'll do is we'll just come inside the model package which we already have, and similar to how we created for accounts and customer, we will now create a new class for the config prop. So just give the name as config prop and give finish. And inside this config prop also we'll do a few things. So first thing is we'll just do the getter and setter. Just annotate with getter and setter. Import the Lombok. Just click on this error. You'll get an option to import. Just do that. So it will just save you from writing all the statements manually, right? But if you just compare this config props with accounts.java or customers.java, that's a major difference. Here we also annotated with entity annotation, meaning that this we are going to now use it to kind of like use it in order to persist the data in a database. But since for the config prop we are not using a database directly, but rather we are using the config prop service to get the data, that's why we are not annotating here with the entity annotation. So after this we just define the same variables which we defined over here. So just copy this. So save time, I'm just copying this, coming back, pasting it. So this just tells my model class, these are the variables which we are going to use. And after this, now I'm going to define the constructor or the method which will be used to initialize the value or write the values. So here I will say public config prop. So I will pass all the variables, all the arguments over here, which is nothing but the same thing which is given over here. And once I pass it, then I define the methods. So what I will do is, just to save some time, I'll just copy this and I will keep on adding it inside. So what we are essentially doing is we're just defining the type of the arguments which are coming. So since we know that these are the only arguments which we'll pass, so that's the reason I'm directly just copying it and putting it over here directly. So once we have done that, the next part is we have to now map each of the incoming arguments to the variables over there. So this is simple. Just do this dot message equals to message. So just understand what is happening. So basically what we are doing over here is in the models file, we have just defined a constructor or a method which will take some arguments, and whatever value we get for these arguments, we will be mapping it to these variables. So what happens is once the service has read the values, we will be invoking this from our controller, this method from our controller, which will then assign all the values which is read to these variables name, which will then be read by our controller. Okay. So now is the final part where we will just map all these things in our controller. So controller is where all of these will be called and we will be getting the values. So what we will do is first we have to auto-wire this service thing. So what we will do is under this existing repository, we will again call auto-wired, and now we will add our account config service. So that is step number 1. And now we define, just like how we defined an API for accounts, we will now define an API for getting the config props. So it will be a get call. So that's why it is a get mapping. And now you can define the API name for getting. So I will just give it the name of config props. You can give it some other name as well, but just to keep it standard and follow me along, I recommend that you give the same name. So it's easy for you to troubleshoot as well. And now we define the method. So first we'll write the method and then we will kind of understand what is happening over here. So now we have written the code. Let's quickly just import all the things. So account config service, just click on this error, import that, then import the get mapping, import your JSON processing exception, import object writer, import your object mapper, import your config prop. That's it. So we are good to go. So let's quickly understand what we have done over here. So basically we have created a new API which is called as accounts config prop. And what we do over here is using Jackson, which is one of the other library provided in Java. So basically what we are doing is we are now instantiating this config prop method inside our model. So what this config, and to this config prop, we are passing the following methods. So we say get message, get build version, get mail details, and get active branches, which means that first from my account config service, which is nothing but this, right? Whatever service we have created. So first using Lombok, when we say get message, automatically this will be invoked. When we say get build version, this will be invoked. Get mail detail, this is invoked, and get active branch, this will be invoked. So using Lombok, first what I do is I kind of fetch all these details from the accounts from the config server. And once I get all those details from the config server, I now write that data into the config prop model by invoking this new config prop constructor. And once that is done, what I do is using the Jackson, I just kind of write back all those value as string into my JSON string, which I'm returning right now. So what happens is, when somebody calls this API service, they will first, internally my application will first hit the config service URL to first fetch all the configuration from the GitHub link. And once it gets all the data, it will just kind of transform it into a string and return it back as the response. So that is what is happening overall. So now let's try to start a server and see if it works fine. So for that, what I will do, first ensure that your config server is working. So if you see in the console, nothing is running. So just first start your config server. So if it's already running for you, that is fine. If not, just ensure that you start your config server. So just give run as Java application. And now over here, you can now also start the accounts microservice once the config server is up. Always ensure it is started after the config server, because internally your account server is dependent on config server. And so it is better that, you start it after the config server is started, so it starts reading all the data. So now that my config server is started, I will also start my account server. Just go to the main class, run as Java application. So we got an error that, injection point has following annotation. So what I've done is we missed to add this private over here. So now let's quickly just recreate, run the application again to see if that fixes the issue. So just go to my accounts application.java and run it as a Java application. So we made a few typos. First is there was, instead of accounts, there was R here. Instead of T, there was R here. So just we refactored it. So how you can rename is just go to the right click on the package. You will have something called as refactor. So here you can select the rename option. So that is first thing. The second thing is, by mistakenly this config got created in the accounts. So we need to move it one step out. So it should be as part of your Java, as part of your accounts folder. So what we will do is, again, we'll click on this refactor. We will move, or we could just delete it and recreate this. Just quickly delete it. Yeah. So just try to start now. Yes. So now you see the accounts has started. So the issue was there was a slight typo in the package name. So just be careful when you create the package's name. So just to summarize, we first created the config service file, which is nothing but it just maps all the variables which is present in our config API. So if you just come to a config API, you'll see that you have this message, build version, mail details, and active branches. So this is what we are using over here, and along with the types. After that, we created a model, so which will kind of take in that data and update it back to the API which is requesting the data. And finally, we created the controller. So wherein the controller, we created the API for this, which is config props. It's a simple get API. And using the Jackson object writer, first what we do is we, using the account config, we get all the message, build version, all the data. And using the config prop constructor in the model, we just then get all the data and write it back. And finally, once that is given to us, we just convert it back as a string and return it as a response to this API. So now since the server is up, let's go to our Postman and now check if the accounts properties is able to read the data from the config server. So in order to do that, so earlier so far we have read it from the config server. So this time what we will do is we will be reading it from the accounts application itself. So what I will do is in the Postman, I'll just give the address of accounts, that is 8080 accounts. And after that, the name of the API which we created, which is config props. So if I try to just hit this, you now see that this is now hitting and getting the information from our GitHub server, right? So which means that now our application accounts microservice is able to read the config from our GitHub configuration file and return it back. So since we are using the default, so that's why it is coming as default. So now, since we have completed the mapping for accounts, let's also redo the same setup for cards application, which will make your concepts even easier. So let's quickly do it. So the step one was we created the interface file. So since we have already done it once, we'll do it slightly faster, but we'll ensure that we still understand it. So the first thing we have to do is we'll create the config package. So just come to your cards src main java. So inside that, create a package in .bang. So this will be common for all the package which you create. And after that, the name of this package, which is config. So inside this config, now create a new class. The name of the class is going to be cards config service. And for the cards config service, here also we have the same values. So what we will do is I'll just quickly copy paste the data from the accounts, so it's easy for us. So what we need to basically do is we just copy this variables first, paste it over here. So basically these are nothing but the data which your service will be fetching from the database, right? Message, build version, mail details, and active branches. After that, we have to also annotate the class. So using all this annotation, so I'm just copy it and putting it over here. Just ensure that in the prefix for configuration property, you change now this with cards, because these files, these variables are now having the prefix of cards. So that is why we put it prefix as cards. The rest of the things remain the same. Configuration, we are telling we are going to read the property from a config server. Properties, we know that it is prefixed with cards, and getter setter is for the lombok to do the get set stuff, and toString is to ensure that all of this is returned as a string. So that is what we are doing over here. And once this is done, the next part we have to define the model. So this is also same as what we did earlier. So we'll just come to the model package, right click, new class. So here also we'll give the same name, config props, finish. So once we open this, so this also will be same as what we did in the accounts. So I'm just going over to accounts model. The same thing, we can just copy paste it. So since it's the same data, that's why I am kind of copy pasting it, and also ensure that you give the same name as the file. So here we are given config props. So that's why this S is important. Save it. And once you have done that, so finally we have to update the controller. So come to your cards controller. So again, I'll just go back to the accounts controller, copy the same thing, just some few changes, and we are good to go. So first, and also you need to auto wire. So just give auto wired, can give the name as cards config service. You can give it private as well. I mean, that is up to you, but even if you don't give, that's fine. So here the other change we have to do is wherever you see the accounts prop, we have to just rename it with the cards config. So Since we copy pasted it from accounts, that's why we need to do this change. And we also need to import this config props. So just import the config props. This is nothing but the model which we created, and now we are good to go. And also this API, just change it to carts. That's it. So just to summarize, we have just created another REST API with the name cart/config props. So this will now first read the config prop data and return it back as a string. So to check if this is working fine, what we will do is we will now, and yeah, before we forget, we also need to update the pom.xml dependencies, same like what we did for accounts. So just come to your accounts at the bottom. Just before the build, we have added this data. So just copy this, and the same thing you can just paste it in carts as well. Just above the build, you can just paste it. And similarly, you also need to copy the cloud config starter. So these are the two dependencies which we need in order to make our application a config client. So I'll just come back, I'll just come below the starter web, and here I will paste it. So that's it. Just wait for a few minutes just to see if the issue resolves. So we just updated our pom.xml, and so now you see that the pom.xml is ready after downloading. The errors have resolved, and we have also successfully added these two things. So one was the dependency of starters test, and the second was the dependency of management over here. So we added these two, and now it is working fine. So yeah, now we are good to go and start our cards microservice. So what we'll do is we'll just go the usual step to start it. So either you can go here every time and give run as Java application, or you can also go to this play button over here at the top, click on the drop down, and if you can see your cards application, you can start it from here as well. So either of the approach works. And once the card application started, we will go to the Postman and check it. So it says that there is an error with, okay, so we have forgot to add the application properties because that is also important. So quickly, let's just copy the application.properties which we added for accounts, and let's go now to the application.properties of card service and add these three properties, right? So first is the name, we give as card. Second, profile, let's just keep it default for now. And third is the server. So once we have done that, let's now go back and start the application again. So we'll just go here, go to the play button and give cards. Yes, so the cards application is also started. And now if I just come here and instead of, I just create a new app request. So just give localhost :9000. So remember, we are running from Eclipse and it will start at 9000 port. And now I give config props. If I hit send, you see that this is now returning me the default data from the GitHub. So that's how we have seen that now both the accounts as well as the cards are now working fine. So this is how you kind of create your rather I would say configure your cards and accounts microservices to read from the config server, and based on the value you can now use this to perform any of your business logic related information that is required. So with that, I hope you guys are now clear that how can we host our configuration related application outside our microservices code, and also get it from a config server and read it within the application. So it's quite simple if you just think about it in a conceptual matter. So we just kind of have to define just the config class server first, get the data to read from the whatever external resource it is. And on the client, we just need to define the config client first, map the data that we get from config server, and just expose it as a API so that any of our microservices will be able to read it. So with that done, we have completed kind of the setup for our accounts and cards microservices. So it's time that we also kind of do the Docker build and other stuff. But before we do that, I also wanted to show you a few other concepts related to config server. So let's quickly see that in the next session. So we have come to the end of this session and looking forward to see you in the next session. Thank you. Hello everyone and welcome to the second session of week 9. So in this session, we'll be looking on what is Spring Cloud Sleuth tool and how we can implement it in our microservices. So the Spring Cloud Sleuth tool is used for tracing and it provides us a host of features. So it is used basically for the distribution and tracing of a Spring-based microservices application, and a Spring Cloud Sleuth adds the following information to all the microservice logs. So first it adds a trace ID and then it adds a span ID. So what is a trace ID and span ID? So a trace ID is nothing but it is the ID that gets assigned to a single request. So as I said earlier, so when a request starts from a user, hits your gateway server and goes to your Eureka server, goes to all the microservices and comes back. So similarly, what happens is whenever like a request gets originated, it will have a unique trace ID which will be same across all the journey of the request. And what is a span ID is, so say assume I have a request which comes from /profile, right? So when my request hits /profile, it will have the same common trace ID across the journey. But when the from /profile it goes and hits the card, it will generate a new transaction ID which is called as the span ID. So span ID is nothing but the transaction ID, which is nothing but a new ID that gets generated at each step of the transaction. So if my microservices goes through 10 steps or 10 other microservices, then it will have one single trace ID, but it will have 10 different span ID at each step. So this is given just to ensure that let us find out at which point did the error occur. And finally, this also helps us to filter the logs based on the given trace ID or span ID. So this is just a quick revision of what we saw. So what is a trace ID? It is a unique number denoting an entire transaction. And what is a span ID? It is a unique number denoting a part of overall transaction, right? And hence a sleuth log consists of the following parts. One, you have the application name, then you have the trace ID, and then you have the span ID. So now let's get into the implementation part of the Spring Cloud Sleuth and understand how it works. So before we go there, I just want to quickly let you know how this works. You're just clear on this on a conceptual level that how it works. So I'll just give you a conceptual picture of it. So assume that you are this user who is using Postman to hit your API, okay? And now you have hit the / maybe profile API, okay? So what happens? So when this request first comes to my sleuth tool, it will first determine if there's a transaction ID to it. If there's a tracing ID to it, it will find that it's not there. So a unique tracing ID would be created for this entire transaction. So that is called as trace ID. So just let's assume that it will be created as ABC123. I'm just making up a random number. Okay. So this trace ID would be now given to this particular request. And when it hits the profile, it finds that it has to now hit 2 or maybe even 3 microservices. So first is your account, second is the cards, and third is your loans. Okay. So when this now branches into 3 different transactions, the trace ID will still be same for all the 3 requests, but each will have its own span ID. So here the span ID will be, say, maybe I'm just again making it up, DF123. For this, the span ID would be maybe AZYZ871. And for this, it could be like BF7567, something like this. So what happens is, and when it comes back again, the trace IDs are same. So what happens is, for my entire transaction, that is from the point the user hits my server to /profile and it goes to each of the microservices and you receive the response and the response is now sent back to the user, the trace ID is going to remain same or remain the common one for the entire duration of the request processing. But however, what happens is at each point of my request, when there is a new transaction, so say for example, here I add profile and from profile, like at profile, a new trace ID is generated. So trace ID is still the same throughout. But say from profile, if it goes to cards, so at this point, there will be a span ID. And at this point, there will be a span ID which is different, right? So what I mean to say is, whenever there is a break in your request flow or there is a branch in your request flow which goes to some other transaction or other step, a new span ID will be created in order to track that particular branch or that particular transaction. And still, it all will be routed to the same trace ID. So if you have to just draw a tree out of it, it will be something like this. For one request, there'll be only one trace ID, but it can have multiple span ID depending on the number of transaction it takes. So if that's a very simple request like say /accounts, accounts is not dependent on any other microservices or there's no other transactions happening. So in this case, there'll be only one trace ID and only one span ID, right? So this is what is the logic of the trace ID and span ID. I hope this is clear to you. And this is an important concept. So ensure that you understand it clearly. So now the next question might arise how does the sleuth adds this trace and span ID automatically? So what it does is just similar to your gateway. It also does this by adding a filter and interacting with other Spring components so that we get the correlation IDs and we pass this through the request whenever it passes through multiple steps inside our application. So the reason why I said Sleuth is a preferred tool because Sleuth is kind of a very popular tool in industry which is proven to work in a very distributed system. And generally, when we use Spring Gateway, it is more for implementing other cross-cutting concerns. So if for tracing, we have the specialized tool. So that's why we use the Spring Sleuth tool. So now that we are clear with what the Sleuth is all about, let's implement this. So to implement or add the sleuth into our project, so what we need to do is, and since the sleuth is kind of a tracing which will be required across all the applications, so whatever changes I'm doing now will be applicable to all the servers or all the microservices which we have created. So the first change which we have to do is we have to open the pom.xml we'll start with accounts and gradually add for others. So just open pom.xml. And now since we are going to use this, add this sleuth as a dependency. So we will manually add this in the pom.xml. Okay. So what you do is maybe after just before your S2 database, so you can just give one enter and add this dependency that I have added over here. So what you do is you just give org.springframework.cloud and in the artifact ID just mention Spring Cloud started sleuth. So automatically you'll see that it just adds the dependency and we are good to go. So similarly for the cards, you do the same thing. Just come to the bottom, like just before the S2 database, give a press enter, add it, save it. And as you save it, the Maven will start downloading the dependency and adding it to the respective servers. So this will also take some time. So as it is doing it, you can proceed and do it for the rest of the thing. So we'll come for the config, the same thing. So to the config also, I'll just come here. So after this cloud config server, I'll just add it, save it. And for Eureka, the same stuff. So I'll just come to the end of this pom.xml. So I'll just come over here after this dependency of Eureka. I will just add it. And similarly, finally, for the gateway server as well. So after this Eureka client, I can just add this to ensure that it is in a new line. Save it. And we are good to go. That's it. So now we have added and even the building process is almost going to complete. Yes, it is completed. So the pom.xml is added and also the Maven has downloaded these dependencies in our local machine. So that was step number 1. So the step number 2 is now it will start when your server's up, it will now automatically start adding the trace IDs into your applications by default. Okay, so that will happen automatically. The next step that we want to do now is we want to now find out what is the whether this is working or not. And in order to find out whether it is working or not, we have to explicitly add some logging statements because only when something is logged will this trace ID will be coming. So what we will do is we will just add a few logging statements in our accounts and cards controllers. So what I will do is I'll just open my the accounts controller. So let's open the accounts controller. And over here, let me just kind of define a logger statement. So in this main class, first we will define the logger statement. So what we'll do is the same thing that we did in the previous week. Public static final logger, L should be capital logger. Then use the same class name, which is accounts controller dot class. And after that, just import the logger and stuff. So ensure that you're importing logger from SL4J. So that is one of the library which is used for logging. And similarly, even your logger factory should be imported from SL4J. That's it. So this is step number 1, where we have just defined a logger object. After this, So what we'll do is we just take one of this API just for demo purpose. So I'll just take our profile itself. So what I'll do is after all the statements which we added previously for the circuit breakers. So after all the statements which we added previously for the the circuit, the resiliency. So I'll just kind of, yeah. So after this declaration of the public customer details, I will just put a logger statement over here. So what I'm going to just log is I'm just going to say, or maybe I can even put something like a debug statement. So wherein I will say this, or maybe I would say the name of this method, right? So customer get customer details is starting to execute. Okay. And when it is completed, so just before the return statement. So why we can't do after return is because after this nothing will be executed in this method, right? So I would say has finished execution. So basically what we are doing is just to check if the trace ID is working fine, because trace ID automatically gets attached to all the logging statements that is generated. All I'm doing is I'm just adding two sample statements. So the first statement is I'm saying logger.debug. This is starting and this is finished. So just to check if my trace ID is working fine, right? So similarly, what we can do is, since I'm calling it on the profile, I will also just add it in my cards as well. So what I'll do is I'll just copy this statement so I don't have to type the entire thing again. So I'll just copy this once. I will go to my cards. I will go to my controller, and inside my cards controller, the same thing I'll do. So first I will just declare this method, and inside this I have to add my cards controller dot class. So this is the convention how we kind of initialize the logger. And after that, once that is done, so I just need to add a few logging statements. So same thing I'll do over here as well. So under inside the cards, I would say logger dot debug. Probably I would say the name of the method, get card details has started to execute. And here I would say has finished execution. Okay. So that's it. This all we need to add. So this is all we require to do. So we can now check if this is working fine. So don't worry, since we have added the logger separately, which will give us the trace, so we can find whether this sleuth is really working or not. Okay. So now that everything is done, we just ensure that all the files are saved. And now the same drill of starting the server. So first you start your config server. So just go over here and go here. So if you have it in the drop down, fine. If you don't have it, just click, because if you restart your Eclipse, it will be gone. So if you don't see it in the drop down over here, you can just go right click here, run as Java application. And once your config is up, the same thing you have to do for your Eureka server as well. So just waiting for the config to be up. So the reason why we are not doing everything in parallel is because these servers internally depend on each other, right? So config is not depending on anything, so it can start fine. But Eureka again depends on config to get this config, and again your applications will depend on Eureka and config servers. So unnecessary it will throw errors. So it's better that we just start them one after the other, so we don't see unnecessary issues in the console. So next is the Eureka server. I've also started that now. The next we can start either the gateway server or the account server, it's up to you. So let me just go and start the account server, but that takes some time to kind of start. Okay, my Eureka server is up. So now I can start my account server. So once my account server is up, I will then up my cards as well. So the accounts is starting right now. Okay, so your accounts is up. Now you can start your cards application. Okay, the cards is up, and finally we can now start our gateway server. So the gateway server is starting now. Okay, so the gateway is also up. It's time to test if it's all working fine. So before we do that testing, I highly recommend that you just clear the console in all the servers so that it's easy for us to know when the log is arriving. So to do that, the fourth button from here, right, in the console, the one which has a small X at the bottom saying clear console, just click on this and also ensure that for other rest of the servers, you are kind of clearing it up. So we can cycle between all the servers through this, like, the icon over here. So it shows you all the servers and you can now just cycle through all the servers and ensure that, the consoles are cleared. So even after clear that, there may be a few, like, things running, especially in your Eureka server where it will try to, like, just log something. So that is fine. So you can just clear it if it comes. So we'll just keep the accounts application open, like the account server console open. And now what I will do is I'll just come to my Postman, right? So I have two options now. Either I can directly hit my accounts application. So I can just kind of hit it directly from here. Oh, sorry, not my accounts, because we have implemented it in the logging in our profile. So I can just directly come here and hit my profile directly on the accounts, or else I could also kind of, like, hit it through the gateway. Okay. So let's check what happens if I hit it directly from the server. So when I give send, you see that now the tracing is working absolutely perfectly. So you see, as we discussed, there are three parts to a sleuth log. So first is the application name, which is accounts. Second is the trace ID, and third is the span ID. This is the first request, or the first part leg of the the request. That's why you see the same trace ID and the span ID is associated. And since this is not branching to any other part, all the logs that got generated has the same trace ID and span ID, right? So that was one thing. The second thing, now let's try to hit it via the gateway. Okay, so I'll just clear this log once and just check all my other logs as well. If no other logs, I'll just clear all of these. And now I'm back to my accounts. Or first I will just have it in my gate. I'll just open my gateway server. We'll just hit the same request from my gateway, right? So what I'll do is I'll just open the gateway. So remember that the gateway URL was 8072, and from my accounts I'm going to hit my profile. So when I hit it now, yeah, so request is there, and in gateway, if you see that even now it's properly generating the trace ID and span ID. So since the request is hitting this first, that's why you see the trace ID and span ID is same. And from my gateway, it would have now flown to your accounts, and from the accounts it would have now flown to your cards as well, right? So that's why you see all this now beautifully getting generated. Sorry, repeat. So that is the beauty of having your sleuth configured, wherein you can now have this beautiful trace ID and span ID generated, and also you have the application name. So if you just understand about this, you can now possibly have a situation where you can actually filter through your servers just by passing these queries, right? So now comes the next interesting part. So how do we ensure that, how do we make the lives of developer easier, who don't have to, like, cycle through so many servers just to find, like, which particular request, or, like, which particular server the trace ID has gone through. So that is an issue, because even here we have now, like, we have just like 5 or 6 servers running. But imagine if you are in an organization and, you have to go through each of these servers now just to find, like, what was the trace ID and span ID that got generated. So in order to solve your problem, that's where the Zipkin came into picture. So Zipkin is going to be a tool to which the sleuth is going to connect and tell that, hey, that this is all the logs which is generating. So please take a dump of it and you create your own dashboard. So how this all works, we'll be seeing it in the next session. But for now, just ensure that you understand what is happening. And even you see whatever the auto logs the Eureka server is generating, it will have this trace ID. But you will see that here there is no trace ID and span ID generated, because it is just kind of an information log. There is no external request that is coming. This is just the periodic internal logs that is generated. That's why you see both of this is blank. So that's it. I'll just kind of, like, just clear all the logs that got generated. So I hope you understood the concepts of how the tracing works, and that's it. So just to kind of revise what we have done, the first thing to add a sleuth to any of the application is you go to the pom.xml if it's existing one, or else if it's a new one, you can directly add this from the start.spring.io dependency as well. But since we have already have existing application, ensure that you add this dependency into the pom.xml. That will automatically add the required dependencies. And once you add that in your application based on the business logic that you may have. So say for in our example, so in the accounts dot controller, right? So what happens is, like, we are telling whenever the, the profile is executing, we are just kind of logging this log. So just to let ourselves know that, this is starting and this is finishing. In the real life, you won't be doing any such logging because it is not recommended that you just put unwanted logs. So in production or in the live application, generally how this logging will happen is you will have an exception scenario. So normally you'll do a try catch, and in the exception scenario, you will probably log a warning or error where you say, like, this is the error, and when you do that, automatically the trace, the span ID and the application name will be added to this. So that's how normally we work in the production. So just for the demo purpose, I've added a dummy statement here telling that, it is starting to execute and it has completed execution. And that's it. So once we do that and we are able to now hit any server, so if even if I now just hit the cards API, right, and if I just go and see my cards, so the log, the it will generate the logs because, since this request is going through my cards application, and the logs gets generated. So that's how, the sleuth and everything works. So I hope you got the idea of how it works, and how the tracing and all the stuff work. So in the next session, we will understand how the Zipkin login happens. Thank you and see you in the next session. Hello everyone and welcome to this third session of the ninth week. And in this session, we'll be talking about Zipkin. So what is Zipkin? So Zipkin is basically used for aggregating the logs from multiple sources into a central repository. A Zipkin system basically consists of the following key parts. There is a Zipkin collector, there's a Zipkin query service, there is a storage, and there is a web UI. So the Zipkin collector, what it does is it performs the following functions on trace data. It will validate it, store it, and index it. The Zipkin query service is used, which is nothing but an API that is used to retrieve the traces stored by Zipkin. It also has a storage which just stores the logs in memory by using MySQL, Cassandra, and Elasticsearch. And these databases really help you to get the results quite fast. And you have a web UI where we can view the traces based on the apply filters from a web application. So that was a quick summary about Zipkin, and let's now dive little deep into it and understand. Before we proceed any further, I hope you remember from the previous session, so how we can, if we hit any of the profile, like any of the API, and make a call, you see that, it generates this nice trace ID and span ID, and even in your gateway server, it will be there. In your accounts, it will be present, so on and so forth. And why it came is because we had added this debug statement inside our controllers, right? So in both our controllers, that is accounts and cards, we had added this debug statement, and that's why it was showing in the logs. And in case for you, if the log is not showing for any reason, one quick simple solution for that is, since we are using debug statement and it is not info statement or error statement, what you can do is go to application properties of your accounts and cards, and below this you can add this one single line. So for accounts, it will be logging.level.in.bank.accounts colon debug. So it means that it will enable logging the debug statements. And if it's for the cards, you have to write the same one. Only difference is that instead of accounts, you will have cards over here. So just add these two lines at for your application properties of cards and accounts, and even for other services if you're interested to check, and just save it and restart your application. It will then start logging all the debug related logs. Okay. Or the other simple change which you can do is, if you don't want to perform that, the other change you can do is, instead of .debug, you can just change it to .info, or you can just change it to .info. Even that works. Okay. So that was just one quick point which I wanted to tell from the previous session. So now we know that we are getting all this nice logs which is getting generated for each of the transactions that is happening, right? So as I said, now a major challenge for you is how do we kind of aggregate all this log in a central place so that it's easy for us to know how the request is traveling and where the error occurred, right? So even here we have like 6 servers through which we have to cycle and find where in each and every log is. And so if you take a scenario where you have like thousands and hundreds of instances, so it's really a nightmare where you have to log into each of the server to find where is the error, right? So in order to solve that, we have this Zipkin. So what Zipkin basically does is it will kind of first aggregate all the logs that comes in, it will index it, then it will like store it. And whenever there's any query to filter through any request, it will just query it and return it back on a UI, right? On a web page which shows the result. So before we go further, it's important that you also understand how Zipkin works. So what is the architecture of a Zipkin like? So a Zipkin basically has a few components, right? So first component is your collector component. The second component is your storage component. The third component is your Zipkin query service, which is nothing but an API. And the last is nothing but your web UI, which is nothing but your dashboard. So basically what happens is all your microservices which are running. So it could be accounts, cards, loans, insurance, whatever. So all these would be kind of constantly sending the logs to your Zipkin. Okay. So the first point where all this meets sits your collector module of your Zipkin. So basically what a collector does it will just take all the incoming log that comes in, trace data that comes in, and it will first validate it whether it's a valid log. Second, it will then store it and also index it. Why indexing is important is so for the future searches that will make it easier so you can quickly search where a particular log is located. So that is with the work which is done by the collector. The next step it goes to storage where it will store all this data as in memory using MySQL, Cassandra, and Elasticsearch so that it is easy for you to store these logs and the whatever the log and the tracing information that comes from the collector. So once it is stored, you have this API called as Zipkin query service. So what it basically does is it will query the storage based on certain parameters. So if you say search all the trace ID, search all the logs which is having this particular trace ID, or you say search all the logs which is come in the last 15 minutes, right? Something like this. So based on these queries, it will go and search this storage and find all the logs which are matching this. And finally, all this data will come and hit your web UI, which is nothing but a dashboard. So this web UI is nothing but a pre-built UI application, which will show you in a dashboard format of all the data that comes in. Okay. So if you see, the beauty of the system is it automatically aggregates and also lets you query the log and shows you in a web UI format in a web UI. So that is kind of it takes off all the heavy lifting from you, and you as a developer really don't have to do anything. Just add a few configurations so that your application knows to which server it has to send the log, and we are good to go. So I hope now this is clear how the Zipkin architecture works or looks like. And before we proceed further, I just also want to let you know that if in case your application has say held like lot of data that is coming in. So maybe you have like 1 lakh application which is running. So obviously 1 lakh microservices running. So obviously the per second logs that comes into your Zipkin is going to be quite big, right? So in even those kind of scenarios, you don't really need to overload your Zipkin server and let it read all the 1 lakh login messages. So what we can do rather is the 1 lakh tracing messages rather. So what we can rather do is whatever log comes in, you can just probably dump it in a JMS, which is a Java messaging queue. So if you people are not aware of it, a Java messaging queue is nothing but a asynchronous pipe wherein you are free to put any message as it comes, but you can only read it when you want. Okay, so just think it's like a post box. So the postman is free to put the letters whenever he or she wants, but you can take it out only when you want, right? It's not like when they put it you have to take it immediately. It's something like that. So what you can do is instead of your Zipkin just constantly reading and taking all these messages and overloading itself, you can also kind of put it in a JMS where it can kind of first the message or the log can sit for some time, and periodically your Zipkin can just listen to this JMS queue and read it when required. So the advantage is you're not going to kind of put a bottleneck on your Zipkin where there are a hell lot of data that is coming in a short span of time. And also the other advantage which you have in the JMS is, so in case your Zipkin instances goes down, right? So the data is still not lost because it is sitting in the JMS queue, and the next time the Zipkin instance is up, it can still go back and read all the unprocessed message. So that is the beauty of even doing it in a asynchronous fashion. So this is just for your general knowledge. What we are going to do in this demo is a straightforward one, which is a synchronous one, meaning as your server keeps on sending you the trace log data, your Zipkin is going to process it and show it on the UI. Simple as that, right? Because in our case, we just have 2 microservices. So similar to what we did for Sleuth, the same concept even applies for Zipkin. So first we have to add the dependency for Zipkin. So what we will do is, we will just go to this pom.xml of, we have to add this to the pom.xml of all the servers. So first we'll go to accounts. And before we do that, it's suggested that you just kill all the servers because we are going to now add a new dependencies, and also we are going to make some configuration changes. So it's better that you first kill all the servers. The next step, you just come to the pom.xml of your accounts. So after you open your pom.xml of accounts, just come below, and after you have added the sleuth, you can now add your sleuth Zipkin. Okay. So this is the dependency which we add. So internally what sleuth does is, if you give the configuration, it will automatically start dumping the logs into Zipkin as well. So that is the step number 1. So similarly, just like we did for accounts, you have to do for the rest of the servers, for the rest of the microservices. So we then go to the pom.xml, the same stuff after sleuth. So after the sleuth, give enter, go to a new line, paste it, just type this stuff, which is dependency group ID, this stuff, which is cloud sleuth Zipkin, and save it. So automatically your Maven will start downloading and installing. Similarly, go to config a server, pom.xml. At the end, just add this data, save it. Similarly, for your Eureka server, just do the same thing. And finally, for your gateway server, also do the same thing. So after you sleuth, new line, save it. So once the Maven build is completed, so we are good to go and just do the application property changes which is required. So we just wait for a few seconds to ensure the Maven build is completed. So we see that Maven is completed. There are no new prompts. So the next thing that we have to do is, we have to open the application.properties of each of the server and just specify what is the base URL of a Zipkin and what is the percentage that we want to log, right? So how will you know the the port of Zipkin? Okay, so for that we have to now also install Zipkin server, because as I said, it is a server which is going to take in your logs and show it in a UI. So it is just like your gateway server or Eureka server or config server. It is also a server which needs to be installed. But one advantage or one benefit we have for Zipkin is, it already has a pre-built Docker image, so you don't have to do any of this configuration. All of that is done pre-built for you. So all you need to do is just kind of run the pre-built Docker image, and we are good to go to start the Docker server of the Zipkin. So what we need to do for that is, just come to open a new browser window and just type zipkin.io. Okay. So once you open this, you will see this is what a dashboard of Zipkin looks like. So we don't have to code or write any of these code. It is all given by Zipkin by default. So if you just come down here, there is something called as a quick start guide. And when you click on that, you will see there are various sections how you can start Zipkin in various ways. So since we are already using Docker, the simple way to start a Zipkin server locally is, you just give this command. So what it does is, so every time we run a image from our local machine, so this time rather what we are doing is, we are directly taking this Docker image of Zipkin from hub.docker.io, and we will start it in the 9411 port. Okay, so this is the default port which they recommend using. So what we will do is, and what is this hyphen D does is, hyphen D says detached mode, which means you won't see any logs when the Docker is starting. So that is why we use this hyphen D mode. Okay. So what I will do is, first I'll complete my configuration and then I will start the Zipkin server. So I now know that my port is 9411. So what I will do is, first I'll go into my application properties of accounts. I'll come to the bottom and I will just add these two property files. So first I say to the Spring that my Zipkin base URL is localhost 9411. Why I've given localhost? Because once I start the Docker server, it will be running my local, right? And the port is 9411 because that is the port with which we are exposing this to the outer world. And the next thing that I tell to Spring is the Spring Sleuth sampler percentage. I've just given it to 1, which means just log all the logs that is coming in. But in case you just want a sample or a fraction of the logs to be coming into Zipkin, what you can do is you can also give it, this is a percentage, okay? So 0 means 0, 1 means 100%. So if you want to just log 10% of all the logs, just give it as 0.1. If you want to log 50%, just give 0.5. If you want to log maybe 70%, just give 0.7. So these are the ways you can fine tune the percentage. For the purpose of demo, I'll just keep it as 1. So we know that all the logs which are coming in. So once this is done, I'll just copy both of these lines, save this file first, and then just add it to all the servers which are running. So I'll just go to cards next. I will add it at the bottom. Same for config server. I'll go to my application properties, add it at bottom. Next, I will go to my Eureka server, SRC main resources, application properties, add it at bottom. So now I have added all the requisite changes which is required, and finally also for my gateway server as well. So just go to the application properties, add it at the bottom. We are good to go. So now we have added all the changes that is required. So the next step which you have to do before bringing up all the server is, we first have to start a Zipkin server, right? And the way to start it is, so here we don't really have to go to Spring Boot, add it as a dependency, do the configuration. We can just simply run the server from this Docker image from the official Zipkin build. So it will directly start the server for us. So what I will do is, I'll just copy this command from here, which is docker run -d -p 9411 9411 open zipkin /zipkin. So just copy this, come to your command prompt. So ensure that you're just in the same folder where your all other microservices are. And so this is just to ensure that you are in the same folder. So also when you are running the future Docker commands, it's easy for you. So just paste this command over here, docker run -d -p 9411 9411 open zipkin /zipkin. So just run it. So first it will tell unable to find the image locally because this is in remote. So it will now go and fetch it from hub.docker.io. And now you see that it has started to pull and the download is complete and it is doing all that stuff. So once everything is done, your server will start running. Yeah. So since we are given this -d, you won't really see much of logs over here. So that's why it has just completed and it is showing like this, which means that now our server should be running in the background. And to verify if it is running, what we can do is just open a new tab, give localhost colon 9411, enter. You now see that you get this nice little Zipkin dashboard. So by default, there is no when you run query, there is nothing over here. So for this, in order for this to have some data, we'll first start our all the servers. Okay, so then I will show you what is the power of Zipkin dashboard. So the first step, I'll just go and just start all my dashboard, like all my servers. So first I will go and start my config server. So the same drill applies, right? What we do every time. Once the config server is up, go and start your Eureka server. So we see the config server started. Next, go and start your Eureka server. And once the Eureka server is up, you can now start the rest of the servers, that is account, cards, and gateway. So the Eureka is up. So I can now start my accounts application. So after this, I can now start my cards application. And in parallel, I will also start gateway to save some time. So once my card has started to execute a bit, I will also start my gateway now. So the card is starting up. So I'll also start my gateway. I'll just wait for all of this to complete. So now we have just started all the servers. So we are just waiting for all the servers to be up totally. Okay, so one quick way to verify if all my servers are up, I still see cards and applications starting. So what I can do is I could just go to my Eureka server and just refresh it. So I see that only accounts is up now. So you just wait for some time till the cards and gateways up as well. So now I see that everything is up on refreshing. So I think we are good to go. So now what I will do is I will show you the beauty of how this Zipkin helps us to kind of trace the data or find the log data. So if I just run query, since we started the server now, we saw a few trace statements which have been generated, and we see what are the logs that were generated. But what I will show you now is let's now get into the let's now make a proper API call. That is, we will first trigger the profile API from the gateway server, and we'll see how this logging happens. Like what is the beauty of Zipkin, right? And then I will also show you a few features. So now what I'm going to do is I'm just going to call this profile API as usual from the gateway server URL. And when I hit it, I'll just wait till the request is completed. Yes, the response is there. So now what I will do is I will just kind of click on this. This plus is nothing but it's a query parameter. You can filter your logs. So here what I will do is I will say the service name is okay. So before that, just to refresh your Zipkin once. So I will just click on service name, automatically will give me all the names. So I'll just filter for accounts. Okay. And here you can also give what the span name or remote service name and all that stuff. So we are not going to that much detail. So I'll just filter with the service name. So now you see that a minute ago we got a call from the gateway server with having this trace ID, and first it went to gateway server, then to accounts, then to cards and back, right? Now if I click on show, this now shows me beautifully how this request came through. So first it hit the gateway server, then it went and hit the accounts profile, and from the accounts profile it went and hit the cards, and each it also show you the time each service took. So in case you have a issue where you want to find out which microservice is taking time to execute, this also helps you. It will directly pinpoint you. So in our case we can say that the gateway server took an overall of 3.48, out of which your accounts took like 3 seconds and your cards took like 1.33 seconds. So maybe we might have to fine tune this 3 seconds call in the accounts in the future, like something like that. So that's how the log analysis happened. So this, it shows you how this request went through, and in case if there was any error, if after cards there was some other call which has to be made but didn't go through. So you can easily find out where this thing stopped, right? And you also can check here what are the server start time, what is the server finish time of execution and all that thing. So this is one thing of Zipkin that is really beautiful. The second thing is you also can filter based on the last few minutes. If I just do for the last few minutes, so these are the various logs that happened, right? And also the other thing which I wanted to show you is, so if you just make a query, right, of all the calls that happened, so just verify this, just see this. So we made a call, from the gateway, like that first went and hit your accounts, and from the accounts it went, and you can actually see this nice little animation, right, where it shows how your request started from the gateway server, and it first hit your accounts, and from the accounts the request came to your card API. So this visually kind of tells us how this request is flowing between the various services. So that is also another beauty of your Zipkin, where it tells how the request starts, where it hits, and from where it goes next, and all that stuff. So this is some of the few things which you can do with Zipkin, and also other beauty is it also is available in some other languages like Spanish, French, and Chinese. So if you are a native of one of these countries, you can also have Zipkin in your native language as well. So that is the kind of the advantage which Zipkin gives you. So you really don't have to code a lot. Even for Spring Gateway, we had to write like a few things, right, to in order to create the correlation ID and tag it and all. But here you don't really do anything. Just your sleuth will take care of adding the tracy ID, and once you give the configuration, it will automatically dump all the logs here where you can beautifully search it or analyze it. So with that said, we have now completed the section on Zipkit. So in the next section, what we will do is we will look into how we can update the Docker Compose configuration for our all the microservices, since now we also have this dependency of Zipkin in. So let's see how we can do it so that in future when we want to start all our Docker images together, how even Zipkin can be started. Thank you and looking forward to see you in the next session. Bye. Hello all and welcome to this fourth session of the ninth week, where we will be talking about how we can update our Docker configuration so that we also add the Zipkin microservice image along with our rest of configuration. So as you know, so far what we have done is anytime we add a new server or new configuration, we also ensure that we update our Docker configuration. And predominantly in the Docker configuration, we talk about the Docker Compose, because it is through Docker Compose we can bring up all our server together and perform those kind of operations. So in order for us to do that, first I would recommend that you can now just stop all your running services. So this is to ensure that there is no conflict or you unnecessarily the RAMs is not getting used when you're creating the Docker image and all that stuff. So the first step that we have to do is when you open your Docker Compose. So why we do it in Docker Compose is because this is the utility that helps us to kind of bring up all the images together, right? So here we have already defined the Docker Compose for config server, for accounts, cards, gateway server, right? So similarly, we also need to now add a configuration for Zipkin. Fortunately, there is no other depends like update the depends on for rest of the microservices, because this is an independent stuff which the Spring will take care internally. So what we need to do is I'll just update the configuration first and we can look at it together. Okay, so I have added this configuration. So this is the only part which we need to add at the top. So first you'll say the name of the image, which is Zipkin, and the image name would be open/zipkin, which means that we are going to download it from this particular repository in the hub.docker.io. And optionally, we can also say what is the memory limit. As I said yesterday, once you start 5-6 images together, it will have an impact on your local RAM, if especially when the RAM is not decent enough. The size of the capacity of the RAM is not decent enough. So it's better that you also mention some memory limit for each of the containers so that your entire system does not freezes. After that, we mentioned what port it has to run. So the default port is always 9411 and we also specify what is the network it has to run. So we say it is the bank network because that is what is the network that we are using so far, right? So that's it. This is what you need to do. There is no other we don't have to really create an image for Zipkin and all because it is already present and given by the Zipkin team. So optionally what you can do is you can now kind of create the update the Docker image for each of these and push it into the Docker hub. So I'll just quickly show you how to do it for accounts. This you already know. We have been doing it for almost last 5-6 weeks. So I think by now you should be aware of this. But even if not, let's quickly revise. So remember that for accounts alone, we are using the Docker file in order to create the Docker image. But for the rest of the servers, we are using the build pack, the Paketo build pack, which helps us to create the Docker image automatically. So since you're using Docker file, here the steps to create the image is different. We first go to accounts, go to run as, then we go to run configuration. And here we will be running the command of maven clean install. So that's why I just chooses accounts, and or else you can just go to goals and specify maven clean install. Run it and you'll see now it will start creating the jar for accounts. So we'll just wait for a few minutes till this is completed. Usually it will be completing under a minute depending on the speed of your computer. So it's currently performing testing and it will be completed now. Yeah. So now it will start building the jar files. And yeah, you see that it is success. So few of you might have observed that there is a error here which says transport exception. Why this is happening is because internally accounts is depending on your Eureka server and config server, but since both of these are down, that is why you kind of see this error. But that's not an issue, it's only for testing. But still, like, you'll be able to generate the jar, and now it shows as build success. So the next thing that you have to do is just go to your command prompt and get inside your accounts, and we have to just execute our command, which is docker build space dot, which means in the current directory. Then you give the tag. So in my case rather, it is bankin123. In your case, it will be your docker user ID followed by the image name, which is accounts. Press enter, and now you see that it starts creating the image. So this is the way how we create a docker image whenever we are using the docker file approach. So as this is executing, so we see that it is now completed. So the next thing we have to do is we have to now create the docker images of all the other applications which we have. So I'll just quickly show it for once, and the rest you can do it in your local. So just right click, go to run as, go to run configuration, and you just select the one which you have saved, which is having, and you just select the one which you saved having cart spring build, right? Basically you have to just execute this command, which is spring boot build image. Now you give run, and this will now start creating the docker image for carts. Similarly, once you're done with that, you can just follow the same for config server, Eureka server, and gateway server. So basically what we are doing is we are creating the docker image. So instead of going to command prompt and giving maven spring boot build image, we are just directly doing it from the Eclipse, right? So once all of this is done, you know the drill. So in your Docker desktop, you will see, like, we already see that the new accounts is present, and also the old account with none tag is present. So your first work is to ensure all the old tags with having none is removed. So this is first to save the space in your local machine. So wherever you see this none stuff, just remove it. And once the cards and other images are generated, all you need to do is just click on this and just push to hub. Or if you want to do it from the command prompt, just go and give docker push and the image name. So in my case, it is bankin123/accounts. In your case, it will be your user ID /accounts, then /cards/config server, Eureka server, gateway server. You don't need, and that's it, right? So this open zipkin docker is still in use. So what I'll do is I'll just also kill it once I've done, since we are done with our demo and we have seen that everything is working fine. So we no longer require to kind of have this running. So I can just kill this, first stop it or directly kill it. Anything is fine. So now that my docker is exited, I can delete it. And once it is deleted, I'll just ensure that, that my zipkin is no longer in use. So you'll see a few other loaders which is used, because since the cards docker image is getting created, that's why you'll see a few images are in use. Okay, so once this is completed, it will get over. So with that, I think we have completed the entire setup. So you just need to wait, just create all the images, and as I showed over here, just push it to your docker hub repository so that in future you can just run all of them together. And if you want to test if all these docker images are really working in your local, once you have created your and once you want to test if all of your configuration is working fine, what you can do is just go to your accounts, and once all your docker images are created successfully, so just give this command of docker compose up. So this will just start all the 6 servers plus 1 of zipkin, so all the 7 servers together, and then you'll be able to do the test as usual from your postman, where you can just execute each of these URLs to test whether you're getting the data and if all the functionalities are working fine. So this is just to test all your docker images together. So I would only recommend you perform this if you have a RAM capacity of at least 16 GB or at least 12 GB or more. In a local system, in a normal system which is having like 6 to 8 GB of RAM, this might really slow down the system. So yeah, in case if it is slowing down your system, I recommend that you just upgrade the RAM capacity of your laptop or computer. So with that said, let's now go to the summary and just check quickly what we have learned so far. So in this week, we have predominantly learned about what is the distributed logging and tracing. We understood what is the use of Spring Cloud Sleuth for tracing. And finally, we saw what is Zipkin and how it is used for aggregation of the logging and showing it in the dashboard. So with that, we have come to end of this week. Thank you for your time and looking forward to see you in the next session. Thank you. Hello everyone and welcome to this week 10th of microservices using Java, Spring and Docker. This will be the last week of this course and I'm excited that you guys would have learned a lot about microservices, Java, Spring and Docker with me in all these previous 9 weeks that we had so far. So in this week we are going to now focus on the introduction to Spring MVC using Spring Boot. So let's quickly recap what we have learned in the previous week. So we saw what is distributed logging and tracing aggregation. So we saw what are the challenges that we might face whenever we want to kind of find the requisite log or find where the particular transaction or request failed and how tracing can help us. Then we saw like how we can use Spring Cloud Sleuth tool for tracing and we also implemented it in our application. And finally, we saw once we have the tracing of the logs implemented, how we can aggregate all these logs in a central server for our quick filtering and visualization for which we used the Zipkin. So this was pretty much what we learned in the last week. So in the current week or this last week, these are going to be the main topics which we will discuss. So first we'll understand what is the Spring MVC model or the Spring MVC framework. Then we'll understand the architecture behind the Spring MVC. And finally, we will be seeing how we can configure Spring MVC and we'll be doing a quick demo of how we can create an app using Spring MVC. So the learning objectives of this week is in this week we will learn an overview of Spring MVC. We will learn about what is this architecture of Spring MVC. Then we'll see how we can use the Spring Boot for Spring MVC configuration. And finally, we'll be creating a Spring Boot MVC application. So what we will basically do is, if you remember, we have created this banking microservices. So what we will do is we will take the customer's database and we'll try to create an application which will now visually show us all the customer records that is present in the customer database. So let's start with the introduction of Spring MVC. But however, I feel before we jump into this introduction of Spring MVC, it is important that we quickly recap what we have learned in the previous 9 weeks. And also I want to give you an overview of how generally the development of any application works. So let's get into that. So for that, I'll be now opening the whiteboard. So let's quickly recap on how any application gets created or what are the parts whenever you create an application. So let's take a simple example, right? So maybe I can take the example of say skilllink.in. So this is just a temporary website which I've created, or maybe for that matter, you can also take the example of our bank website which we are creating, which is bank.in. Just a a made up arbitrary name. So whenever you say that I want to create an application, and this when I say application, it could be either your web application, meaning your websites that you create, or it could be your mobile applications, right? The any applications that you download from your Play Store or your Apple Store, right? So the process is fairly same. Only things in case of a mobile application for the front end or for the application that you actually download, you have to write the particular application in the language which is supported by the OS. For example, if for Android, you write in Kotlin, and for the iOS world, you write in Swift. And for website, you again have to follow a few other languages. But also nowadays, we can kind of write our websites and convert it into mobile apps. So there are a few technologies around it. But what I want to really tell you is how this process of application creation happens and why this is important is in this week we are going to study about Spring MVC, which is going to be the front end part of the application. So it is also important for you to know why we are studying about it, right? So let's see what happens or what are the moving parts or what are the parts of the application that you will generally develop whenever you have an idea or you're going to create a new application. So the first thing that happens is you will create something called as the front end, or which is also called as a UI, user interface. Okay, so this is nothing but the website that you actually see whenever you open any application or website. So say for example, when you open google.com, when you open flipkart.com, when you open amazon.in, so all these are nothing but the front end part of the application that you actually see. So in theory or like in technical jargon, this is also called as view, or even sometimes it is called as view, right? View or UI, anything is fine. Okay, so this is nothing but the actual application which your end user will be interacting with your application, right? So this is where the end user will actually be interacting with your application. So the front end is nothing but, it's just going to be a static or a dummy piece of code, which is just going to take the data from backend, just do cosmetic changes on top of it, and it is going to be displayed on the front end. And the predominant technologies which we use for writing the front end applications are HTML, CSS, JavaScript. Okay, so these are the building blocks of any web applications or websites that you develop. And again, within JavaScript world, you have a lot of frameworks. So like if in case like, you want to develop your application, like, using some frameworks. So frameworks are nothing but, you can just consider them like Spring. So like how you have Java language and on top of it, there is a Spring framework. So Spring framework basically gives us an additional tool or additional methodologies or means by which we can reduce our development effort. So you would have seen how like, just by adding a few dependencies or and just by doing some configurations, we were really able to get our application up and running, create the APIs and do all this stuff. So that is the beauty of any framework. So it gives us a lot of abstractions and ready-made utilities on top of the base language, which helps us to speed up our development experience. Okay. So JavaScript again has a lot of libraries and frameworks. So say for example, a popular library which is used is called as jQuery. In the framework world, you have something called as Angular. Then you have something called as React. And also if you want to develop like, away from JavaScript or you want to use server side, you have something like PHP. So these are a few tools which are used to kind of create or add the dynamic behavior to your front end. So what I mean by dynamic behavior is, so whenever you click a button, you see kind of a pop-up or like, when you type a form, you submit it, the data goes to the backend. So all those kind of dynamic behavior is added by JavaScript, and you can use some of these tools to add that. Okay, so this is the front end part of the application. And your front end alone is not enough to complete your application, right? Because you will have data, you have to check something, you will have business logic. So when I mean by business logic, so say for example, if I come to your bank and I want to open an account, so definitely you'll be looking, am I eligible to open an account? Do I have a valid Aadhaar card? Do I have like, do I have the necessary supporting documents? Is my KYC complete? So all those kind of a few preliminary check has to be done before kind of I'm allowed to open account, right? So in order to do that, we normally don't do it in the front end. So that's why from the front end, we make kind of a REST API call. So these are nothing but, your calls which have JSON format. So if you remember whatever we did so far, like we used the Postman client to test our APIs. So Postman was nothing but we just replaced the front end and we use Postman to directly check those calls, right? So basically what happens is from your front end, there is a request or a call made to the backend server to either read some data, write some data, update some data, get data, like, all those kind of stuff. So where all this request goes is, this is the part that we actually created, right? So which is also called as your backend. You can call it as like, APIs, you can call it as web service, like there are a lot of names for it. So basically this is nothing but the core area of your application where all the business logic and everything is written. So basically what happens is you have like, you can use any of the languages like Java, .NET, Node, JS, which is nothing but JavaScript. So that Node.js is the environment, or Python, like, you have a lot of languages to write your backend services. So in this course, we had specifically chosen Java, and within Java, we had the Spring framework. So as I explained, whenever you use any framework, the advantage is it really abstracts and encapsulates a lot of things for you. So it becomes easy for you to speed up your development because a lot of ready-made utilities and patterns are provided to you out of box. So what this backend basically does is it does all the heavy lifting or the check of all the business logic, right? So this will be checking whether like, if my customer is like, eligible to open account, is my customer having a valid KYC, does my customer reside in India, is he or she a permanent resident of India? So all those kind of checks, right? So all this the kind of things we write in the backend. But backend is something where it only kind of like, just reads the data, writes the data, manipulates the data. Ultimately, all this data has to go and sit somewhere. So that is what you call as the database, right? So database can be of different types. So predominantly we have two languages or two scripts of databases. So one we call as SQL and other we call as NoSQL. Okay. So SQL basically stores all your data in columns and row format, and NoSQL stores them in the JSON format. Okay. So these are the two main technologies which we have, and a lot of common examples for SQL is I'm sure you would have heard about Oracle SQL, MySQL. For our demo, which we did till the last week, we use something called as the S2 database, which is an in-memory database. So in-memory database means it does not actually write to your hard disk. So till the point the server is up, all your data will be stored in the RAM. And once your server is killed, the data will be lost. So why we used S2 is we didn't really want to have all this configuration in our local system where we want to first create the SQL, write the data and all that. So that's why we use the H2 database. But don't worry, even in if you decide that you want to use Oracle or MySQL or Microsoft SQL, whatever, it's very simple for us. We don't really have to change a lot of code. Only in your application properties and in your POM dependencies, instead of you have to give the dependencies of whatever SQL JDBC connections that you want. So if you want Oracle, you will select the Oracle dependency. If you want Microsoft SQL, you can select Microsoft SQL dependency. And if you want NoSQL, maybe you can select something like Mongo and those kind of databases. So this is where how your entire application kind are repeat. So this is what are the different parts of your application. So you basically have a front end, which is where the user actually interacts with your application. This is your back end, where all the business logic and all this actual processing of the data happens. And you have the database where the data is actually stored. So with that clear, now let's understand what we did in the last 9 weeks, right? So as I said in the starting of this course, we didn't focus on the front end part because when we since our focus was majorly on the microservices or on the Java, that is the backend part, we were focusing purely on the backend part, right? We tried to understand how we can develop different microservices based on different functionalities. We also saw what are a few challenges that we can encounter when we are developing these different microservices and how we can overcome them. And that's how we were developing our application. And for the database, as I said, we were using H2 database. Why we were using H2 database, as I said, for the purpose of this demo, since our focus was predominantly on backend, I didn't really want to spend our time on learning the database, because all the databases are almost same, and it doesn't really make sense to spend some time to do the setup and all that stuff. So that's why I use the H2 database. But as I said, you can also, after at the end of this course, if you prefer, you can replace this H2 database with a SQL database or a NoSQL database and do it in your own free time. You are free to do that. For that, there is not much of a backend changes which you have to do. So I'll just quickly show what are the changes that you need to do. So if you come to the Spring Initializer website, right? So if you remember, for the H2 database, we had selected this H2 dependencies, right? So instead of that, so what you can do is, so say if you want to have a Microsoft SQL, so you can take MS SQL driver. So if you want to have MyBatis, you can take MyBatis. So if you want some other database, maybe like a IBM DB2 driver, you can select that. Or you want a MySQL, you can take MySQL. You want a Oracle driver, you can take Oracle driver. So that is step number one. Step number two is, so if you, I'm just showing you a sample. So the step number two is just come to the application properties. So I'll just open the application properties of the accounts. So I'm just opening the application properties of accounts. So if you remember that, we had did a few. So if you remember, we had did a few configuration or changes with related to the data source. So these were the predominant things that we added, right? So these part. So where we said, what is my data source URL? What is my data source driver? What is my user ID, password, and all this stuff. So instead of these H2 related configuration, you have to now give the configuration for the particular SQL or NoSQL server which you're going to connect. Okay. So these are the only changes which you have to do in order to change your database. And once you are done with that, you are good to go, and you can still use the application as it is. You don't have to touch any of the other code within our application, right? So that is one of the beauty of having this Spring framework. So how that happens is, I'll just quickly give a high level schematics. So basically what happens is, you have your code or you have your core services or whatever you say, like the API code or services that you write over here. And in between, what we did is, we basically created a data access object, right? Or rather, I would say the repository interface. So which will now interface or talk with your database. So what we have basically done is, we have decoupled the API from the backend database. So the advantage of this is, whenever you write any services, API or whatever, you don't have to really tightly bound it with whatever DB you write. So it's not like in your code itself you have to embed what is my JDBC driver, what is my the user ID, password, and all that kind of things. So to do all that heavy lifting, we have something called as this data access object in between. So that actually takes care of mapping your services to the database object and vice versa. So that's why, if you remember, we wrote all these different classes, right? So I will just show you quickly for what we did in the accounts. So if you remember, that's why we first created this account repository, right? So what this account repository basically does is, it's an interface which is extending the CRUD repository, right? So what is this CRUD repository? Is nothing but the built-in library which is given by your Spring framework, which helps you to kind of perform the CRUD operations based on whatever database you choose. And the type of it is just the same model or the same data which you are manipulating. So in our case, it is the accounts model. And if you just open the accounts model, so you'll see that here we have defined So here we have defined all the column names and everything which we are expecting. So as long as your database is having the same column name, we are good to go. So like, you can change as many databases as you want. You don't have to change any of these code. And just to ensure that, this, our GPA is kind of like, mapping all these columns to that particular, all these values to the particular column properly, we have kind of annotated with this entity annotation, which tells it that, just ensure that, all these things are treated as a database objects and you do the mapping properly. And also, as I said, we used this project Lombok. So why we used project Lombok is in a traditional way or the old style of writing Java code. For all these all these variables that you created, you also have to create that getter and setter class in order to fetch or write the data back to the database. But in order to avoid us to write all that lengthy code, we just simply give getter, setter, and toString. ToString is just to convert all the JSON back to the string format. So what's the advantage of this is if I just come to my controller. So right. So when I come to my controller over here, I don't really have to say really don't have to bother writing and defining all the method. I just simply say account repository dot find by customer ID. So find by customer ID is what I have defined over here. So where I say it just takes an input of customer ID. And if you see my controller, all I say is in this find my customer ID, I'm telling from this particular response or from this particular input that I give, just I say get the customer ID. So this get customer ID is automatically generated by Project Lombok. So wherein we know that, there is a column name called as customer ID, and from that it just directly maps this and sets this getter class. So that is the beauty of having Lombok. So as I said, that these are the few advantages of using your frameworks and other libraries when you are working with any language. You really get all these utilities out of box, which really reduces your development effort. Okay, so that is all about what we did. And just again, a quick recap what we did so far. We basically looked into microservices, right? We developed the microservices for accounts and cards functionality for our banking application, right? Then we converted it into Docker images, right? And pushed it into Docker Hub. Then we added a config server, which kinds of just takes out all the configuration inside the code and kept it on the cloud or in the external repository using GitHub. So we kept all our repository in the GitHub. From config server, what we did is we went to Eureka. Why we did that is this is basically for the service discovery and registration, right? From Eureka server, we also implemented our gateway server. Why we did that is to ensure that we have a single policy enforcement point. We are able to do custom routing. We are able to kind of do any cross-cutting, standardized implementation of cross-cutting concern, right? So for all these things, we use the gateway server. We also saw that whenever we have multiple microservices depending on each other, say for example like the profile API. So where the profile API depends on the cards API to get the data. So in this kind of scenario, we also saw how we can implement resiliency, right? So what is resiliency? So resiliency just means that, if one of my API is down, so instead of just returning the user an error or making all my API microservices down, I can simply return some default data. I can simply return a no data, or I can simply call alternative sources of data and provide the data. So that is what we saw in the resiliency. And finally, we also saw that how can we add tracing behavior into our server. So we saw that if I have tens and thousands of microservices, how can I find out where a particular transaction went, right? For that we implemented tracing using the Spring Sleuth tool. Then we saw a challenge like if I have to see the trace logs of tens and thousands of instances, that will be very cumbersome process. And in order to aggregate all that logs, we saw that we have something called as a Zipkin, which helps us to provide a centralized dashboard having all these logs in a central place. So this is what we did so far. And as I said earlier, while we were concentrating on the backend so far, we didn't really touch the front end, right? We really didn't create any of the UI or the HTML pages where we kind of wrote the data or fetch the data and did all that thing. Why? Because this microservices itself is a huge topic. So within whatever span of time we had, I tried to cover most of the major topics. And still there are other vast topics which you have to cover on your own if you're really interested. But I wanted to give you a flavor of how we can develop the front end. Now that we know how to create backend services and how to kind of interact with the database. Now the only part that is remaining is I also show you a flavor of how can we develop the front end applications using Spring. So why I'm specifically using Spring is, so as I said, Spring is a framework, right? It's an end-to-end framework of using Java. So wherein I can develop both my front-end application and also I can develop my backend application, right? So I can do both of this using Spring. So for backend applications, normally what happens is I use Spring Boot primarily, and also I have other supporting tools like Spring Cloud and all that to help me kind of kickstart my backend process work. And similarly for front end, I have a concept called as Spring MVC framework, which is kind of gives me guidelines on how I can create a front end application. So what we'll basically do is in the next session, we will now jump in deeper into the Spring MVC and understand what Spring MVC is all about, like, what is the architecture of it, what are the, like, the standard way of how MVC works. And then we'll be creating a sample application wherein what I will do is, so remember that in the accounts application that we created, we also had created a customers database, right? So we had a customers model which had these few basic data like the customer ID, name, mobile number, email ID, and created date. So what I will do is, let's kind of like, and also if you remember in our like, when our accounts started, like, we also had defined a data.sql file where we had inserted a few default data, right? So if you remember, these were the few data which we kind of created, and like, we just created this customer database and added a few data into customer when the application started. So the same logic we'll also do in our application, wherein we'll just create a customer database, add a few value, and we'll see how can we fetch this data from the database and show it actually on the UI. So far we were using Postman to do all the calls. So now instead of using the Postman, we'll directly use this front end application and see how it all works. Okay. So I'm sure you are excited like I am in order to, like, jump into the Spring MVC and understand how it works. And before we go any further, I also want to clear a few other things so that it's really simple for you to understand what happens. So as I said earlier, front end can be developed using multiple languages and multiple frameworks, but a few common threads still exist. So for example, you have HTML for actually, so what HTML basically does is it creates all the building blocks of your HTML. So just think that these as the bricks of your house, right? So what it basically does is, so say if I want to create a login page, so I know that, there'll be a user ID, username input field, there'll be a password input field, and there'll be a submit button, and there'll be a reset button, right? So what my HTML does is I basically define what are the different containers or different elements which I have to place in my HTML. So that is what the HTML does. But now it's not only enough that you just place the content, right? You also have to style it or either add some cosmetic appearance to it. Like, I want to keep my input red, I want to keep my password maybe gray, and I want to add some animations to my buttons. So to do all that things, that's where we have CSS. So where it gives all the cosmetic effects and doing all the visual things that you normally see in any website is basically done by the CSS. And finally, we have something called the JavaScript. So what JavaScript basically does is it adds interaction to your website. So when I say interaction, it means that in this case, so say for example, I give user ID and I didn't give password and I try to hit on submit button. So if you know that normally what happens is I get a kind of error over here saying password is mandatory, right? And in case if my password is wrong, I press submit button. So what happens? It sends the data back to the server. The server sends a response, and now my page changes to something else, maybe the home page or dashboard page. So all this kind of interaction is what is handled by the JavaScript, and these three are kind of building blocks of any application. But there's also one more thing which you need to understand, that when I want to develop my front end application, there are two ways how I can do it. So either I can do it as server side, which is what we are going to see, or we can do it as client side. Okay. So what is the difference between that is, when I say, like, for example, as I said, when I hit bank.in. So the question is, do I want my HTML, JavaScript, and all these things running from server, or do I want to run it from the user's browser? Okay, that is a key question. So if I say, do I want to run it from the server, then I'll be using server side rendering technologies like Spring MVC, and there are also a few other technologies like PHP, right? And even in React and Angular world, you have something like Gatsby, and all those kind of Angular Universal and all those kind of framework. So what these guys do is, they don't see, normally what happens is when you hit any website, and if it's a client side rendering application, so normally what the server does is the server will send all this HTML, CSS, JavaScript file to the client browser, that is to your Chrome or Firefox, these kind of browsers, and your browser will kind of then compile it all together and render it. And any interactions that you do, everything will be then done locally, and only when any data transfer has to happen, it will make a REST call to your backend server. But in case of a server-side rendering, your server will not send all this HTML, CSS, JavaScript and all separately to the browser and let it compile. Rather, it will directly compile the HTML and send the direct document to the user. And any click and any interaction that you do, none of that will be done locally. So any changes or any interaction that you do on the browser, it will be directly reflected in the server. So that is what we call as the server side rendering. And client side rendering is the normal technologies or things that we do with this is we have something like Angular, we have something like React, Vue.js. So all these languages, what they basically do is whenever you create a website, they normally send a JavaScript file and an index file to the browser of your computer, which is Chrome or Firefox. And after that, the application loads locally. So after that, there is no kind of interaction with the front end server. Anything that happens locally. And when you do any interaction with the site, you submit a form or you try to upload a form, whatever it is. So in those kind of scenarios only, it will go and directly contact the backend server. So that is what is the difference between the server side and the client side. And as I said, we are going to look on the Spring MVC framework. And Spring MVC framework basically uses two kinds of technologies to render the website. So the older approach that we used was called as JavaScript pages, which is also called as JSP. And the newer technology which is currently introduced is called as the Thime Leaf. Okay. So this is more like a templating engine and it is closer to writing a normal HTML page, whereas this is more verbose, okay? And it is kind of also outdated, okay? So that's why we are not touching JSP, but rather we'll be seeing what is Thymeleaf and how can we implement Spring MVC using Thymeleaf. So I hope that is clear. So in case if you still are not clear, I would recommend that you just wind through this entire recap session once again, and so that these concepts are really clear to you before we proceed any further, because it's simply not enough that you just know the terms and technologies. You also should understand how it fits into the actual enterprise application development that we do. So with that, we have now come to end of this first session, and I'll be looking forward to see you in the next session where we'll be discussing about what is Spring MVC. Thank you. Hello everyone, and welcome to the second session of week 10. In this session, now we'll try to understand what is Spring MVC all about. So Spring MVC is a project that is part of the Spring framework. As I said, Spring framework is a very large framework which comprises of many independent projects. So one of them is called the Spring MVC, which is used for building the front-end applications. It helps in development of the web application based on the MVC model, which is model, view, controller, pattern. So how this model view controller pattern works, now let's see, and also we'll see what is the components of the Spring MVC. So whenever you build any Spring MVC application, it basically these are the few components which you normally build or it is composed of. So the first thing is this is your web browser, which is nothing but your Chrome, Firefox, your Microsoft Edge or any of those web browsers that you use. So what happens is whenever a request is made from the web browser, so it first goes to something called as a front controller, where this front controller is the component which helps to manage the flow of Spring MVC application. And what happens is from the front controller, then the request goes to the controller. So controller is the main business logic area of your application, where the way you want to render the application, what are the conditions based on which you want to render the application, all those kind of business logic is handled by your controller. Then finally the flow goes back to the view, and the view is what I said, the code or the actual application that gets rendered, and that is what is sent to your web browser. So this is nothing but usually your HTML, CSS and JavaScript files, which are kind of sent to the web browser. Okay. And in case of a server-side rendering, there's not much of JavaScript because most of the rendering and the dynamic kind of the interaction is handled by the server itself whenever the user does anything. And in between, you will see something called as this model. So if you remember from our discussion of Spring so far, so model is nothing but the actual data which is kind of moving between all this. So if you see, basically all these are nothing but cycles. As I said, the view just represents the data on the screen, and model is nothing but the data that is kind of manipulated by the application. So this is kind of a cycle that keeps on going. Okay, so let's go to whiteboard now and understand this a bit in detail. So first, we have to understand when we say Spring MVC, what is this MVC all about, right? So when you develop any application, right, basically there are many patterns of it. So one of the common patterns which is used is called as the MVC patterns. There are also other patterns like MVVM pattern, which is like model view model pattern. Okay, and there's also like MV star pattern, wherein you are free to choose what you want. Like, you have a model view, but the controller can be replaced by something else. So these are various patterns by which we can kind of build application. But one of the common and time-tested strategy which we use is called as the MVC pattern. So basically, MVC pattern is nothing but it just has kind of three major things that happens. So first thing, you have your view in between, right? You have your model and you have your controller. Okay. And also, let's assume that this is being used by a user. So let's put our user over here. Okay. So let's assume that this user is going to see the view part of application. So what is view? View is nothing but actual user interface or actual application with the user will see and interact for your application, right? So that is called as the view. Okay. So what happens is the user is going to see the view, right? And they're also going to interact with the view. That's why it's a two-way arrow, meaning they will see the data, they will also interact with the data, right? So what happens is from the view, like, whenever the user interacts or changes any data, that interaction will then go into the controller. So what the controller basically does is the controller will get all the user actions. So say for example, whenever you submit a form or if you change any values on your UI or you drag and drop something. So all those kind of actions are then sent to controller and it has nothing but it will just pass the model. Model is nothing but the data, right? So it will pass the data to the controller and now your controller decides, okay? So based on, this is why I said it is the business logic of your, so business short for business. So this is where your business logic sits. So assume that this is a banking application. So your control is where now say for example the user has now decided to add create a account, a new banking account in your application. So he or she has now entered all the details and they have now submitted. So when they submit from the UI or the browser, what happens is a call is made to your backend controller wherein the data which they have submitted is also sent along with the action, which is add or create account, right? So now your controller decides based on the data given whether that data is valid or not, right? And also they will check based on the data and the user info provided, are they eligible to kind of open the account? And do we accept new application at this point of time? So doing all these checks, if it finds that all of them or many of them passes based on the business logic, it will then kind of take this data, okay, and it will go and update the database. Okay, so it will go and update your database and do all the other backend work that needs to be done. And what it will do is it will now go and update your database. Okay, so now what happens is once the database is updated, again the view gets changed. So what happens is whatever is the new update or the updated data, so that updated data now comes on the view. So where you say that user created or this is your profile information, whatever it is. So that update is now pushed from the model to the view, and that what the user will now see again. So this is what a typical MVC cycle looks like. So I'll just recreate it and in a simpler format. So you have your model over here. So a model is nothing but remember data, right? And you have your view over here, which is nothing but your user interface. And you have your controller, which is nothing but all your business logic, which is implemented. So I, as a user, when I interact with my application, I am predominantly interacting with my UI. So the view, what it does is that it makes a call to the controller with the data that the user has changed. The controller decides what I have to do with the data. Then it will go and update the main database or the repository where it stores the data. And once that happens, the updated data then comes back to the view and which is now shown to the user. So this is how a typical kind of the cycle goes through, right? And also at sometimes it happened here, we may have a two-way communication. So sometimes instead of updating the model, the controller may directly send back something back to the view. Maybe just like telling, hey, this is wrong or something like that. So where there's actually no requirement for the data manipulation to happen. So even those kind of scenario, it will be direct from the controller to the view. So that's why this will be a two-way communication and this will be kind of a unidirectional flow. And here again, it will be a two-way direct communication with the user because the user can interact with the data. The user also can view the data because basically they'll be doing all the CRUD operation over here, which is create, read, update, and delete. So I hope that is clear right now. So what my Spring MVC basically does is, so Spring MVC is basically nothing but one of the projects within the Spring framework, okay, which is used for creating the front end or the UI of my application. So far we were only concerned on how to create the backend services for my application, but now we are going to see how we can also create the front end part of my application, okay. So this topic is going to be quite vast because as you may be aware, so as I said earlier that basically when you have to learn Spring MVC, there are a few basics which you should be aware, which you also discussed in the previous session. So first you should understand how any website works, right? So I told there are like three building blocks for any website, which is HTML, CSS, and JavaScript, right? So you should have at least some basic knowledge of these three. Then also you should now then be aware of how the Spring MVC works, right? So what happens behind the screen, what are the components, what are the stuff. So you should be aware of that. So that's what we are going to cover now. And finally, you should also have some hands-on experience in creating the Spring MVC application, right? So this also we'll be doing now. But given the length of this course and the time that we have for this week, so what we will basically do is we will understand the Spring MVC better in a better way. I will also cover the basics of HTML and CSS as we are creating the application. And for the application, what we'll basically do is we will create this customer database which we had used for accounts, right? So we already had created this model for customer database. So what I'm going to do is I'm going to create a very simple application, a front-end application, which is going to list me the name of all the customers which are present in my database. Okay. So what we'll do is in this CRUD operation, we will just do this read part in this demo, wherein I will show you using Spring MVC, how can you fetch the data from the database like and show it on the front end using the Spring MVC concepts. Okay. And how we are going to do the HTML part, as I said, Spring MVC basically gives you two options. Either you can do it from JSP or you can use Thymeleaf. These are the two competing methodology how you can create the UI in Spring MVC. So I also said that JSP is an outdated way of creating it because it is using servlet and it's also more verbose. So what I mean by that is when I say it is a servlet and it is verbose, you have to write lot of code in order to create this. And even the code that you write is not very natural because in your front end itself, you have to write lot of logic in order to manipulate the data. However, Thymeleaf is more, it's a templating language. Okay. So what I mean by templating language is it is closer to the HTML language. Okay. So I'll show you how a typical HTML looks in case if you're not aware. So this is something very similar to HTML. So people who know a bit of HTML basics it will be very easy for them to learn Thymeleaf. And also from your career perspective, I would strongly recommend that you look into Thymeleaf a lot compared to JSP because this is where the world is moving. And also for your information, like in many of the real world applications or companies, normally the front end is not created with the Spring MVC or the server side rendering technologies. I mean, there are scenarios where you have to use it. I'm not denying that. But there are also competing frameworks or client side rendering frameworks which is used. So as I said, there are frameworks like Angular, there are frameworks like React, there are frameworks like Vue.js, and so on and so forth. So these are a typical few library frameworks which are used, and all of them use the concepts of JavaScript or TypeScript. So these are the languages which is used to create this client-side UI applications. So whenever you feel comfortable with Spring MVC, I also would kind of recommend you that you go through at least one of these framework. The React is most popular of all these. So if you get a chance, please look how you can create UI using React. So it will give you a different perspective of how you can create various applications. So with that said, now let's get into the architecture of Spring and understand how Spring works behind the screen. So now let's understand how the Spring MVC architecture looks like. So this is a typical architecture diagram of the component of the Spring architecture. It has a dispatcher servlet. This is the core of Spring MVC. It has a handler mapping. It has a controller. It has a model and view. It has view resolver. It has view and it has request. So these are a few parts of your Spring MVC, or rather I would say these are kind of the flow of how a request flows from your in your MVC application. So now let's try to understand how this any request to your Spring MVC, how it works. So when I say request, it just means that from my web browser, when I type any server name or any application URL. So say for example, I just started in my local and I type localhost colon 8080. So that is a request which comes to my Spring MVC server, right? So that's what we are trying to understand what happens when that request comes in. So the first component that kind of intercepts this request is called as the dispatcher servlet. This is kind of the core or the base of your entire Spring MVC. So what it basically does is it intercepts all your request that comes into your Spring MVC and it first acts as a front controller. It will decide what it has to do with that particular request. Okay. Then what it does is based on the request that comes, it will then it will try to find which handler is going to map the kind of handle this particular request. So as we know, we already saw in our the microservices discussion earlier also, we create kind of lot of APIs, right? So inside accounts, we had slash profiles, slash accounts, slash config props, so on and so forth. So what happens is when you hit on that particular URL, the first your controller decides where I have to route this particular request. So similar to that, this dispatcher servlet will then decide based on the URL where I have to kind of send that particular request. And how it finds out it, there is something called as a handler mapping. This is nothing but just a XML configuration which the Spring maintains. So it will try to first look up for this particular request, who is the handler to whom I have to send this particular request. Okay. So the handler will give the response saying that you have to route it to this, and now my dispatcher servlet, what it will do is it will dispatch that particular request to that particular control who is going to handle this particular request. Okay. So say for example, we have now two websites or two pages. So one is say maybe the home page and second say maybe is the hello page. So first, my say and the user is requesting for hello page. So first, what happens is my dispatcher servlet will check where I have to send this hello request. It will find that data from handler mapping, and once it gets the handler data from handler mapping, it will then route this particular request to the controller which is handling the hello page. Okay. And after that, what happens is we have this model and view, right? So what is this? Basically, the model and view is, so basically this is nothing but your controller then gives the particular model and view binding for that particular request. Meaning, what is the data that is associated with this particular request, and what is the view that I have to create. Okay. So when I read my view, it will just give the reference of the HTML page which has to be displayed, and the data which has to be bound with that particular view, and that is kind of retrieved and sent to the dispatcher servlet. And after that, what the dispatcher servlet will do is, based on the reference of the view which it gets from the model and view, it will just send it to the view resolver. So where the view resolver will then take or find the particular HTML which has to be rendered, and then finally the dispatcher servlet will check where this particular view is, and it will invoke that particular view component. So in our case, it will be a HTML file like your hello.html, which will be kind of displayed to the user. So this is how your Spring MVC architecture works. So this is just a summary of what we have seen so far. So the incoming request is first intercepted by the dispatcher servlet, which acts as the front controller, as we saw. Then the dispatcher servlet forwards this request to the controller, and after getting the handler mapping details from the XML file. So this is what I said now, right? So dispatcher servlet first checks with the handler mapping, sees which controller I have to forward, and then it forwards to that particular controller. After that, the dispatcher servlet checks the entry of the view resolver in the XML file and invokes a specific view component. So once I get the model and view details from the dispatcher servlet, I'll then look up from the view resolver where is the particular HTML file or the view which I have to invoke. And once I find that, I will just invoke it. So this is how the MVC architecture works. So don't worry if it looks really complicated. Once we start kind of implementing the Spring MVC stuff, it will be quite easy for you. And with that, let's now check what is the typical Spring MVC configuration like. So what we basically do is Spring Boot makes it easier for us to automatically configure a Spring MVC project based on the dependencies that is declared in the class path. And for the purpose of this course, we'll be using the Spring Boot to create an application based on Spring MVC. So what I mean by this is so basically we use the start.spring.io to create any new application, right? So far, whatever, the microservices we created, we came here and we created. So what we will do is we'll use the same Spring Boot. That is we'll use the same Spring Web dependencies. We'll also use the other dependencies to kind of create our MVC application as well. So that's what we mean that we'll be using this underlying Spring Boot, but on top of it, we'll also use the MVC components. Like as I said, we'll be using something called as a thime leaf, which is used for creating the front end views. So we'll be using thime leaf and other stuff in order to create our MVC. And the reason we are doing that is Spring Boot really makes it easy for us to create our MVC, as you will see right now in the maybe the next session where we'll be creating our first MVC based application. So just to let you know that we'll be creating our Spring MVC application using Spring Boot. Okay. And before we proceed any further, I want to end this session right now, because in the next session we will then see what is the configuration or what parts of the Spring MVC will we be configuring to create our application, and based on that we will start creating our first Spring MVC based application. And I would recommend that if you are not able to recollect how we created our microservices so far, I would strongly recommend that you just wind back to one of the previous week where we created a new Spring a boot-based application either for accounts or cards or gateway server or Eureka server. So if possible, just go back to maybe the week 3 where we created our accounts and card services and just have a quick look at what are the steps we did, because that will help sure that you just kind of recollect the steps that we did then, because the same kind of steps we'll be doing now as well. Okay, so don't worry. Anyways, I'll be kind of revising all the steps again, so it will become easy for you. Thank you, and looking forward to see you in the next session. Hello everyone, and welcome to this third session of the 10th week of the microservices course. So now let's try to understand what are the configurations of Spring MVC which we have to do, or what are the parts of your Spring MVC project is which we have to configure in order to create our application. So as we saw, Spring Boot really makes it easier for us to automatically configure a Spring MVC project based on the dependencies declared in the class path of application. I just showed to you in the last session as well. So wherein I say that whenever we create any Spring based project, so I'll just go to my Spring Initializer website, and over here I will by default add the Spring Boot, that is the Spring Web. And along with that, I will also add kind of my MVC related stuff. So I said we'll be using Timely for our development along with the other dependencies for database and other stuff. So this is what we are going to use, and the similar way we'll just click on generate, the zip will come and we'll be doing it. So the advantage of that is, since Spring Boot is handling all of this internally, we saw even in the earlier sessions, right? Whenever we added any new tool like maybe the Spring Sleuth or the Spring Gateway, so there's a lot of internal wiring that happens, which really reduces our time to configure things. So that is what I mean by we are going to use Spring Boot in order to create our Spring MVC application. So the next point is, there are a few key components of a Spring MVC project which you should know, which works together to make up the complete application. So on a high level, we already saw this earlier. So just it's on a different, we are just going to explain it on a different level. So the first thing is your web browser, which is nothing but your Chrome or your Microsoft Edge or Firefox, Safari, those kind of web browsers from which you are going to access the application. The view is nothing but the actual final rendered HTML, CSS files which get rendered, sent to the web browser for rendering. That is called as view. Controller is nothing but just going to invoke the business logic and work with the data. Services or your repository, which is nothing but it's going to provide the business logic and functionality for the application, and also it will be working as mapper between your controller and DAO, which is nothing but the data access object. So what is a data access object? We already saw in the initial part of the session. So this basically separates the application from the underlying database. So what happens is you just create all your columns and configurations, and based on the Spring gives you this concept of based on the underlying database, then it will do the requisite mapping from this model to that database. And for that we have certain tools like GPA and stuff. We have the Spring Data GPA tool, which kind of then works with the whatever data database you use and store the data. So this is a conceptual view of this Spring MVC configuration which we already saw. So as I said, this is a view which we can implement either with JSP or Timeleaf. We are going to go with Timeleaf, and I also suggested that you should go with Timeleaf because that is more a natural way to write your HTML code, and also it is a preferred framework. JSP is kind of dying right now. And what happens is, whenever a user requests any application, first the request will hit your controller. The controller will then check with the model. The model will then be converted, your model will be then mapped by the DAO into the particular database to retrieve the data. Then it will get mapped to that particular model, assigned to your controller, sent to the view, and that will be shown to your web browser. So that's how this entire thing works. So if you are not clear on how this works, don't worry, I'll be also showing it to you based on whatever we have created so far in just a few seconds. So before we proceed, just a few quick notes. So what we can do is basically we'll just simulate a scenario wherein we want to create a user management page for the banking application. So wherein we just want to check who are the users or customers of our banking application. So we'll just create a simple page which is going to load all the data, the actual data from the database, and show it on the UI. So for this, the user interface or the view will be created by Timeleaf. The backend services will be created by Spring Boot as usual, and the database management is going to be done by H2. So this is what we also used for all the 9 weeks. So this will be kind of easy for you to understand. So now let's jump into the demo and understand how this works. And before going any further, I just also want to show you how this actual mapping works. So just understand what we did here. We say that we have a controller, we have a model, we have a data access object, and we have a database. So I want to show you in practice. I would say just want to revise this part alone of how we have already achieved this right so far. So let's come to our accounts application, which we have created already, right? So if you come to your accounts application and just come to your SRC main Java, right? So we have created a bunch of packages already. So we have this main class called as accounts application. We also had, you can just skip the config because it is related to the config server. But we also had a few other package. One is the controller, and one is the model, and one is the repository. So when I say that, when my data moves from the view to the controller to the model to the data access repository, basically what happens is I first create a model, right? So model is nothing but if I just take maybe my customers.java, right? So I'm basically telling my Spring application, since I'm annotating it with this entity annotation, I'm just telling that, this is the, consider this class as an entity or an object which has to be mapped with the database where you'll be retrieving and writing the data to. So I'm saying that whatever is the underlying database, just map all this value to that. So in that, again, I'm telling these are the specific column names and this is what is the name which I'm going to use in my application. So say for example, I have a column called customer ID, then I'm mapping it as customer ID, like camel casing and underscore, that's the only difference. So what basically happens is in your underlying application, like whatever database is there, I'm just telling that no, these are the variable names or these are the column names which are present. Okay, so this is step number one. So using that, we also created something called as the account repository or the repository interface. So this is where your actual DAO or data access object comes into play. So basically what this repository does is it is extending something called as a CRUD repository, which is a built-in kind of interface from or class from your Spring repository. So what it does basically is it will kind of now map these columns that you have created with the actual database which is you're using. And how it finds the actual database. So in your application dot properties, you have defined what database you're using and what are the properties. So we say that we are going to use the H2 database. So the driver is H2 driver. So driver is nothing but what database you're using. And also you have specified what is the URL, what is the user ID, password, and all that stuff. So basically what happens is now this using Hibernate, which is a ORM or object relational model, which converts all this simple data into actual SQL queries. Now your data access object will now kind of convert all these mappings that you created, the customer data that you created, into actual SQL queries, either search or write into the database and fetch whatever is the actual value back and map it to this. So now what happens in my controller is in my accounts controller or any of the controller. So whenever now I get a request for say /accounts. So what I basically do is I just call my accounts repository, and in my accounts repository I've just defined a method, right? Find my customer ID, and I'm passing the customer ID. So what it does is from my underlying database, right? So from my underlying database, it will just try to find what is my customer ID and whatever is the query that the actual customer sends, right? So in the Postman, if you remember, we used to send customer ID 1 or customer ID 2. So whatever is that number, using Project Lombok, it will get that particular customer ID and it will pass it to this repository, which will actually make the call to the database, fetch that data and store it to this variable, which is now kind of returned back to my end user. So that is what we have done so far, and that's what even I've explained in the Spring MVC architecture as well. So with that said, I'm sure that now you are a bit clear on what are the basic moving blocks of creating any Spring application. So basically, you need a few things for sure, right? So the first thing that we require is we first need to kind of create the application using the start.spring.io, so which we'll be doing in a few minutes. So once you have the application ready, then you have to kind of define your application properties, stating what is the database and server port that you're using. So these are some of the mandatory stuff that you have to define. And after that, within your project, you have to define a few packages. So by default, you will have the main controller, the main Java class file, that is fine. And after that, you have to define minimum three packages. So one is for your controller, right, which will be handling all the requests. One will be your model where you define all the the column names and data which you'll be using. And finally, you'll also define a repository, which is nothing but your data access object, right? And since we are going to create the front-end application using Spring MVC Timeleaf, so what we have to additionally also do is, if you come to your SRC main template, you will see that there's a folder called as template which is present. So far we haven't created any template because we weren't really rendering in HTML. But in case of Spring MVC, you also would have to create HTML pages which will be kind of called by your controller from the controller to this particular template, right? Which will be kind of rendered in the UI. So we'll see how all this happens. And for that, I just want you to kind of go back to this diagram which we had talked about earlier, like how your Spring MVC is actually fetching the view from the the view resolver and sending it back. So this is what exactly will happen behind the scenes when we are going to create our template and call it from the controller. Okay, so I think we have talked a lot about the theory part. So now let's get into the practical stuff and see all of this in action. So what I would recommend is this project is not dependent on any of these other projects which we created so far. It's going to be entirely a new project, right? So just like your gateway server, Eureka server, we are going to create a new standalone application. And since this is going to be a Spring MVC, we are not going to kind of create the Docker images and stuff like that. We are just going to kind of run it from a local and understand how it works. Okay. So now let's do the step one, which is kind of creating your customer's application. And before we proceed, I'll just kind of repeat or just tell you what we are going to build. So basically, we are going to build a dashboard, right? Or a page which is going to show us the list of all customers who are using our applications. And if you remember from our previous accounts and other discussion, we actually had created a model of customers who had these basic details. So a customer will have a customer ID, name, mobile number, email ID, and when they were created or when they were added to a system. So using this data, and also we will kind of add some sample data into a database using the data.sql file. So if you remember from the previous discussion, we can also create data when the server starts. We will have some test data. So we will create some similar data in our database for us to test, like, whether we are able to fetch that data from the database and show it on the UI. Okay. So now let's get started. So first I will go to my start.spring.io website, which is my Spring initializer, just to create my basic application. So the first thing, the group name. So always say that this is the reverse of whatever is your domain name. So if my domain name is bank.in, I'll create here in.bank. Okay. And the artifact name. So here I'm going to create a customer management application. So I will just call it as customers. And if you want, you can also give it as customer management. That is fine. After that, description. So I'll just say customer management application for banking app. Okay. Or I would say just customer management for banking app. Package name is auto created based on the artifact name you give. So it is going to be a jar. It is based on Java 11. And the dependencies, let me just add one by one so it is clear to you what we are doing. So the first dependency which we had as usual is the Spring Web. So this is useful for us in order to create the REST and other stuff. And also it will be useful for us to kickstart our Spring MVC development. The second important dependency which I'll add is the theme leaf. So why we require theme leaf is this is what we are going to create our HTML with. So to create our view or the HTML part, we are going to use theme leaf. The next thing is the usual data dependencies which we add. So first we'll add the H2 database. Okay, so this is a dependency. And since we are going to work with databases, we also need the Spring Data JPA, which is actually going to do all the mapping work, right? I said internally it will be going to convert all your code into actual SQL queries. So that is where the Spring Data JPA comes into play. And so I will also be using our favorite project Lombok. Why? Because as I said, we want to reduce the boilerplate code of setting and getting all the data or model which we create. So that's why I'm going to use Lombok. So once I do all this, so I think we are good to go. I'll just kind of create a hit generate. And also if you want, you can also add Spring Actuator, but I think we have done enough of it in this demo. We really don't need it. So I'm not adding it. So now you can just click on generate. It will create this zip for you. So you know the drill. So what you need to do is just kind of take this or extract this particular zip and just extract it to the folder where you have created your rest of the services, right? And you also, if you want, you can put it in a new drive, that is a new folder, that is fine as well. So I have now extracted it to a local folder. So since I have now extracted it to my local folder, I will go ahead and import it. How I import it? Come to Eclipse, come to File, come to Import, then come to import existing Maven project, then come to the folder where you had now extracted it. So in my case, it is over here. So in your case, wherever the folder is, just select that. Automatically it will show the pom.xml. Just select that, click on add to working set, finish. So now you see that it has started to import the Maven project. So just wait till this is completed because we are adding it for the first time. The Eclipse will auto download all the dependencies for you. So this is going to take some time. So please wait till that is done. And meanwhile, you see the customers is added now, right? So once that the customers is added, the next thing that I want you to do is we have to update the application properties. So this is going to be similar to what we have added already for accounts. So I'm not going to type each of these. So rather what I will do is I'll just go to my accounts, go to my resources, application properties of accounts. And these first 11 lines, right, I'll just copy them as it is. Or probably what I'll do is I don't need the Spring application name and profile because these are config related. So I'll just copy the part from here, right? So I'll just copy from Spring data source URL till my server port. Just copy these lines, come to your, and by the time your Maven is also done, so we are good to go. So come to your application properties, paste all that we copied from accounts, and just like quickly review what we have copy pasted, right? So the first thing is we are telling what is the URL of our H2 database. So it's an in-memory database. That's why you see as memtestdb. So this is the name of the default database that gets created. The second, we say what is the driver class name. We are saying it is H2 driver because we are using the H2 database, and we have to create a user ID and password for this database. So we are using the default admin and pass, or you can also give whatever you want. And next we say what is the database platform. We say use the Hibernate dialect of H2. So internally it will be mapping all your code that you write into the actual SQL queries for H2. Then we say JPA deferred data source initialization. So what this does is once your Spring is totally initialized, after that it starts creating all these database connections, right? So at times what happens is you might get some conflict during application boot, especially when you're starting multiple servers. So that's the reason we gave this for accounts. But in our case, for this, since you're only going to start this server today, even if you don't give this, that is fine. Okay. And we have also enabled the H2 console. Why we have enabled this? In case you want to just check what is the data that you have in your database that is created. That's why we have enabled this console so that you can quickly check what are the data that is present in the database. And finally, we have given the server port as 8080. So either you can use 8080, but in case you feel that if it will conflict with accounts, though we are not going to start both the application together, you may also give it some other port. Maybe like, I can give something like 4000. So that is fine as well. Okay. So this was the next thing that we needed to do. So, and once you do this, we will also create our test or sample data.sql file and add some test data to it. So since we already know what is the kind of customer data we have, we'll simply just add those SQL queries so that whenever we start our server, we'll have some data in our database so that it will be shown on the UI. Okay. So how to create it is very simple. So what I'll do is I'll just come to my SRC main resources, right click on this, go to new, go to SQL file. The name of the SQL file is going to be data. So I'll just give data, finished. It will create my data.sql file. Now again the same drill, I'll just go back to my accounts data.sql file which is under SRC main resources. Over here, I'll just copy a few lines. So the first line that I'll copy is drop table if exists customer. So it means that at the startup, if already the customer data is present, table is present, we are just kind of deleting it or dropping it. So normally it won't be present because it's an in-memory database. So every time you restart your server, it gets deleted. But this is just like for a backup purpose, so that you don't face any error at the start at the runtime. The second thing that you'll do is you have to create this customer table. So we'll copy this as well and we'll paste it over here. So what this customer table basically contains is your customer ID, which is your primary key, and it will auto increment. Auto increment means based on every data that you insert, automatically this customer ID will get incremented like 1, 2, 3, 4, and so on. Next, we have the name of the customer, which is like you can have character up to 100 and not null means you definitely have to give data for it. Similarly, you have the customer mobile number, which is also a varchar. Why we have kept varchar? Because the customer can enter some special character like plus, right? So you can give plus 91, 1, 2, 3, 4, whatever. You also have an email ID, which is a varchar like a string. And you also have a created date, meaning when the customer got created in our or added into our application. Okay. And by default, that is null. So that is what we have. That is the database which we have defined. The next thing that we want to do is we also want to now add a few data. So I'll just copy this insert data queries that we already created and I will now paste it over here. So basically what we are telling is we are just inserting a few random customer entries into our database. Why we are doing that is when we create our UI, we want to show some data, right? So that's why we are creating some test data. And in order for us to really differentiate between this data, I'll just make all of the entries a bit unique. So what I'll do is skill link. The first one I'll just give skill space link. And for the mobile number, for the first one, I'll maybe just add 7 at the starting. The second number, probably I'll just add 8 at the starting. And for the third number, let it be 9. And similarly for the email ID, I'll just give test. The second one I'll give test 2 and the third is test 3. That is fine. And the created date, let the first one be the current date. The second one I'll just give maybe 10 days from the current day, meaning like it will show the date which is 10 days from behind today. And for this, maybe I'll show some day which is 100 day behind today. Okay. So this is the created day. So all the entries are kind of unique. So it easily helps us to identify like if the entries are coming properly or not. So this is just for the testing purpose. I've added all this SQL queries. So what happens is when my application starts, all this data will be now present in the H2 database. So we are done with this. So the next part, this is where it gets interesting. So we will just do the usual stuff that we always used to do. So first we have to create the packages. So as I said earlier, we need to create basically the packages for three main stuff. One is your controller, right? The same stuff that we did for accounts, right? So we just expand accounts. So we have to create one for your controller, one for your model, and one for your repository. So these three things are the basics which you have to create. So first, whenever you start, always start with your model because that kind of gives you the idea of what data you're working on. Then based on that model data, you will then create your repository, and from the repository, you have, like, since you call your repository from your controller, then finally you will create your controller. So let's go in that order. So first, what I will do is I will come to my SRC main Java of customers. I will create my new package. And in the package name, we follow the standard format, which is in.bank.customers. That is my main project name. Dot. So since I'm going to create my model first, I'm giving dot model. So once I create my model, just right click on this, go to new. So basically what we are going to do is we are going to create now a Java file, which is going to hold our model, right? So this is going to be a class. So I'm just going to select new class. And what is the name of my model is, since it's going to hold customer data, I'll just give it as customers and finish. So this is something which I'll be doing all the while. So nothing new here. And what I will do is instead of writing the same stuff again and again, and since we have already done this in the past, I'll just go to the model of my accounts, go to the customer.java of my accounts, and simply copy all this. Why I'm doing that? Because we are going to create the same model again. So we are using the same model again. So I will just copy paste the same thing again, but we'll quickly go through what we have done so far. So basically what I'm doing, I'm first annotating this class with the entity annotation, which means that, this data that you are going to use here is something which you are going to interact with the database. So that's why you're putting the entity annotation. So this will be kind of working with the JPA repository in order to set and get the data. Then we have the getter, setter, and toString. These are your Lombok utilities. So the reason we are using this is, in the traditional way of creating this model, you also have to define the getter and setter for each of these kind of the variable names you give. So you have to create a get customer ID, set customer ID, and pass the value and all that stuff. So in order to reduce the boilerplate code, we are using getter, setter, and toString. The advantage of that is, if you just see the controllers account.controllers file, right? So here you will see that, whatever request I get, I directly do dot get customer ID. But if you just search your application, there is nowhere we have defined this get customer ID method. What Lombok does is, based on the models that you have created, where you say that, I have a data called as customer ID. So when you put get customer ID, automatically Lombok finds out that you are trying to get the value of this customer ID. So that is the use of Project Lombok, and that's why we are annotating it with getter, setter. And finally, we also have this toString, because whenever we get the data from the backend, it will be like, in the SQL format. And what we do is we just convert it to plain string and send it back to the controller. So that's why we have this toString as well. Okay, so these three are kind of coming from your Lombok. And here the same stuff, right? So the customer ID is going to be a primary key, or the unique, the column with the unique values. So that's why I've just set it with the ID, stating that, to my Spring, that this is going to be my primary key. And then I say that, since I'm going to auto generate the value for customer ID, meaning that, whenever a new entry is created, I'm just going to increment it. So that's why I say generated value is auto. So every time a new entry is added, it will just automatically increment the customer ID. Okay. And after that, we have this column annotation which says what is the name in the database that will be present. So if you see our data.sql file, so let me just quickly open data.sql. You will see over here that, we have created the column name as customer underscore ID, right? Email underscore ID, created underscore ID, mobile underscore name. So the same name is what we give over here under the column annotation. So it's saying that this is a database name. So that's why I said is the beauty of the data access object, right? So you just specify what is the column name, and irrespective of the technology or the database that you use in the backend, the code will not change, right? So even if you change tomorrow to a SQL, all these things will not change. Only thing in your application property, you will just point it to the SQL and add the necessary dependency in the POM. That's it. So similarly, we have defined for customer ID, name, mobile number, email ID, and created it. That's it. So these will be the variable names which will be used inside the application. And this is the column name to which your JPA will be writing the data and fetching the data from. That's it. So this is what your customer model is all about. So now once we have created the customer model, the next step is we have to create the repository. So I'll just right click on my SRC main Java again, create a package for repository. So the name of my customer repository, the name of this repository can be customers. Like, first I'll create the name, the package. So the package will be in dot bank.customers.repository. So this is where the actual mapping happens, right? This is acting as my DAO. So here I'll go and create a new interface. Why? Because it is implementing the current repository. So that's why this is going to be an interface. So here I'll give the name of my interface, which is going to be my customers repository. Okay. And just click finish. So once I do that, it creates all this interface for me. Over here, it is quite simple. What I have to do, this is also going to be similar to your accounts repository, but there's a change. I'll tell you what's the change. So in the accounts repository, we have created a method called find by customer ID, where we are actually passing a customer ID, right? So if you just remember from our previous discussion, whenever we used to like make any query, we used to pass one customer ID, and based on that customer ID, we used to get the data, right? But now in our case, for this particular application, we don't require to search by customer ID. We want to get all the data, right? And so for that, we don't really require this find by customer ID or similar implementation over here. So that's why what I will do is I'll just leave it empty, meaning that I'll just let my customer repository just implement the CRUD repository. And in my controller, I will just find all the data where the customer ID is present. Okay. And before that, since this is going to be my repository, I have to annotate it with my repository annotation, and right click and just click on this error and import this repository. So this by using this repository annotation, what I'm doing is I'm just mapping it, like telling the Spring that just ensure that you are marking this as a repository where all my mapping takes place, right, from the data to the actual backend database. And this repository is going to extend my CRUD repository. So this is a repository where this is an interface which Spring offers to perform CRUD operations on any database. And the type of that is going to be like the data which I'm going to get is my customers model. And the type of that is going to be a long integer. So that's why I put long. And once I do that, I just import all of these. So CRUD I import from my CRUD data Spring data repository. Customers I'll be importing from my model. And long is anyways the JavaScript default data type. So no need to import that. So once I do that, we are good to go. No need to implement any method over here, right? And after that, the final thing which we have to create is your controllers. So just the same thing. Come to src main Java, come to new, come to package, give the name. So it is in.bank.customers.controllers or controller. Okay, finish. And now you create a class inside this. So right click, new class. So the name of this is customers controller. So you create the customer controller. So by default, all this gets created for you. So now is where the magic happens, right? So now we have to define the the endpoints or the URLs where our customer will be hitting our application and what we have to serve in return. Okay. So before we do anything, first we have to do a few basic things. So first thing is we have to annotate this as controller. Okay, you are telling Spring that hey, just consider this as a controller. So this will be acting as the point where all my requests will be passing through. That's why I'm annotating it with controller. So if you don't give that, Spring will not really know what to do with this class file, right? After that, since we have created a repository, now we need to auto-wire this repository with this class. So we basically just use the auto-wired annotation, and now we just do private customers repository and just define the same variable again. So customers repository and just import all this. So AutoWire, just import it from the Spring, and customers repository, just import it as well. And that's it. You're done. So this was step number 1, where I'm just auto wiring this particular account repository with my customers controller, which will get auto initialized whenever this class is called or initialized. Okay. So now where the magic happens, we have to just define the API URLs or the endpoints on which we have to serve certain files. Okay. So this is where it gets interesting. And I told that, you also have to now remember the architecture components or the request flow diagram, which we saw earlier. So let me first define a simple mapping, and then we'll see what it means. Okay. And before that, as I said, we have to define the HTML templates for our application in order for this controller to serve it. So what I will do is I'll just take a very basic example. I'll just come to our src main resources template folder, right click on this, go to new, go to other, and here I'll just search for HTML. Since you're going to create a HTML file, click on this next, and I'll give a name. So maybe let's give the name of this file, just to rename this or remove this new file, let the dot be there, and maybe just give it the name of hello. Okay. So just ensure that you give the name of the file as hello.html. So now you see under a template, a new hello.html file is created, right? And this is the basic boilerplate code which is created, meaning the basic parts of your HTML template. Okay. So the title of this page. So in case you are not comfortable with HTML, I strongly recommend that you first go through the basics of HTML. So this is the basic HTML tags for any website that we create, right? So you basically have the HTML, which is just the marking of the application. Title means what title gets displayed on the browser, and anything you put inside the body is what you'll be seeing in your application. Okay. So let me put the title as, say, maybe welcome to bank.in. Okay. And inside the body, I'll just put maybe under h1 tag. H1 tag means it's a heading tag. Okay. It will be shown bold. I'll just say welcome to bank.in. And in the next line, I will just say in a paragraph tag. So P means a paragraph tag. So I will just say maybe this is rendered using thymd. Okay. So this is what I want to do is basically I want to render this hello.html whenever anyone is hitting my say slash hello is requesting for slash hello page. Okay. So what I will do is just like the same way how we defined all the APIs. So if you just open accounts controller, you just see, right? Just the way how we defined all the API endpoints. The same thing we'll do in our customer controller as well. So remember, by default, whenever you hit any website from your browser, it is going to go to the server as a get mapping. So that's why we are defining the get mapping. And now the argument for this get mapping, we'll just put it as slash hello, because this is the API which our user will be kind of requesting. And now I will define our method. So I'll just say public string hello page. And here, now I will declare something called as a model. Okay. So what is a model? So first let me import this model. So basically what a model does is it will give you all the attributes of that particular HTML page. Okay. So if you just come to this HTML page, right? So basically you can define a lot of things inside this HTML page. So this model will give you all the attributes of this HTML page through which you can now manipulate it, or like, write some data to this HTML page from your controller. Okay. So that is the use of this model. So initially, I'm not going to do anything with this model. So I don't want to confuse you. And before you proceed, ensure that you are also importing this get mapping to remove this error. Yeah. And now what I will do is I'll now return a string. Okay. And the name of the string is hello. Semicolon. So now let's understand what we have done. So in our controller, whenever there a request comes which says take me to slash hello, your controller will just return a string called as hello. Okay, it is not returning the HTML page, it is just telling return hello. So this is where I said you have to now just revise what we learned so far. So let me just open the request flow of Spring MVC in parallel so you can see both of them in action. Okay, just give me a second. Okay, so I've just opened the request flow and this in parallel. So first we saw that the dispatcher servlet will determine where this particular request has to be forwarded using handler mapping and sent to that particular controller. And then your controller will return a model and view. So what a model and view is, this is a model, meaning all the data or content of the HTML which you can manipulate. And view means what is the page reference or which HTML I have to load. So here when I say hello, it means that in my templates folder, there is a file which starts with the name hello. So that's what I have to return now. And once this hello comes back to the dispatcher servlet, it will use a view resolver, which is nothing but this view resolver will just get into your templates folder and check which file has this word, has the name of hello.html. And that it will then return to the dispatcher servlet, which it will use to now render the view. So what happens internally is your dispatcher servlet will check which file has this name, like, using view resolver, it will check in my template which file has the name hello.html, get that file and send it back to the browser. So that's why we just return a string over here. So what happens is when you return the string, it automatically searches for the file which has the name hello.html. So all this happens behind the scene. That's why you don't have to code much and it will serve. Okay, so that's it. We have kind of written our first Spring MVC basic application. So now let's try to test this. So how to test it is very simple. Just start the application. For that, you just go to customers application.java file, right click, give run as Java application. That's it. So since this is a very small application, this normally shouldn't take much time to start. So first it will start the H2 console, and after that it will quickly start your customer application. Okay. So now you see that it has started the customer application. So you know how to test it. So remember that in our application properties, we have given now the server port as 4000. So what I will do is I will come to my Chrome. I will first type localhost. Then I will type 4000. And if I just give enter, right? You'll see that I get error because by default, when you don't give anything, it will try to resolve to index.html. And since we have not defined index.html in our templates, that's why you see this white label error. Okay. But now let's try to hit hello. So that is what, if you see over in the controller, so customers controller, we are defined for the hello request, right? So now let's try to hit /hello. You see that whatever HTML we had created, now it is rendering. So remember in the hello.html, we had added welcome to bank, and this is rendered using timeleaf, right? So the same thing is now being displayed over here. And even you can add some styles to it using CSS. So I remember I said CSS is what gives all the cosmetic appearance to your website. So what I can do, I can just give style equals to color red, and when I save it and just kind of restart my application, because remember that whenever you make any change to your application, either it has to restart, or you can also add your Spring debug tool dependency to your project when you select the dependencies, so that it auto restarts in the background for you. Okay, so I'm just quickly restarting my server. Okay, so it has restarted. Let me come and just refresh. You now see this text has turned red, right? So this is how you kind of add the cosmetic values. And in case if you people are not familiar with HTML, or you don't really know much about HTML, CSS, how to style, there is this open source tutorials available called as W3 Schools. It is one of the most famous, and it was the starting point for many web developers. So whenever you want to learn anything about HTML, CSS, and JavaScript, I strongly recommend that you first go through this website, because these are itself are big courses in themselves. So we won't be really able to go into the basics of this. So I recommend that if you are not familiar with HTML, CSS, JavaScript, please go through this website so that you get a basic understanding of how CSS works. So what we did now with CSS is we just added the colors to it. So that's what something you can also add background colors and do stuff like that. So just to show you how it works, I had done this, right? So far so good. We have created a basic HTML page, and whenever the user hits /hello, we are showing them this. Now the next thing that we have to do is, and before we proceed, I also will like to show you the H2 console. So what I'll do is I'll just remove the /hello, and I will put h2/console. So remember, this is the management application for our database. So the admin is user is admin, password is pass, because that's what we had given in our application.properties. And when you connect inside, and here you see that the two database got created, which is wrong. So which means that in our data.sql file, we had made a typo. Yeah. So just ensure that you update your data.sql file. We missed to add s over here. So the table name is customers and not customer. Okay. So I'll just save it, and I'll just quickly restart my application once, so that the new table and data gets created properly. So just ensure that in your data.sql, you have this customers, the name is customers and not customer. And similarly, even below in the insert statement, just ensure that all your table name is customers. Okay. And why this is important? Because if you check over here, right, the repository that we create, here we say the model name is customers, and even in the model, we say the name of our table is customers. So that's why ensure that the same name is created for the database as well. And while we're creating the sample application or the sample SQL, we need to add this. That's why you see there are two tables created, right? So just ensure that all the insert queries has the table name as customers, and here also you create the table as customers. Okay. And even at the top, replace the customer as customers. And now just ensure you kill the server and just restart the application once. I'll just quickly show you what we are going to do next, right? Okay, the application started. I'll just go and refresh my S2 console. So since we restarted, it'll again ask me for password. Just give pass as the password, PSS. And now you see just one table exists. So now we ensure that for you also only one table exists with the name customers. So I'll just click on this. Automatically the SQL query gets generated. Select star from customers. And if I click on run, you see that whatever table data we inserted, the same data is now coming over here as well. So what we are going to do next is, in the next session, we are going to map or show the same data in my website. Okay. So the same actual data which is present in the database, I want to rather show it on my application as well. So when someone hits my localhost 4000, right, I want him or her to see the list of all the customers which is present in my database. Okay. So that is what we are going to do in the next session. So we have come to end of this session right now, and looking forward to see you in the next session. Thank you. Hello everyone, and welcome back to this fourth and final session of this 10th week. So in this session, we will now be creating the dashboard for showing the list of all our customers using the Spring MVC, which we discussed in the previous session end. So as discussed, the plan is we are going to take the data which is present in the database, read it from the database and show it on the front end using our HTML template, right? So the first thing which we have to do is before creating or proceeding with the controller changes, let's create the sample HTML which is now going to show our data. Okay, so for that, what I will do is, and since I'm expecting my user to just hit localhost :4000 to show the data, I'm going to create the template or create the HTML with the name of index.html. So what is index.html? Whenever there is no HTML file or no kind of URL specified, your Spring MVC will by default try to show you the index.html. Okay, so we will name this file as index.html, finish. And once you open index.html, the title, I'll just change it to customer details. And inside the body, now I'll just write the code or syntax for how to create a simple HTML or the simple table using HTML. Okay. And before we do that, so before we do the table creation part, I'll just quickly show you how we normally create a HTML table. So for that, I've just come to w3school/HTML. So over here on the left, you'll have something called as the HTML tables. So this is what a sample table looks like. You have a table tag, then you have the header part, and then you have the body part. Okay, so this is what is something we are also going to do. Okay, so let's try to create our HTML table. So there's no right or wrong way for this. So we are just going to kind of follow the standard template. Okay, but if you see some other examples in the internet or somewhere which uses a different approach of creating tables, so don't get confused. So a table can either be created with a table tag followed by the th tag and tr tag, or you can directly go about creating the table using the th and tr tag. Okay, so it's just about the implementation part. So let me first create maybe the div or a container which is going to hold our table. So div is nothing but just kind of a logical container which is going to hold our table. Okay, and maybe the name of this div, I can just give it as table container. Okay, so this is just for our reference. After this, we'll start creating the table. So the first tag is table, and even you can give some class name to your table. So basically a class is nothing but it is kind of a placeholder or an identifier for that particular content in your HTML. So if I want to style something, I can directly style this container if I know either the ID or the class of this particular container. Okay, so the difference between ID and class is, if you give ID to a div, it means that it only applies to this particular div. But if I give a class, I can have multiple containers having the same name. Okay, so it is similar to, I'll just give you example. So one student can have one roll number, so that becomes kind of ID, right? But many students can be part of the same class or same division, so that is something like a class. Okay, so first I have created and always remember in HTML, whenever you open a tag, for most of the tag you also have to close it, and the closing tag is followed by prefixed by a slash. Okay, so first I add the table, then I had my t head, then I have a TR. So TR is nothing but it just denotes that now a row is going to start, and now in a row I have to define what are the columns I have. So the first column I will just mark it with a TH. Okay, and here I will say the column name is. So before that, let's quickly get into our data SQL file and see what are the columns we have. So first is the customer ID, then name, then mobile number, then email ID, and then created date. So we will follow the same order. Okay, so I'll come back to my HTML. So for my TH, I'll just give the name of this header as customer ID, close the TH. After that, one more column. This column will be the customer name. So I'll just give it as name. So either you give customer name, customer ID, or just give as ID customer. So I'll just give it as ID, customer name. So since we know that this is all about customers, so the next after the name we saw that it had mobile number. So mobile number. After that, we know it had email ID. So, and finally we had the created date, or we'll just change this created date name, and the UI will show it as added on. Okay, that's it. So this what we have done right now is, and after this, just ensure you close your TR and also your T head. Okay. So basically we have now defined the header for our table. So the header which will be shown on the top of the table, now we have defined that. Okay. Next, we have to define the body or individual data of our table. So for that, I will first start it with a tbody tag. So this means that I'm defining the body or the main data of my table. So the same syntax follows. So first I need a tr tag, and I will close this tr tag. But this is where the magic happens now. So now I don't really know, like, this data is dynamic, right? So what I'm basically going to do is, using my customers repository and model, I'm going to fetch all this data, and in my customers controller, I'm going to have it as a list, right? But now here I don't want to manually, like, add that many tags, because obviously I don't know how many customers are present in my database. And obviously I also don't know what is the data that's going to come. So what I'll do is, I will just give some special magic or some special syntax over here, where I will tell using time leaf to my HTML, like, these map the data that is coming and create your own HTML. Okay. So let's see how it happens in real time. So just see what we have created over here, right? So under TR, we have a lot of TH tags, right? So the first thing what I will do is, so the first thing that we need to do is, under TR, I need to create individual TH tags, right? So the first thing that I will do is, under my TR, so I will tell this is, and this is where the time leaf syntax comes in, right? So when I say time leaf is closer to HTML language, this is what I meant. So you can write your normal HTML syntax, and wherever you need to map it with the data which is coming from your controller, here is where you just use the time leaf syntax. So here I say each. Okay, first write the syntax, and then we'll understand what it is doing. Okay, so I will say maybe record so of dollar customers. Okay, so first let me write it so it becomes easy for you to understand what's happening. So this is just the simple kind of time leaf syntax. So first let me write it, and then it will become easier for you, or what we are doing. Okay, and here I'm just going to do the same stuff. So what I'm going to do is, I'm just going to copy all this four, or rather what I'll do is, I'll just, since this is going to be a body, we don't have a th tag, but rather we'll have a td tag. Okay, so I'll just say td. So what I'll do is, since this is my body, I don't really need a th tag. I can just use a tr tag. So tr just means that it is going to be a individual row, or sorry, rather it will be a td tag, which means that is the actual tag, actual row, which is actual column which is having the data. Okay, so this is just simple HTML stuff. Let me just quickly define all this stuff. So first td, this is all standard time leaf syntax. Okay, this is not HTML, the stuff that I'm writing right now, all that dollars and all that square brackets. But you will understand quickly what we are doing once you get a hang of it. So first, so since the first column is going to give me the customer ID, right? So I'll just put a double square bracket, and whenever I'm going to use the variable or data, I'll just mark it with the dollar, meaning that I have to write a data over here, and the data or the variable is always annotated with this curly braces. And record means individual record from the customers, right? Here you can give any variable name but just for the reference or understanding, I'm just giving it as record. So whatever is the current record which is returned from the SQL server or from the S2 server, I'm going to print the customer ID for this particular TD. Okay. And similarly, I'll just have, so how many columns do we have? 1, 2, 3, 4 after ID, right? So I'll just paste it 4 times. And for the rest of the columns, for the rest of the row columns, I'll just change the name. So for name, it will be name. For here, it will be mobile number. Here, it will be email ID. And here, it will be created date. That how I got this name. So as I said, if you come to your repository, if you come to your models, so here we have defined what is the naming which I'm going to use, what is the mapping we are going to use for each column name. So created date, email ID, mobile number, name, and customer ID. So the same thing I have now defined in my index.html. Okay. So with that, we are good to go. So just ensure that, whatever you have opened so far, you just close it. So just quickly verify if you have closed all the open tags, and we see an error over here. So let's quickly check what is the problem. Okay, so since we are using time leaf, your Eclipse is not able to make out what is this, because this is a time leaf syntax. So that's why you're just seeing this warning, but forget it. Now let's try to understand what we have written. Okay, so as I told you before, so a standard HTML will be looking something like this, right? You have a row, and inside that you have a column. Basically what happens is, you first define a row, that is this row, and inside this row you have each TD represents one single column. So the first TD has email, second is Tobias, and third is Linus, right? So similarly what we have done is, we have defined now 5 columns. So the first is ID, second is name, third is mobile number, fourth is email ID, and fifth is created date. So what we are telling to our HTML using time leaf is, in my HTML, now what you do is, you will find something called as a variable called customers, which you'll be getting from my controller. Now what you do is, when each means we are telling that it is an iterative database, it is an iterative data structure like a list or iterable. So you will have a number of records in this. So take each of the record in this customers, and for each of the record, for the first TD, you just print the customer ID. For the second TD, print the name. Third TD, print the mobile number. Fourth TD, print the email ID, and then they created it. And again, when you find next record, do the same thing. So this way, you will be creating multiple rows, which each of the columns having the separate data coming from the customer's data. Okay. So this is what we have done right now. So finally, what we have to now do is we have to send this customer's data to the index.html whenever the customer is accessing our website. Okay. So that is also quite straightforward. So what I will do is I'll just define the same get mapping. And this time I'm not giving any URL. I'll just give slash, which means by default, this is what will get rendered. Okay. When the user is not passing any URL or routes in the API or in the browser address. So I'll then define my method. So remember, always the return type of this method is string, because we are not actually returning the HTML. We are just returning the name of the HTML file which has to be rendered. So here I would say maybe homepage, because this is what is by default sent. And remember that this method has an access to the model. So I would say model M, or you can also give the name as model. Anything is fine. Okay. So what it basically means is this model helps us to kind of access our HTML and set any attributes or anything or any such properties into our HTML. Okay. So now what I will do is first, as I said, we have to first get the list of all customers and then pass it over here. So getting the list is very simple since we have already created the repository and all that stuff. So all I need to do is will define an iterable. Why iterable? Because I'm going to get a list of all customers. So I'm going to get a list of all customers, give this variable name as customers. And how can I get this customer list? I just do customer repository dot find all. That's it. So just let me quickly import this model and this repository. So it is actually customers repository. Okay. And also we have to import our model. And once you do that, so the next thing we have to do is now we have to pass this variable to our HTML, right? And for that is where this model will help us. So all I will do is model dot add attributes. Okay. So it should just be add attribute. Okay. And inside this, I will now send my attribute name. Okay. And the name of that attribute is customers, which is nothing but this placeholder which we have defined over here. So remember I said we are going to pass a data. So this customers is nothing but that attribute name. So all I'm doing is I am mapping this customers with the value of customers that I'm going to get from here from my database. Okay. So after this, I just give comma customers. And finally, I will just return my index.html. And so what this means is, okay, we have a issue over here. So actually we don't require this attribute name again. So that's the typo. Yeah, so the error is gone. So that's it, right? So just to revise what we have done. So we say whenever a user is hitting our URLs with no extra route specified. So I'm just kind of what I'm doing is I'll first make a call to my customers database, and find all just means that find all the records. So I just retrieve all the customer data that is present in my repository. And once I get that, I just assign it to this customer variable. And now what I do is this model is nothing but it gives me access to my HTML which I have defined, right? So whatever I return over here, this HTML, it will give me an access to all the model over here. So now what I'm doing is I'm telling that in my model, you add an attribute of the name customers and assign it this value of customers. Okay. So now what happens is wherever in my HTML, I have defined this word, this placeholder of customer. Now actually that customer data or list will get injected. And since we are doing here TD or each record, what it will do is it will iterate every record. So in our case, we have 3 customer record. So for every record, it will take 1 record. Then it will add these 5 columns, come to the second record, again add these 5 columns, so on and so forth, right? For every row. So this how the mapping happens. So let's see if this is working fine. So I'll just kind of stop my server once and I will just run it again. Okay, so the server is up. Let's open the localhost :4000. At this time, we are not specifying any extra routes because we want this customer to act as our default page, right? So it seems that we have some error. It is not loading properly. So let's quickly check what is the issue. So it is telling that the customer ID cannot be found. So this usually means that the record, this line that is getting passed over here is not working properly. So not an issue. We'll just quickly debug this. Just give me a minute. I'll quickly find what was the issue. Okay, so there was a small typo. I managed to find it. So here, as per the standard Thibleaf template, we should have a TH as over here. It should not be TD. So just replace this H with D. And after that, what you need to do is just on the safer side, just right click on your customers, go to go to the Maven and just update your project once. So this is just to ensure that there are no caches and other stuff. So just give OK. So it will just kind of just update your project once. And after that, now you can just go over here, click as run as Java application. So now once the server is up, we see that it is working fine. Okay, so this is how you kind of create the table. So a few of you might have a question like, what if I want to kind of style this table and make it a bit more presentable? Yes, you can do that. So for that, what we need to do is using CSS. All I need to do is inside my head tag, I just need to add style tag. Okay, and I'll just define some basic style for my table. So this is my selector for table tag. So wherever I have my table tag, I will say border collapse. So this will just collapse all the borders and width 100%, meaning my table will span my entire browser width or my window width. After that, for TD and TH tags, I would say border is 1 pixel solid. Maybe I'll just give it gray, and I'll just align all my text to left, and I will also give a nice little padding. So padding is nothing but just the space between the text and the borders. And so don't worry if you're not able to follow all the CSS syntax. So as I said, if you just if you just come to W3 schools and go to the CSS part, so here you can just find out what each of these means what we are doing right now. So say for example, when I say padding, right? So just come and search here for padding. So you see here there is padding. So this is what padding is all about, right? So between the border and inside your element, what is the space? So in case like, here I just make the padding to 7. So what happens is my content will now just have 7 pixels of space between all the borders, right? And similarly, if I just do text align right, so it will just from the left alignment, it will take it to right alignment. So these are the kind of stuff which we can do with CSS. So it's not possible to teach the entire CSS in this course. It is out of scope. So I'm just using a few of the CSS, to just to make our table a bit more presentable. So just follow along. You will understand what we are doing. So I'm just currently adding borders to each of my columns and rows. And after that, I will also add a bit more styling. So wherein I will say inside my T body TR, and for every odd row. Okay, so odd row means like first row, third row, fifth row, so on. I will just change the background color. Okay, I'll just make my table have alternating row colors. So I will say background color, and I can give some color value. So either it can be a hex value or it can be the actual color name. So what if I just give gray? Okay, so that's it. So once I just stop my server and just start it again. Okay, my server has started. So I'll just close all this W3 school. And now if I just come and refresh my website, you see we have added some styling, right? And as I added alternate colors, so that's why in my T body, the first second row, alternating row has a different color. And if you want to give a different color, not an issue. So you can just inspect it from here. Say you want to give some other color, right? So maybe you want to give red, or you can just select from here. So what I can do is to this row, right? Yeah. So to this row, I'll just come here and I will take I'll just see which color. So if this color looks good, Alice Blue is the color name. So what I will do is I'll just come to my code over here and I will say instead of gray, Alice Blue. That's it. So if I just stop my server, start it again, that's it. So it will get updated. So So I hope you got a gist of what we have done. So basically, this is the same data which is present in our database. So if you want, you can also verify it. So if you come to our data.sql file, you'll see here that I have skill link 2 3, and even here you can verify. So current will have current date, one will be minus 10 day, meaning 10 days before, and the third user was added 100 days before. So if I come here to my UI and see and just refresh it once, so ensure that the data is up to date. So now you see that, so today, as on recording, the date is 28th of September. So I see that. After that, 10 days before is 18th. So I see that. And 100 days before, 6th or 20th of June, I see that as well. So this means that, my data is properly getting fetched from the backend and it is being shown over here. Right. So with that, we have now seen how MVC works, and also we saw how we can actually fetch the data from the backend and kind of show it on the UI. So similarly, even we can also edit and delete and perform all that operations. So that also follows the similar lines. So here in our customer controller, so what we have done so far is we have just fetched it. So even if you want to write it back based on what the customer does, you can do a similar kind of stuff. But since it will take some time to explain and it's also quite vast, we are not going to touch it as part of this week. So with that, we have come to end of this week and also to the end of this course. So let's quickly summarize what we have learned in this week. So we saw the overview of components of any web application. We saw what is front end, what is back end, what is database, how we can create each of these, what are the technologies used. We also saw the summary of microservices exercise that we performed. So we saw how we started with the development of accounts and cards microservices, how we added the config server, gateway server, Eureka server, how we added resiliency. So all that stuff we tried of kind of did a summary overlook of it. Then we saw what is the overview of Spring MVC. Then we saw what is the Spring MVC architecture. Then we saw how we can configure the Spring Boot for the Spring MVC. So we went to start.spring.io, downloaded the Spring application, and we configured it. And finally, we also created our own Spring Boot MVC application, wherein I first showed you how we can create static pages, and also we created a sample dashboard page where we fetched the data from the backend and showed it on the UI. So with that, we have completed this course. I really thank you for staying all along and learning with me. It was a pleasure having to do this course with you guys. Thank you and wish you all the best in your learning journey.
Congratulations on completing Cryo.do's ultimate guide to microservices using Java, Spring, and Docker. And your hard work has paid off. If you found this course helpful, please like and share this video. Don't forget to leave your questions and feedback in the comment section, and we'll get back to you as soon as possible. Make sure to subscribe to our YouTube channel for updates on more courses like this one, and check out our website to explore the premium programs we offer. Until next time, goodbye and happy learning.